Great. I had so
Thank
much
you,
time
Wendy.
last week.
And hello, Clark.
Hello.
Dr.
I'm here.
Chapman, you're here tonight, and it's
Hi.
so good to have you here,
Well, so good to see you, David.
David.
Hi, Scott. Hi, Dave. And
Hello.
I'm not sure, Wendy?
That's
Wendy is right here as well.
Right.
She's
Hi,
smiling.
good to
Hi,
see
Wendy.
you.
Yeah, Wendy says hi. And I mean, we're going to have a good night tonight, but we're putting Stella, we're putting you on first after me because it's late on the East Coast.
It's okay. I brought my tea. So I'm good.
Brush your teeth.
Yeah, let's have tea together. Why not, right?
Yeah.
It's nice. It's nice. It's nice.
Our live, our mics are hot, but live right now. When I say that, everybody gets really quiet.
We'll clean up the jokes. Yeah.
Be Wright coming on. Hello, Joe Wright.
Good evening. Can you hear me?
Yes, I can hear you just well.
All right. Hi, Wendy.
And then Wendy's saying, waving, she's waving hello. You'll be able to hear her when it's her time to speak.
Oh my goodness, we're hosting Galileo. What a rare privilege.
So, it didn't come up with my name. Okay, I need to change
Hmm.
that. So that's what I use at school with the kids.
You
Or
can stay on
something
as
else.
Galileo. That's all right.
Well, I do like to call myself the gentleman astronomer.
You'll have to grow a bit of a beard, I'm afraid.
Yeah, and drink more wine.
And we'll have to put some shackles on your hands and introduce you to John Milton. Oh, my goodness.
But I could stay home and work.
Yeah.
Yeah. Yeah. Galileo was the first at-home worker.
There's Scott.
How you doing?
Just fine. How's things down there?
It's good. It's good. I think we might have a storm coming, though.
So do we.
Yeah.
I think it's a pretty good system.
Let's see. We're starting to carry weather stations and stuff. So yesterday I hooked up a weather station that's connected to the internet. So you just log into this webpage and you can see your own private home weather. You know, just kind of.
And I enjoy Mr. Eicher's family history that he posts on Facebook.
Thank you. Thank you very much.
Oh, Dave, we need to connect on Facebook. I didn't know you were there. Why didn't I
Yeah.
think about it? Really?
Absolutely. Yes. We certainly shall.
Absolutely. Libby, so lovely to see you again.
Hello. My internet just disconnected, so I had to reboot everything.
Well, we hear you pretty well and see you very well right now, Libby, in the stars.
I'm getting a pretty good.
And you're going to be on pretty early tonight. In fact, right after Dr. Kafka.
When they say that your head is in the clouds, your head is in the nebular clouds, Libby, tonight. Huh?
Right smack in the middle of the Milky Way.
Yeah.
She's out there. I'm loving it. And I'm loving it that it's the XXXX star party. That's
Pretty soon, Scott, you're going to outdo the Roman emperors if you keep doing these.
I know, right? Isn't that cool?
I don't know how many star parties Roman emperors actually had. They had a couple, though.
Well, we can always claim that the emperors of the modern world are here.
Yeah.
Ha
Oh, that was nice. Chris MP just sent an email back. He says, "It was fun. You're an easy and expert host." That was very nice.
That's quite a
He's
compliment.
exactly right.
He's exactly
Yeah.
right. And Clark, I feel like I'm in Rancho Europa right now, sitting
Well-
here talking with you this way.
Well, you sort of are in Rancho Europa, and I'm finishing up my dinner here. I'm not sure how this screen sharing's gonna work. What do I do to make that work when my time comes up?
Scotty,
Okay, so
Scotty's going to have to explain that to you.
in Zoom, you can see on your if you put your mouse over the video where you see everybody, okay?
Yeah.
You're going to see a green button down at the bottom, and it says,
Yeah, I see that.
see that? And if you click on that,
It says you cannot start screen share while the other.
I'm going to let you do it anyways, okay? We got just about 5 minutes here. So try it, hit share screen.
Okay.
And we'll see when you do share. And so, yeah, there you go.
That's it.
You are.
And so then I would do slideshow.
Yeah, you do that, and it'll take it full screen. And it looks like we're looking at your desktop right now. Looks good.
Does that look like the first slide?
Planet
It
Mercury.
certainly does, Clark. You're
Yeah.
a quick learner. You're a quick study.
Okay, good. So I stop screen sharing by doing what?
Okay, so go back up to the top there.
Oh, stop share. Okay, I see it.
Uh-huh.
There.
There's another way to stop sharing. You can take your laptop and toss it out the window. That will stop the sharing as well also.
That's more
That would-
expensive though. Yeah.
Definitely solve the
Slightly.
problem. So with that in mind, please smile. I'm taking an e-selfie. Oh, come on. Here we are.
Here we
that's
are
what-
getting ready, getting to know each other, getting comfortable with our group. And I think we're going to have a fun evening and I'm going to try to keep on the schedule as much as I can tonight.
Oh, Dave, I'm so ready to hijack your schedule because you asked for it. He said, why don't you talk about this and then talk about that? I'm like, how many nights are you
This
giving
and
me?
that. The AAVSO is a very precious organization to me. It's like family.
But people like you is making this organization special.
Well, it's going to be fun to hear about it from the boss.
Maybe I should go and get our observers coming. Oh my goodness, I was actually exchanging emails with a friend, and I have to admit I was a little bit late on sending him something that I promised to send him. And I'm like, please forgive me. Over the last 3 days, 3 novae and 1 eclipse in binary happened. So really, I was busy. And he was like, yeah, I get it. Okay.
Hello, Terry. Terry's joined us.
Hi,
Terry
Terry.
has joined
Hi,
us.
Terry.
And
Hi. How's everybody doing?
we're good. We're doing
Good.
well. Glad you're here with us.
Thank you. Glad to be
And,
here.
And Stella, I wanted to say that your favorite star the other night threatened to get faint again, but it was just haze in the sky.
I know, right?
So it was not the actual star Betelgeuse fading again.
We're going to talk about that at a different time.
Yeah, that'll be a different time.
Yeah. But depending on the day you ask me, it's a different favorite star.
Yeah.
There's so much going on, so much, and such an exciting time to be a part of this amazing community. Seriously, we're having fun. We really are. And we're having serious fun. We're serious about work and we're serious about fun. So that's what makes everything exciting.
Yeah,
Yeah.
It's
it
a good
really
philosophy.
does.
Means party hard and play hard, right?
Yeah.
Exactly.
Wait a minute. If you're partying and playing, work hard and party. Never mind.
Scott, you just confuse everybody.
I'm anxious to know what happens when your countdown clock reaches 0. Does the Earth explode or something?
Some Earth somewhere does, yes. Yeah. It's randomized, you know. It's like a big surprise. Okay. Who do we got watching here? We've got Cameron Gillis was the first one to log in here. And then we got Harold Locke. Good evening to all of the GSP tonight. The rawer, the better. The rawer. That's right. James the Astrophotography. Good evening, everybody. Matthew Walsh says hello. I think Matthew, I'm not sure if Matthew's new or not, but welcome to Global Star Party. Mike Wiesner, hi from cloudy southern Arizona. Book Davies says okie dokie. Yep, clouds, wind, and dampness here. And we got this Stella Kafka is on there too. How can she be there? And Mike Wiesner says my audio's low again.
Who's that
How's
person,
that, Mike?
really?
What's that?
Who's that person?
I don't know.
Mike
It's a random
Wiesner is
hacker.
someone I know. It is, at least from my part of southern Arizona, it's just partly cloudy, a lot of cleared right now. But
Oh, okay. Kevin Habhager says, hello, everybody. I was able to view my first triple star last Saturday night. Congratulations. Very cool.
Which one was it?
good question.
Kevin, you have to tell us which one it was.
Yeah.
No pressure. We just have a team of expert astronomers here to check it out.
Absolutely. And we're eager to just go out and observe it right now. So
We can take a 5-minute break. Yeah. At the start of the program. Yeah.
That's right. Rob Duke says, good evening from Seaforth, Ontario.
hello,
And
Terry.
hello, Jason.
Hello.
Welcome.
Yeah, thank
Hello,
you.
Ontario.
So how can you tell how many people are watching live right now?
That's a difficult one because we simulcast, and we also simulcast onto a couple of websites where we get no numbers. We are on the homepage of cloudynights.com. So we want to thank the people for Cloudy Nights allow us to do that, which is really cool. I know that Ontario Telescope likes to broadcast us, so we thank him for that. And then we are on Facebook on a couple of pages. We're on maybe 3 pages on Facebook. We're on YouTube, and then we're on Twitch, and then we're on Twitter. And so I wish there was like a little counter that you could see everybody all at once. Part of it that you can see is the people who are not just watching, because there's a lot of people who just watch and they don't chat with us. But when you see active chatting going on, you can be sure there's a lot of people, watching out there too. And we love that. So we're down to about 1:20 right now.
I hope the Earth doesn't blow up. Really quite concerned about that.
I would put a damper on the 40th Global Star Party.
Yeah, I think so.
It was my understanding that we had 5 to 6 billion years left before Earth was in big trouble.
Or a minute.
Who's counting?
57 seconds. Yeah.
If you need an insurance policy, see me.
And I hope literally to see you and Rita pretty soon in Arizona, Joe.
Well, we are missing it.
I bet you are.
We're not sure. But one way or the other, maybe we'll still just come down.
That would be nice.
I'm having withdrawal symptoms from Tucson, especially with the winter we've had here.
You in the audience, please, if you like this outreach activity that we do, please like, share, subscribe, hit the little bell, all those things.
Going pretty early.
Well, hello, everybody out there. You are with us on the 40th, I'm so happy to say this, the 40th Global Star Party with our special guest host, David H. Levy. And with us tonight, you can see just some of the speakers. There'll be more coming on later, but of course, there's David Eicher with us, David Levy, of course, who's going to be our introducing each person. Clark Chapman, it's my pleasure to meet you, Clark. It's great. Wendy Wallach-Levy, David's wife, is here with us. This is wonderful. Stella Kafka from the AAVSO. Joseph Wright is with us. Of course, Libby and the Stars. Terry Mann from the Astronomical League. Jason Gonzell, the Vast Reaches, and Adrian Bradley. How you doing, everybody? Yep.
Great to be here.
Yeah.
Doing good. Good to be here.
Well, David Levy and I have had a long-term friendship. Spans over a few decades now, and I've had the privilege to go observing with him. I've had the privilege to do star parties with him, to conspire on doing outreach activities. We built a telescope together. Gosh, I think, if you ever had an astronomy friend and you wanted to do it all, I think David and I have almost done it all, so it's been wonderful. It's been great to watch my friend discover comets and asteroids and to be recognized for all the great things he's done. His articles have been fascinating. His insight into people that he knows has been amazing. His work with biographies for Clyde Tombaugh, and I think you did Bach's biography. I would have loved to have met him, but through David, the entire astronomical community has been able to learn more about the people that are the movers and shakers in our community, and he's definitely one of them himself. David, thank you very much for being our special guest host, and I'm going to turn over the whole thing over to you.
Well, thanks.
Did we lose you, David? I think we just lost David.
We lost David.
And possibly Wendy.
Yeah, which doesn't surprise me if something happened both of their lines. Hopefully the glitch will resolve itself very soon.
You don't want it too small because maybe it doesn't want to go on trails.
Huh. Okay.
So maybe a medium-sized dog. And
Yep.
Some apartments have a
That's a
fire.
first. Well, it's not a first. I've done it myself, so. Okay, audience, please bear with us for a minute here. We're going to get things going.
To follow the rules. And, find out what the weight limit is. And then proceed with finding a dog that would be in that weight limit. I mean, I don't think they're going to weigh the dog, but you want to try and stay within that range. Yeah.
Hello.
Yeah, I mean, that's awesome. Because it's screened in, so he's not going to fall through the rails.
Huh, the phone is not.
He can sit outside, enjoy the sunlight. Dog that can be out there.
Hello.
Oh, we're back in, are we?
Yeah, I hear you. Okay, we're back.
We're back.
All right, we're
Maybe
back.
the second try will be a little bit better. Can everybody hear me?
Yes. Yes.
Okay, good. There's always a good place to start when the engines turn on and then shut down like Gemini 6. But then a few days later, they try it again and maybe this time it'll work. Anyway, I always begin these start parties with a poetic quotation, and I wanted to expand the reach a tiny little bit. And so I took my book of Victorian poems, the one I used when I was at Acadia so long ago, and I opened it up at random to any page. And I bumped into this delight by Matthew Arnold, and it's called Self-Dependence. And Wendy, you might enjoy this as someone as non-dependent, as dependent as I am. Well, we'll just see if this will work. And it kind of says something about those of us who are trying to look out for ourselves a little bit. Weary of myself and sick of asking what I am and what I ought to be, at this vessel's prow I stand, which bears me forwards, o'er the starlit sea. From the intense, clear, star-sown vault of heaven, o'er the lit sea's unquiet way in the rustling night air, came the answer, wouldst thou be as these are, live as they? O airborne voice, long since severely clear, a cry like thine in my own heart I hear, resolve to be thyself, and know that he or she who finds himself or herself loses that misery. Thank you. And on that note, I am now going to introduce one of my favorite people. Stella Kafka is the current director of the AAVSO. And the AAVSO is really not an organization to me, it's family. It is a place where I have made friends that have lasted a lifetime. I joined the AAVSO during the days of Margaret Mayall and matured hopefully a little bit in the time of Janet Maddie. And Janet is the one that Wendy and I met here in Tucson just before she became ill. But had that not happened, she would probably still be the AAVSO director. But if she were here right now, I think she would say, oh no, I have to turn the wheels of the organization over to Stella Kafka, who is so good and so wonderful as a director of the AAVSO. And I would like Stella right now to take over and talk to us a little bit about this beloved organization. Stella, over to you.
Dave, thank you so much. And you know something, when I started the AAVSO, I really realized that I had really big shoes to fill. It was not an easy task, and was definitely something that was really overwhelming, because when you're talking to legends and when you are taking over from legends, everything can be very overwhelming. So today, what I would like to talk about are two different aspects, but they come together under a very wide umbrella that has to do with this amazing organization. When Dave Levy actually calls you and tells you, listen, I want to hear more about the women of the AAVSO, then you never say no. You say, absolutely. Last time I was here, last week, we talked about women in science. And actually, not only that, literally the hidden figures in science, highlighting some of the amazing individuals who actually push the borders of science forward to boldly go and enabled scientific advances such as the Wi-Fi, such as computers and programming that we know right now. But let me focus a little bit on the AAVSO, and I would like to start with the same quote that I started last time. We are standing on the shoulders of giants. If I have seen further, it is by standing on the shoulder of giants. And that is only Newton's quote. This quote actually is known since the 12th century, way before Newton. And this is one of the depictions, the understanding of the time of what that meant. This is actually derived from Greek mythology. I am Greek, so I can actually make references of that. This is the blind giant Orion carried his servant Sedalion on his shoulders to act as the giant's eyes. And it demonstrates the main idea of the quote, that by using the knowledge, understanding, and wisdom of major thinkers and accomplished leaders before us, we managed to make progress ourselves and push whatever is good to making it better forward. So today I would like to start by introducing the AAVSO to you and discuss some of the giants of the AAVSO, some of the influential women leaders without which we wouldn't be here. And with a disclaimer that this is only a tiny sample of the female intellect that has made extraordinary impact on the AAVSO over time. And maybe in the future, I can come up and have like an hour to myself where I can actually talk about the rest of them. I would like to start by a short history of the AAVSO. You know, the AAVSO has been around for 110 years now. And for that long history, the association has had just a handful of directors. Actually, the founders were staff of the Harvard observatories, and they were called recorders. In total, we've had just 5 directors in our history, 4 of which were women. So today, I would like to start by introducing those giants of astronomy, those absolutely amazing female leaders of the AAVSO that actually made an impact and again, made the AAVSO what we know. And they had an impact of the organization to make it what I took over and pushed into the 21st century. And then I can tell you a little bit more of the AAVSO in the 21st century. And I would like to start with Margaret Mayall, the Iron Lady of the AAVSO. Margaret actually earned her a master's in astronomy from Radcliffe College at a time where women were not allowed to actually get a PhD from Harvard University. Radcliffe College was the associated university college where women were allowed to get some kind of a degree. That was back in 1928. And then she actually spent her senior year during her studies at Harvard Observatory working with Annie J. Cannon and Harlow Shapley, who was the director of the observatory. After graduating with a master's, she continued her work with Annie Cannon on spectroscopic classification of stars. Now, early in the 1949, Harvard Observatory Director Harlow Shapley asked Mayall to consider taking over the position of the AAVSO recorder. That was actually the name of the director at the time, from Leon Campbell, who founded the association when he retired. She accepted the position. She was named a Pickering Memorial Astronomer, Harvard Observatory and AAVSO recorder. And actually, this title was changed later to become a director of the AAVSO. So she, in principle, Margaret Mayall was the first director of the AAVSO. When Shapley retired from the Harvard Observatory directorship in 1952, the AAVSO's position became to change a little bit. We changed directorship which at the Harvard Observatory, and they changed, in general, they changed direction. So in 1954, the new director, Donald Menzel, announced that the AAVSO we have to move out of the Harvard Observatory and that all its funding resources were discontinued. At that time, you can imagine a new organization that was just founded, an organization that depended very deeply on Harvard, could be in crisis. But Mayall actually was the person who decided that she is going to protect this organization and move it forward. She oversaw the transition of the AAVSO to an independent, nonprofit, scientific and educational association. And actually, as the association struggled through severe financial hardships because they had no financial support from Harvard anymore, Margaret Mayall worked without salary for a number of years to ensure the future of the AAVSO. She was truly an Iron Lady. During the critical early years of independence, she actively sought out new sources of funding from government and private donors. She communicated widely with the astronomical community to solicit both technical and moral support for the AAVSO from the professional astronomical community. She actually managed to establish an endowment fund to secure a much more solid financial footing for the AAVSO. And she expanded existing programs and committees and added new to ones that existed to attract a broader membership of the organization. She added more stars to the observing program and actually established a new system for correlating and publishing data for professional use. And back in 1967, before the computers and systems that we know right now, she introduced a modern data processing methods of the AAVSO with emphasis on machine computing and plotting for publication. Margaret Mayall was a director of the AAVSO for 24 years. She retired in 1973. And with that, she passed the baton to another Iron Lady of the AAVSO, Janet Maddy. Janet Maddy came in the US from Turkey, where she was born, to get her bachelor's in science. And then she became one of Dorrit Hoffleit's assistants at the Maria Mitchell Observatory in Nantucket in Massachusetts. And actually, when Margaret Mayall decided to retire, Janet was selected by the AAVSO Council in October of 1973 to succeed Margaret as the AAVSO director. Janet Maddy did not have a PhD at the time when she actually became a director, but in 1982, she earned her PhD in astronomy from Edge University in Izmir, Turkey. Janet Maddy was an AAVSO director for 30 years. And you know something, everyone I know knows Janet. She was a person who was very loved, exactly because she left a huge legacy behind her. She strove continuously to teach the global astronomical and educational communities about the vital contributions that amateur astronomers make to variable star astronomy. She was extremely passionate about the AAVSO and what it means for citizen scientists worldwide. Over and over again in her talks, she demonstrated how astronomers, educators, students could enhance their research through utilizing the talents of variable star observers, variable star observations, and the unique resources that the AAVSO offered. And actually, Janet's directorship took place during times of tremendous challenges and opportunities in astronomy. Some of those were the advent of satellite astronomy. Suddenly, we're looking at the universe through means outside the Earth, right? Evolution of computer technology that opened up new means for communication and data management. And not only that, instrumentation advances that gave amateur astronomers access to observing equipment and the resultant exponential growth of the size of the AAVSO International Database. She was strong and she managed to actually lead the AAVSO through all those changes. And actually, as Dave mentioned in his introduction, Janet would have been with us if it wasn't for health problems. She lost the battle against leukemia in 2004. You know, that was a time of crisis with the AAVSO. That was a time where we needed someone to step up and save the day. And there was another woman that actually helped move the AAVSO forward and became the link between two different directors, and kept the organization moving forward while it was in limbo without a figurehead. Come Elizabeth Wogan. Elizabeth Wogan started working at the AAVSO in the summer of 1974, fresh out of Smith College with a bachelor's in astronomy. She says her one-year position to process data, help with the journal of the AAVSO, and help the director with her international correspondence has turned into an extraordinary 40 years and counting with the AAVSO. Quoting Elizabeth, the interactions with the international astronomical and educational communities are stimulating, instructive, and rewarding. For what more could one ask? Elizabeth served as an interim director for 2 years, a position she held after Janet Maddy was taken ill in September 2003. As interim director, she was responsible for management of the AAVSO and its programs in conjunction with the organizational leadership of the AAVSO Executive Board and Council. She returned to her former position as a senior technical assistant when Arnie Hendon became the AAVSO director on March 1st, 2005. Her main area, Elizabeth actually is still working with her, and she's working now on the AAVSO International Database, quality control and data processing, interacting with observers on a variety of issues. So she's part of our active help desk, coordinating, observing campaigns and alerts, and serving as the associate editor of the Journal of the AAVSO. This is only a small sample of the leadership of the AAVSO. So if you want me to talk more about the women that actually made a difference, our board members, our observing section leaders, our professional astronomers who actually push the science of the AAVSO forward, our observers who are actually still working behind the scenes to actually make the AAVSO the wonderful organization that it is, I will need an hour. So this is perhaps a subject for a different time. But I just want to say that there has been a numerous of other extraordinary women who worked and are working in front and behind the scenes. Please don't forget the AAVSO staff that are actually right next to our observers, right next to our members nonstop. And it's actually a function for them. It's not a job. They have as a personal mission to improve the value of the AAVSO to its community and the impact of the observer's data to scientific discovery. The AAVSO today is an international organization. We started with a small group of individuals from the Harvard Observatory, and now we're all over the world. And actually, we serve a very diverse community. That means people with different needs, different priorities, different interests, different professional preparations, habit, and cultural background. We have individuals who are interested in using variable star data for the research projects. We work with educators all over the world who introduce astronomy to their students. We collaborate with a very dedicated group of volunteers. We attract individuals who are just interested in learning about advancements in science and what variable star astronomy is teaching us every single day. And of course, we work with observers, those who acquire data through the telescope, CCDs or DSLR cameras, and they share this information with the wider community through the AAVSO International Database. And what brings everybody together in this business is the love of the night sky and the wish to understand some of the most dynamic phenomena in the universe. So at the very core of our work and our program are variable stars, stars with whose brightness is changing with time, within timelines and time scales that we can observe. In other words, the stars we're interested in change with time on time scales of hours, days, months, something we can actually observe. And this is one of my favorite ways to demonstrate what variable stars look like. This is a little movie. It's actually a composite of 3 different images that were taken with digital means. So there was a person who actually pointed the camera at the part of the night sky. This is what we call a globular star cluster, stars that were born all together, and took 3 pictures back to back. and actually stuck them together and created a movie. And if you pay close attention to this movie, there's not much going on. I mean, stars are just lingering there, they're hanging out with all of us. But if you actually pay a really close attention, really, really, really close attention, can I say it again? You will see that there's some stars whose brightness is changing from frame to frame. They're blinking, right? Here's one. And here's another one. Oh, where are they? Here. And here's a third one. And actually, I could make a competition, as in how many variable stars whose brightness is changing, you can detect within like a minute. There are lots of them in there. These are the variable stars we're studying. This is what we mean by variable stars. And you know, the reason why those stars are changing in brightness is very diverse. There's a great variety of reasons. And all those changes reveal something about the nature and how the stars work. So for example, eclipsing binaries like these here are two stars together moving around the common center of mass. And as one is passing in front of the other, the collective light is dropping in a very characteristic manner that we're actually generating as a graph of tracking brightness variations with time. Spotted variables like our sun are those that have big star spots on the surface, which result in a change in brightness of the system as the star rotates and the spot comes in and out over land side. Pulsating stars whose size is changing with time. How awesome is that? So you have a big star that is increasing and decreasing in size. And that is actually depicted in the light curve of the stars, and the brightness changes with time. Supernovae, dramatic explosion of the universe. And these are just some of the examples of what the AAVSO observers are observing, collecting data in time. All this data is coming in the database. And actually, through that database, they become available to researchers all over the world. So, you know, it's not really difficult to take data on these kind of stars. It's not really difficult to observe their brightness variations. And the AAVSO is actually here to help you do this kind of business. So the bottom line, I guess, is that if you are interested and you have time and energy to participate, if you have a camera, a telescope, if you can take pretty pictures and enjoy exploring the night sky, you can certainly do something like that. Take data on those stars. And the AAVSO is here to provide you with the tools you need to participate. Just give me 5 more minutes. I would like to actually dedicate the rest of my presentation to tell you how we can help you not only learn more about variable stars, but also start your own observing program and join the conversation. We're here for you. Most of our resources are open source. They're free. They're on our web pages. So you're very welcome to use them, explore them, and actually be part of this, our own star party, right? So let's start from our observing sections, which are ways for you to learn more about all types of variable stars. So the AAVSO is observing. There's information about all types of objects, including exoplanets. Did you know that with a small 8-inch size telescope, you can actually take data on exoplanets? Haha, we can teach you that. We can talk about high energy targets. We can talk about the sun. The sun is a variable star. And also we are discussing information and instrumentation and equipment, which is of interest of some of our observers. There are people who really love building their own observatories. And this is something that we are discussing through our observing sections. Also, we are running a webinar series around our observing sections, around all kinds of subject matters that are of interest to the AAVSO community, such as key results of research that's coming out of our database. They're free. Please just sign up and enjoy learning about variable stars and how the AAVSO data is being used by the international community. And not only that, we have what we call how-to hours. These are a little bit different in the sense that we are teaching techniques of observing through those how-to hours. For example, this last Saturday, we were teaching how to acquire spectroscopy data on a budget. How cool is that? You don't really have to have a $30,000 observatory in order to take spectra of stars. You can just do it with your Dobsonian and with just a small grating in front of it. So everything is recorded on our YouTube channel. We also have training materials such as manuals for observations, choice online courses, an active peer mentoring program that would help and that helps enhance our observers' technical skills and provide advice from experts. So please join again the conversation. We would like to start learning different observing techniques. We also bring targets of interest in front of you. There are billions of stars in the night sky, billions. How do you know what to observe? It's tricky, isn't it? Well, we have a very active alert system. These are targets that are of immediate need of observing. These targets come from the professional astronomical community and they are requests for data. And we also help our observers to build their own observing filter throughout our target tool. And through that, you can get target information, observing cadence, when targets was observed last, notes on those targets, when you should acquire data, et cetera, et cetera. We have also tools, practical tools that facilitate observation. So for example, finding charts and appropriate comparison stars for star fields based on your equipment that would help you actually plan your observations. Online tools for data uploads. So you took your data, then what? Just upload them on the AAVSO database. Tools to visualize your data. These are light curve generator, which plots your data alongside data of other observers. And actually you can zoom in and out and actually check who else is observing that particular star at the same time that you have observed it, and all kinds of things. And of course, we have our super catalog, the variable star index, that includes the known information of more than 2 million variable objects right now. Yeah. So if you discover a new variable star, you can list it here and get credit for your discovery. And you should get credit for your discovery because it's a result of really hard work. You know something, I can talk for hours, but at this point, I just gave you a snapshot of what we do and what we offer to you. We live in a golden era of variable star astronomy. There are a multitude of space and Earth-based missions that aim at exploring the night sky, and they will produce a plethora of interesting stars to study and exoplanets to explore. And there are not enough professional telescopes to acquire the necessary follow-up data and that will actually help us solve those mysteries. It's like, you know, you're opening a book and you're reading an absolutely fascinating story, and then you're turning a page and that page is blank. How horrible is that? So you, parts of our community, are called to write the rest of the story based on your data, based on your observations, based on your collective intellects. The AAVSO is actually an essential collaborator for researchers worldwide. If not anything else, we need more observers to acquire and help analyze astronomical data. We strongly believe that a diverse and inclusive scientific citizen science workforce, an international citizen science workforce, draws from the widest range of backgrounds, perspectives, and experiences, and maximizes the creativity in science for the benefit of all. So if you want more information on our work and what we're offering, here's our webpage, aavso.org. If you have any questions, you want to come contact us, here's an email address. Please do become a member. We are supported by membership. So everything we're offering is for free to the whole community. And with that, I would like to thank you for your attention. Wish you clear skies. And I spoke too fast for me. And that's the end of my presentation. That's that.
Thank you so much, Stella. And home run. That was just wonderful. To take a subject like astrophysics and make it as fun as you do. I think the first time that I encountered you was you had just become director. And I had written to you, and you had wrote back to me and suggested that I write something about my own favorite variable star. And then one thing I learned years ago from Janet, is that if the director of AAVSO asks you to do something, the best thing to do is to drop whatever you're doing and do it. If you're driving your car, just pull over and do it. Whatever you're doing, and all kinds of things, just do it.
Oh,
I'm
now
not going
you're
to do
putting
any-
everybody in trouble. You know that, right? Because I'm going to start using the power.
Yes, you have the power.
Oh, God.
Now, I'm certainly not going to do a poem before every speaker, but I am going to do one before David right now. I'm going to do a little bit of a quote that I've done before here. This is from Leonard Cohen, and it's a slight rewriting of one of his songs. It's time to go outdoors tonight. The sky is dark. Some stars are bright. The Milky Way shines overhead. Now see, a comet rises in the east. With end to strife, it brings us peace and calls us to a cosmic hallelujah. 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 I don't think you want me to sing any more of that. But anyway, I've known Dave Eicher for a very long time, since he was a teenager, editing this little magazine, Deep Sky Monthly. And he has been now editor-in-chief of the world's biggest astronomy magazine, named Astronomy, headed out of Wisconsin, and has been extraordinarily successful over the years. David, over to you.
Thank you, David, very much. And boy, how do I follow that, and how do I follow Stella? Those were fantastic. Wow, what moments we've had on this star party already. Thank you, both of you, for that. Stella mentioned it in her talk. We're in a golden age of astronomy here in many ways, and I wanted to come back to talk about a little bit of astrophysics for a few more weeks now before going on to some other things. And tonight I thought I'd talk about dark matter. So I'm going to talk about the mystery of dark matter, despite the astonishing progress we're making in many, many areas at the most rapid rate ever in lots of areas of the subject we love. There are quite a few areas that remain a work in progress, shall we say. One of them is dark matter. We know in recent years, the most recent cosmological results from the Planck satellite, the composition of the universe as well as its age pretty well. It's about 69% dark energy, 26% dark matter, and 5% baryonic or ordinary matter, that is matter made of atoms and quarks. And remember that total 100% is mass and energy in the universe. You know, as Einstein and others taught us, that those are interconvertible forms of the same thing. So we know that about a quarter of the universe exists in the form of dark matter, but we really don't know what it is. Well, the story of dark matter is very interesting. Historically, about a decade after Hubble's discovery of the nature of galaxies, two astronomers began to find a lot of trouble in the behavior of galaxies with their observations. Still kind of called spiral nebulae or nebulae, but they were known to be galaxies, large systems of stars. The first was the Dutch astronomer Jan Oort, who became very well known, of course, for the shell of a couple trillion cometary nuclei. David has added our knowledge on a few of those by discovering them in the outer solar system. But Jan Oort, back in the day, he studied the motions of stars around the sun's neighborhood, and he found that really the mass of the Milky Way had to be much, much larger than could be accounted for by the visible matter in our galaxy, because of the motions of stars. That is the luminous disk. Well, soon thereafter, one of the most interesting characters of the 20th century in astronomy came along, the Swiss astronomer Fritz Zwicky, and he took up the issue with a passion. And in a famous paper that was published in 1937, he hypothesized dark matter, really in a formal way for the first time, calling it Dunkel Materie, sharing observations of galaxy clusters that he had made over a period of several years. Zwicky calculated that unseen matter must exist in very large quantities, or the galaxies in galaxy clusters, this is, would fly apart into intergalactic space and could not be held together. His paper, it was called On the Masses of Nebulae and Clusters of Nebulae. It would be largely overlooked for many years, although he was on the right track. And of course, part of the problem was that Fritz Zwicky was a somewhat abrasive, controversial guy. And then after a gulf of time came another influential paper that sort of kickstarted the whole thinking in a serious way about dark matter. That was in 1974 when the astronomers Jeremiah Ostreicher, Amos Yahil, and Jim Peebles published a study that assembled is really about dark matter into a coherent proposal for the first time. They calculated that galaxies must have masses of about 10 times the amount of the visible material in them, and that the dark matter must exist in large halos that are observable because of the rotation curves of galaxies. Outer parts of galaxies were rotating much faster than could be explained if the visible matter was all that there was. Then in the later 1970s and 1980s, Vera Rubin, the superstar of dark matter, came along, and she got her working group at Carnegie, the Carnegie Institution, working on it along with Kent Ford and others, and really made numerous observations showing in an ironclad way that dark matter halos exist. The proof was in the pudding, and Vera Rubin basically wrote the book on the observations of dark matter. Still, what was dark matter? No one knew. We still don't know. The leading theoretical idea came to be called the cold dark matter model of cosmology. Cold dark matter refers to dark matter particles that are traveling slower than relativistic speeds when they decouple from photons. The leading culprits for dark matter for about the last 50 years have been many. Cosmologists propose, among other things, fairly massive things called machos, massive astrophysical compact halo objects, but none is known to exist. Other ideas like free-floating, myriad planets and black holes and things like that are not terribly tenable in the ideas of most theoreticians. Most of the ideas that have a lot of credibility, and this is especially the case in the last couple of decades here, come in the form of subatomic particles. For a long time, WIMPs, you may have heard of, weakly interacting massive particles, were a leading idea, but the strongest possibility, and the one that would explain the most of what we can observe in galaxies and elsewhere in the universe, comes from a hypothetical particle called the axion that was proposed in 1974. The problem is that no collider or research group has found an axion as yet. So we know that dark matter exists. Remember, you have to believe in the scientific method all the time, not when you feel like it. So we feel that we know that dark matter exists. We don't know exactly what it is, but we know that 26% of the mass energy in the universe exists in the form of dark matter. And if we take dark energy out of it, which we'll talk about next week, if we're just talking about matter, then about 80% of the matter in the cosmos exists in the form of dark matter. And if you can figure out what it is, we can get you a Nobel Prize next week.
Great.
So let me leave it at that. And thank you very much.
Thank you, David. That was really exciting. It was so interesting to notice, having spent an entire lifetime observing comets and variable stars, to be told that 95% of it I don't even see. Anyway,
Hey, David, you still have things to discover.
There'll have to be someone in another generation, I think. I'm still out there searching, but I'm enjoying the search more than anything else. Excellent. David, thank you so much.
Thank you, Debbie.
And now we go to our next, speaking of our next generation, this is a good time to go for it. Libby, are you about ready? Libby, we need for you to unmute yourself because you are about to be on. I don't,
Of course,
Libby,
the
can you
curse
hear
has
us?
happened, and Libby has
Yeah.
frozen.
My Wi-Fi's been pretty bad, so.
Yeah.
No.
Okay, well, we're going to have to put Libby on a little bit later, I guess, unless we can get her back within the next few seconds. And John Briggs is not here yet either, I see. And so I think we're going to jump ahead a little bit and revise the schedule a bit. Scotty, you didn't tell me we were going to have to do that.
Is it any better now?
Okay, what we're going to do now is we're going to skip ahead to another very dear friend of mine from Boulder, Colorado. Now, Clark, are you ready to unmute yourself and become? Yes. I met Clark in about 1982. I was just come back from a visit to Montreal, back to Arizona, and the phone rang from Planetary Science Institute, and it was Clark Chapman. And he said that we're doing this program of observing asteroids, and we're looking for someone who would like to observe with us each month at Kitt Peak on the 36-inch, number 2 36-inch telescope up there. And I'm sitting there breathless. And then he said, I'm wondering if you could recommend somebody to do that. And my heart just sank. And, what do you do when that happens? Well, I'm thinking, do I know anybody? And I knew a couple of people. And I said, I do know a couple of people. But then I took a deep David breath and I said, I really wouldn't mind doing that myself. And I waited for the axe to fall. And then when it fell, Clark said, I was so much hoping you'd say that. And that began a number of years of wonderful collaboration with all of the people at the Planetary Science Institute. Clark has written some wonderful books, but still one of my favorites is his classic book, The Inner Planets. And of course, he's going to talk tonight about one of, I think, his favorite of the inner planets, which is not the one that we live on, but one that we could be living on someday, the planet Mercury. And Clark, over to you. Enjoy.
Well, let's see what I can do here. I was told that the theme tonight was night, and Mercury is maybe not the best example, but we're going from the darkness of zero knowledge almost to what we will be learning even more so in the future. So let's begin. Mercury is really an extreme planet. It's the smallest planet. It's the closest planet to the sun. It's kind of like a baked Alaska because it's very hot during the daytime, and the days are very long on Mercury, and it's very cold at night. And night is a very long time on Mercury as well. Mercury is made of the densest materials of any planet. It's mostly an iron core. Its silicate mantle and crust are really very thin compared to the size of its core. And we'll get to this a little later. Mercury has the longest comet-like tail that's ever been seen. Now, when was Mercury discovered? Mercury's bright enough, and particularly back in prehistory when there were no skyscrapers and no street lights and you could see down to the horizon, no doubt Mercury was seen at that time. It was recognized as a planet, that is a moving star, millennia ago, several millennia ago. Mercury, of course, is seen during dawn or twilight only because it's close to the sun. It is said that Copernicus never saw it. I think that's apocryphal, but it's widely quoted. To see Mercury, you really need a clear horizon. In theory, you can see Mercury at night. It gets farther away from the sun than the sun can get below the horizon down to end of astronomical twilight. But practically speaking, you see Mercury in dawn and twilight, or even with telescopes during the daytime. You can see the night side of Mercury as it transits the sun. Of course, the dark part of Mercury that's facing you is the night side at that time. The first transit of Mercury across the sun was apparently observed in 1631. More or less, since that time until the middle of the last century, it was thought that Mercury kept its sunward face to the sun at all time, just like the moon keeps one face to the earth. And since Mercury goes around the sun every 88 days, it was thought that its rotational spin was 88 days. And maps were made during the late 1800s and the early 1900s based on that understanding that it was rotating every 88 days. The map that you see in the lower right corner is one made, I think, around 1930 by Antoniadi. Well, it's not really a good map, it turns out, because in 1965, the Arecibo radar echoes off of Mercury disproved that it had an 88-day period. It was closer to 60 days, according to the radar data. And picture of Arecibo is down there in the lower left, as you all probably know. A few months ago, Arecibo collapsed and is gone forever, but it sure was a great astronomical instrument for a number of decades. And one of its early discoveries was that Mercury rotates in about 59 days. Why it does that was explained a few years later by Giuseppe Colombo, an Italian physicist, who pointed out that as a result of its eccentric orbit and the great tides from the sun, it's caught in a resonance lock and spins in 2/3 of its year. 59 days is exactly 2/3 of 88 days. Now there's a wagon wheel effect, which gives Earth-based observers the illusion of an 88-day period, which is why Antoniadi was able to make a map. The wagon wheel effect, actually, for the few of you who can see David Levy's ceiling fan, to me, it's sort of jerking around and not really rotating, and it's apparently because of the timing of the video in relation to the spin of the ceiling fan. Anyway, as a result of that, there's an understanding about why many observers felt they could make a map of Mercury despite the wrong rotation period. I did a map of Mercury a couple of years after the new rotation period was discovered. I went to the archives in the Harvard College Observatory Library and found drawings of Mercury that people had made during past decades and centuries, and put them all together, assuming the 59-day rotation period. And this is a map of the albedo spots on Mercury. This has nothing to do with with the geology of Mercury, but it was an attempt to see what Mercury looked like now that we knew what its rotation period was. In the 1970s, Mariner 10, a NASA spacecraft, flew past Mercury 3 times. Now, it was originally planned to just make one flyby of Mercury, but the same Bepi Colombo, the Italian physicist who explained the rotation of Mercury, was able to calculate that Mariner 10 would fly by Mercury 2 more times. So it actually flew by Mercury 3 times. Now, Mercury looks superficially like the moon to Mariner 10's cameras, but it was covered with these scarps that are shown to the left of the text there, very long cliff faces. And actually the whole globe looks like it's kind of shrunk. And that's probably what happened, is that the interior cooled and the crust shrank a bit, causing these giant faulting scarps that are very unlike the moon and pretty unique to Mercury. Mariner 10 also discovered that Mercury has a Earth-like magnetic field, although it's very weak. It still stands off a magnetosphere, and it's important despite being only, I think, like 1% the strength of the Earth's magnetic field. Also, Mariner 10 discovered aspects of a very thin atmosphere that Mercury has. Now, after Mariner 10, it was a long time before another spacecraft mission to Mercury, but Earth-based astronomers still were making discoveries. And the left-hand side, you can see a radar image of the North Pole of Mercury, again by Arecibo radar in Puerto Rico, the late Arecibo Observatory. And it discovered that Mercury, despite being so close to the sun, has ice in its polar craters. Both the North and South Pole craters have ice in them. And that was really quite a surprise. Also, Mercury is a comet. David, you should take particular note about that. It's not your ordinary comet. There's a black bar there in the picture to the right, which is hiding the glare from the planet Mercury itself. But sodium gets into the atmosphere of Mercury and then streams away thanks to the solar wind and so on. And Mercury's a giant comet. Did you know that, David? You probably know.
No, I did not, but this does give me an opportunity to show everybody my ceiling fan.
Right. Okay, here are 2 books about Mercury. I mean, there's many other books, but these are sort of professional books about what we learned about Mercury chiefly from Mariner 10 in the book on the left, which you'll see is co-authored by myself and Faith Vilas and Harlow Shapley's daughter, Mildred Matthews, who edited many of the University of Arizona Space Science Series books. That was published in 1988. On the right-hand side is a book that just was published a few years ago based on the results of Messenger, which I'll be getting to in a moment here. Messenger was an orbiter around Mercury, and this book, published by Cambridge University Press, summarizes all that we've learned from that. So here's the Messenger mission. It was, I can't even see all of my slide here. But it was launched many years ago and did a bunch of Earth and Venus and Mercury flybys to get its orbit down to, or its trajectory down to where it could go into orbit around Mercury. And it orbited Mercury for several years until eventually it, after an extended mission beyond the original plans, it actually eventually crashed into Mercury. but it learned a whole lot. Studying the chemistry, the geology, the magnetic field, the core of the planet, the polar ices, its thin atmosphere, and so on. And let me just show a few of the things that we learned about Mercury from Messenger. On the right, well, here, let me start with the left-hand portion here. The three pictures in the left-hand dominant portion of the slide are all of the same region on Mercury, the very same one. And in the upper left is an image of this region from Mariner 10. And below that is a U.S. Geological Survey sketch map of what they think was seen in that picture. Well, Messenger took the picture just to the right of those, and as you see, over the decades, the cameras have improved a whole lot. So, so Messenger has good images of a large fraction of Mercury's surface. Now, Mercury tends to have many more secondary craters on it than the Moon and other planets do. Secondaries are when a crater is formed, it shoots out debris in all directions, and the debris falls back and makes craters. The debris, each chunk of debris can make a crater. What you see on the right-hand side are two examples of rays from a crater and a close-up showing the crater chains of a bunch of secondary craters from two primary craters that are not visible in this picture. Mercury also has some large basins, like the big basins on the Moon, like Mare Orientale or Mare Crisium. These two basins are a couple 100 kilometers wide, and they have very few craters superimposed on them, which means they're really quite youthful. They were formed on Mercury only, I don't know, 1 or 2 billion years ago, instead of way back 4 billion years ago, like basins on the Moon. Some other things. Mercury has volcanoes on it. Some recently active. Conceivably, they could still be active. In the upper right is a volcano. One an oblique view, the other a colorized view from overhead near the basin Rachmaninoff. A very large bunch of debris shot out of the volcano and producing that light area around the volcano. In the lower left, you see the Caloris Basin, one of the largest, probably the largest basin on Mercury, and it's got some volcanoes that in this false color picture are reddish in color around the edges of Caloris Basin, and a blow up of one of them is also shown there. Mercury has other interesting features that don't look very much like the Moon. Perhaps the most amazing new features are the so-called hollows. You see some examples to the left. These kinds of features are obviously not impact craters, they're depressions, but they appear to be due to the devolatilization of material on Mercury. Mercury is very hot. It also has, very surprisingly, a large fraction of volatiles, in particular sulfur. And it's probably that the heat just has gotten so hot that the rocks get eaten away and dissolve and leave these depressions called hollows that are seen only on Mercury. Mercury has a magnesium-rich area shown in the left. The gamma ray spectrometer shows that reddish area is very rich in magnesium compared to the rest of the planet. On the right, you see the outlines of the northern hemisphere, northern polar smooth plains. These are volcanic plains that happened fairly recently in Mercury's history because they're not very heavily cratered. Now, Messenger mission ended in 2015. There was a time quite a few years earlier when it was hoped that the European Bepi Colombo mission, named after that Italian physicist I've mentioned a couple of times, would be arriving at Mercury while Messenger was still there. But it's a very complicated spacecraft and its development was delayed, but it finally was launched in, I think, October of 2018. And it's been on its way to Mercury. Although Mercury isn't very far away, just like Messenger and Mariner 10, takes a while to kind of slow down and get into orbit around Mercury. And Bepi Colombo, which is partially a European mission and partially a Japanese mission, will arrive in 2025 and put 2 spacecraft into orbit. One is aimed at studying the planet itself, and another, in a very much more elongated, more distant orbit, will explore the magnetosphere of Mercury. So that's the future. Now, I just wanted to point out that, you know, since the days I was an amateur astronomer and making drawings of Mercury that partly went into my map I made back in the 60s, the capabilities of amateur astronomers have improved a whole lot. And here's a picture, photograph taken of Mercury a few years ago. That's just, to me, completely amazing. But a well-equipped amateur astronomer can do their own studies of Mercury until Bepi Colombo gets there in 2025.
Wow.
So that's it.
Wow.
Well, thank you so much, Clark. That was so inspiring and very interesting to listen to. One of the things that really got to me on a very personal note was the crater Rachmaninoff. And it kind of reminded me, my little David brain was moving around from subject to subject. And I was thinking about an episode of MASH, which I think had probably the best writing of any television series ever. Anyway, there's a scene in the bar where Winchester is there, and he's telling his servant very rudely to get him the Rachmaninoff. And he says, it's very easy to find. You just find the album with the letter R, the big letter R, and then all the other little letters after it. And I just couldn't get that out of my mind as I'm thinking of the crater on Mercury right now. I think if MASH were done now and if the characters were living now, they'd probably have a lot more to say. And I believe, we have Libby in the stars now.
And you have John Briggs.
And John has just arrived. And we're going to be putting him on later. A few adjustments here, but I'd like to give Libby a chance because, as both Clark and earlier Stella had told us, that really what we're going to be worried about and concerned about and excited about is getting our next generation into astronomy and to appreciate the night sky. And I cannot think of a better example of that than Libby. Libby, are you still here? No, I guess Libby has fallen off. Oh, no.
Okay, she's trying to return. There she is,
I
right
think she's
there.
trying to return. Libby, are you there? We're going to give you a couple of minutes here to. I'm certainly not going to sing another song after the reaction I got from the last one, people throwing things at me. So I will not sing "Hello, Darkness, my old friend.
Yes.
I've come to talk with you again." Anyway, we finally have Libby.
Well, it brought Libby alive when you started singing. Her
Libby
screen unfroze. So maybe
Libby,
you do have some
unmute
powers
yourself
there.
And introduce us to the next generation and what's concerning them and what's exciting them about the night sky and the theme tonight of night. Presenting it to you, Libby.
Okay, so I'm gonna try and do this really quick because I am having very bad internet issues and have been randomly kicked off. So about stars and their temperature.
Libby, I think that we have the.
Yeah.
Hey, Libby.
Yeah, your internet issues are starting to affect you again.
About stars and their temperature and how that helps with knowing how old a star is. And I got into this, so
No, we lost her. Okay.
It looks like we've lost Libby for
That's
now. We'll try her again if we can get her back. But I think now
Yeah,
we're
I
going
definitely
now.
want to hear that.
Yeah.
That sounds like a
Libby,
very
you're back.
interesting.
Okay, Libby, you're
Try
back.
it again.
Back to you. Try again. No, I don't think
Oh
we have
no,
Libby.
she's frozen again.
If we get her later.
so I'm going to share this real briefly.
Dave, maybe if you sing again, you'll unfreeze her again.
I'll share this really quickly and briefly. So our sun is the color that's like a darkish orangish color. And let's take another star that might be a blue star. Now that star would be hotter than our sun because if you look on the graph.
Oh.
We're just having.
I don't think this is
Libby. We'll try to get her on a little later if possible.
Yeah, yeah.
So we're going to proceed now to our next guest, who is someone that I know very well. And this is Wendy, my wife, who is here this evening to talk with us about her activities in astronomy over the years, and more particularly, how she manages to be married to as difficult a person as me, and how she handles it. Not all of this is going to be positive about me, I hope. And I'm really looking forward to it. And Wendy, it is all yours.
I think she's coming to join you, Dave.
If you've noticed, my picture is now lost. And that's because the way David and I have our little office set up, we cannot have my little machine on and David's on at the same time. Excuse me, David, move this. And so I'm coming over to his desk, which is far too big for me, but at least maybe you can hear me as I knock everything over. David asked me to speak on life, what it's like living with David Levy. And I was thinking about how to proceed. And then I remembered way back when in 2017, I had written an article for Skies Up, those of you still familiar with it. Oh, there I am. Called Life with David Levy. And it was very interesting for me to write because I figured really before you can figure out how I am dealing with my life and taking care of David, you need to know a little bit about my life. And David and I had totally different trajectories. We are not the people that as we were growing up, anybody would have ever thought would be together. And let me just go a little bit into my life and then you'll see how it blended with David's and why we do work so well together. I had a very fortunate growing up. My life was super well ordered. My family was always together. We were very close. My parents were always family first. We did things together. So I knew what it was like and thought every family in the world was like our loving family. And as I learned later on, that was not so, which made me very thankful for the family I grew up with. My life itself sounds very boring because it was all in little boxes. Like most of us, you went to elementary school, you went to junior high school, then or middle school, high school, and then you realized what you were going to do, and then you go off to college to find your career and see if it is the one you love. And my career was nowhere near astronomy. I knew very, very, very little about the stars, and my parents were both physical education majors. That's why they played with the family so much, and I followed in their footsteps. I also was a physical education major. And what I'm going to do now, because I'm a little bit nervous, is read you bits and pieces from the article that I wrote for Skies Up, which is a very short article, but it'll give you the feeling of who I am and how David and I worked. And the first part of this that I labeled was, no matter what I choose to do in life, it was obvious. I would always be a teacher, and I would always be an organizer of things. As a physical education teacher and coach, I organized every class tournament, every intramural activity in my schools, as well as after-school extramural activities. My days were long, my weekends non-existent, as they were filled with school sporting events. On occasional weekends where no school events were planned, I did volunteer work for a local American Red Cross chapter. I organized the annual Learn to Swim programs. I taught first aid, CPR. I trained instructors in those fields. And by the time I wound up leaving Las Cruces, where I was teaching, I was head of the Safety Services Committee in Doña Ana County. So I was doing a lot, and people just kept bumping me up the ladder. And if that wasn't enough in my career, and this is all before I met David, when I wasn't teaching for the Red Cross and I wasn't doing the sporting events, I moonlighted up at New Mexico State University, teaching a 1-hour class on Sunday afternoons at their weekend college. I was a very busy girl, but it was boring in the extent that it was always the same. I knew my school year would go from, we would start with girls softball, and then we would go to girls volleyball while the boys were doing wrestling. And then we would go into girls basketball, and then we do boys basketball. And meanwhile, I'm organizing all this plus the cheerleaders. So it was the same every year, just never stopped. And at one point I was talking with one of the main organizers in our school system. She was one of the assistant principals. And we pondered together what it would be like after everything we do to take care of one famous person as opposed to every student in the school. And so after 26 years of teaching, and I was figuring it would be easy because by then I knew David, and he was the primary reason I retired from teaching. And I knew I was going to be the one organizing that one famous person. That was not nearly as easy as I thought it was going to be because it was totally different. I was ready, but I wasn't prepared. When it became obvious that, where was I going to read in my article here? Anyway, what wound up happening as we were together, I looked at what his strengths were, what my strengths were, and then I figured, okay, I think the way this would work best, I looked at David, and most of you know David. I'm going to describe this before I go on into two personalities. I learned this at an in-service day, and they gave a number of different personality types, but these were typical personalities. The first is the one we would call a concrete sequential. The concrete sequential is the person you know that will come to a meeting, be there 20 minutes early, have everything laid out on the table, ready to take notes, sitting up in the chair, and just in case there's some free time, they brought something to do so they wouldn't be bored. The second personality is your restless romantic, could never know, they can't find anything, they're running around trying to get everything done. They run into the meeting just as it's about to start, plop down on the chair and go, made it. Now, I think you know by now, I am the concrete sequential and David is the restless romantic. When so when we started to figure out how we were going to have life together, I said to him, David, you are a wonderful astronomer. You write well. You hold the audience in the palm of your hands when you lecture. I'll take care of everything else. And that was the mistake because he didn't want me to. He said, no, 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 you worked so hard. I'll take care of you. And I thought, all right, this will be easy. This will be interesting. And after 1 week, I started little by little. I took over the bills. I took over the shopping. Now it's back to where I originally said, I take care of everything. And part of this turns out to be that when people look and they say, how, because we still are so opposite. I looked at David and I made him watch a movie I know he'd probably never seen, and that was Rocky, the first Rocky movie, because of the one line in Rocky where it said, we fill gaps. And I said, Dave, and that's what David and I do for each other. We fill gaps. We have no competition between us. So it's very easy for me to sit back and listen to him speak. And he never has pushed me to become an astronomer. So when people today say, you're an astronomer, I go, well, by David's definition, I'm an astronomer. I can look up, I know a few constellations, I know some stars, but I cannot take what I know and what I put together. And of course, my mentor is David Levy, so I will never feel like an astronomer. It's just the way it is. But one of the things he has done, because one question I asked him early on in our dating, we were driving back from our first date and it was getting a little bit, dusky out, and he pointed out Vega. And we saw a star, and I said, what star is that? He said, that's Vega. And I said, David, if I asked you the name of that star every night, what would you do? He said, I would tell you the name of that star every night. And it was like, oh, be still my heart, because in my practice marriage, there was, people only told me things once, that's all I'm going to tell you. And I thought, oh, he has patience, this is great. and it's worked. It never made me feel like I had a push to learn to be as good as everybody else. But one thing David did do is he had, whenever he would write a book, and I was not an English major, but I had okay grammar, and he would have me be his first line of copy editing in books, which was an interesting trick. And all his book publishers should be saying thank you to me, because I would go through his script, and David was a hunt and peck typist, which meant multiple typos, so I could correct those pretty easily. I knew the stories he was writing about because he would always recap them to me. So when I would get to a sentence that looked pretty illegible, what I wound up doing was just thinking, okay, this is what he wants to say. And then I would rewrite it, and hopefully it was right. And if he left things out that I thought were critical, I'd put, where is such and such story? And sometimes I would not know anything he's writing about, and I'd go, huh? So this was the kind of copy editor I was. But by the time it got to the publisher, they at least could make sense of it. And then we'd get it back in the galleys. And I got to read the book again, because I went through mistakes we may all have missed. And then I did his index, which made me really look at the book. And so consequently, my little mantra is, I think I'm learning more than I think I'm learning. I just feel like I am the backup for David, because that's one of my strengths in organizing. I can look at a problem and I can see what needs to be done, and I can always figure out how to get it done. And so for those of you who think I, like my mother does, that I just sit back and let David do all the work and just take in money, which I don't, I do work right alongside David. There is one thing I want to read specifically at the very end of my article. It says, David and I each have our ways of doing things, and they are never alike. But in the ways we need to be alike, we are truly in sync with each other. Our brains seem to work at the same speeds. We have the same beliefs and ideals, and we each have enormous respect for the jobs we both do to make our lives work so well together. Thank you.
Thanks, sweetheart.
Wonderful.
That was great. Let me try to get the chair back here before the rest of the house comes crashing down. And it's very exciting. And I'm glad that you didn't tell everybody that your nickname for me sometimes is wrong.
I didn't want to go that.
Oh.
I didn't want to go into every little nuance. I'll have to get to know us better for that.
Well, that'll be the next talk. As I was listening to Wendy's talk, I was finding this letter up here that I'd like to quote from a little bit, written to another Dr. Levy. And it says, a life is measured not only by how long it has lived, but also by how well it has lived. As you celebrate your 100th birthday, may you take this opportunity to look back on the many lives you have touched, family and friends and people throughout your community. Without you and your lifelong contributions, Canada would not be as diverse, as rich, or as interesting. It is my hope that you will share your life's achievements with others and inspire them to dream bigger, aim higher, and reach for the stars, because that is what you have done, and that is what you will continue to do. That letter was written to my mother, Edith Levy. She never got to see it because Mom passed away about 6 weeks before her 100th birthday. And the letter is signed by Julie Payette, Governor General of Canada. And I just thought I would share that with you. And Wendy, thank you so much for sharing your part of our lives in the stars. And that's great. And now we have John Briggs here. Are you, he's waving, and if you want to unmute yourself. I met a new writer over at Sky and Telescope a number of years ago and immediately took a liking to him because of his passion for telescopes. He is a very active member of the Antique Telescope Society, and as such, I can claim that he knows everything there is to know about telescopes. He also knows everything there is to know about the AAVSO. In fact, Stella and John and I had this big go around about who was going to say what. And I'm so glad that Stella did what she did this evening. But now it is my great privilege to present the microphone to John W. Briggs. All yours, John.
David, thank you so much. Thank you, everyone. And I apologize. My schedule has been convoluted tonight because in this Zoom era, for the first time, I was obliged to make 2 presentations tonight. And the earlier one was to the Royal Astronomical Society of Canada, the historical section. And so it was a great privilege. And it went a little bit longer than I expected, and maybe I goofed something up with the time zone. But anyway, here I am, and I trust you could hear me. And I am going to attempt to share screen. And let's see, select a window. I'm not that experienced. Oh, this looks like it. Let's see if this works. And good. From beginning.
It's working.
Oh, wonderful, wonderful. Thank you, folks, and for your patience. So I want to share with you a few slides quickly about one of the great events in amateur astronomy, at least in eastern United States, and it is in fact where, for example, David Levy and I first met, and also David Eicher and I first met. We met through the community at the so-called Stella convention in Springfield, Vermont, that runs every summer. It's been running since 1926. So people hear about this event, Stellafane, and it actually is the name of an observatory and a clubhouse. And it's almost mystical. So here's a drawing of it. So people haven't been there, might have some kind of vague conception of what it might be like this drawing. Well, reality. This is what it's like in reality when the annual convention rolls around. And what was so lucky for me in my life was that as a young teenager, I got dragged along to attend the long weekend Stellafane convention campout in 1971. And I have to do the arithmetic. Was I like 12 or 13 or something like that? And I was just another kid interested in science and nature in general. But when you're a kid in school, you don't necessarily understand much about the community of people who might be out there who share these kinds of interests with you as a youngster. That such a community exists, to discover that early on, that's really an eye-opening thing. So for me to go up there to this site, to discover the little pink clubhouse of telescope makers that was built back in the 1920s, to discover the White Observatory there, the so-called Porter Turret Telescope, a very, very unusual telescope built, dedicated in 1930. And to see, like, on the order of 1,000 people show up to go camping. And I always love to go camping. It's a great event. And look at the youngsters in there. Look at the diversity of the telescopes, almost all of which are homemade, because this event really is traditionally, since it started in 1926, it's a convention of amateur telescope makers, even more than it is like a camp out star party, although there's certainly plenty of that too. But anyway, let's just go through some of the slides. And here's a shot from the second floor of the clubhouse, looking down on the traditional a convention site, because you see originally the site was only a couple of acres, and but now the organization that runs this, Springfield Telescope Makers, they own altogether about 80 acres. So the campground has expanded. There are additional observatories. There's a great big building that can seat actually about 1,000 people. It's a great big pole barn, so that if it happens to be a rainy weekend in New England, and very often they are, you still have a lot of fun. They have fabulous speakers. And guess who became one of the most regular, one of the most articulate and popular speakers at Stellafane as we all grew up and got older? Of course, it was David Levy. But when I first saw him in action, when we were quite young, it was as young men running around Stellafane. Well, let me keep going, showing some slides, because I don't want to go too long. There was a founding figure, a visionary, making all this happen. And I can only allude to him a little bit. His name was Russell Porter. And boy, he was an artistic and all-around gifted Renaissance man. He had studied architecture at MIT, but he had a chance to look through a telescope when he was a young kid, and he didn't have much money. He decided he had to have one, so he ground and polished his own. And that was, he began talking about it, writing about it. It caught the attention of the famous astronomer out in California, George Ellery Hale. And George Ellery Hale was creating the Palomar 200-inch project at the end of Hale's life. And Porter, by the way, had been an Arctic explorer. He was a wonderful artist, and these watercolors of the native people up north that he met and lived with for a time. But it was natural for Porter, with his telescope making skills and everything, to be embraced with the design effort for the tremendous Palomar project starting in the 1930s, which was building the largest telescope on Earth. And this was just a preliminary design sketch, 1936, by Russell W. Porter. But let's look at how his drawings continued. I think we might have somebody else with some background noise.
Yeah.
But I hope you can all still hear me. But anyway.
We can hear you clear. I think you're muted.
Oh, good. But here, let's keep going. These sorts of drawings are what Russell Porter became particularly famous for at the end of his life. He had built and designed the clubhouse, the pink clubhouse, and the observatory back at Stolfane. He had founded the astronomy club that ran the summer meeting that went on for decades and decades till like I and others here tonight got to go to when we were younger. So inspirational to us. But Porter made these design drawings of the 200-inch before it was built. But they were amazing works of art, weren't they? Let me just go through a few. They were cutaway drawings that showed the guts of the telescope, this monumental telescope. This telescope where people could open hatch doors in the mounting mechanism and climb up through it to get to obscure points of focus and all kinds of, just an amazing, it was one of the greatest scientific efforts of its era right then, starting right before World War II, was delayed by World War II, but it was dedicated in 1947. Unfortunately, Hale did not live to see it finished. But anyway, all these drawings were things that Porter created before the mechanism was built, before photographs could be taken of it, just based upon mechanical drawings. But you might be able to tell these are really cool works, mechanical drawing works of art. There was a famous artist of that era named Maxwell Parrish. He was friends with Porter. He wrote, if these drawings had been made from the telescope and its machinery after it had been erected, they would have been of exceptional excellence, giving an uncanny sense of reality, with shadows accurately cast in well-nigh perfect perspective. But to think that any artist had his pictorial imagination in such working order as to construct these pictures with no other mechanical data than blueprints of plans and elevation of the various intricate forms is simply beyond belief. Yeah. Oh, Parrish went on praising Porter and how cool his things were. But all I'm trying to say tonight is Porter was an amazing man. And he did these things, but he touched our lives by setting Stolfane in motion and encouraging telescope enthusiasts like this one made by Steve Dotson of Canada, 22-inch, back, when was it? In the late 70s or early 80s? It's not a very good picture that I had, but let's look at some of the others. Some of the telescopes that are displayed are beautiful antiques by the great makers of yesteryear, like this, I think it was a 5-inch refractor, maybe a 4, but it was made by Elvin Clark and Sons Corporation. There's the back of the telescope. You can barely see that it says Elvin Clark and Sons. Beautiful antique telescope, well, at least about 100 years old. Workmanship, exquisite mechanical artistry in these things. You see this stuff when you go to Stolfane and get to look through it, because all people want to do is share and let you look at and look through the telescopes and hang out as late into the night as you can stay up. You meet interesting people. Like here's Dennis DeCicco, a very dedicated, famous astronomer and author. Dennis spent his career at Sky and Telescope magazine, and David talks about, I'm supposed to know about telescopes. Dennis DeCicco, he's somebody who really knows about telescopes, but a very good friend, wonderful person. You get to get a sense of community by going to events like these. And celebrate how much fun it is enjoying this type of equipment, so much that you can be inspired to build the stuff yourself. Now, I should whip right along, just showing some of the fairly exotic homemade telescope. This is some kind of Newtonian, but notice the white hemisphere towards its bottom, because this telescope pivots around the sky, by just allowing its sliding motion on that hemisphere. The Porter Turret Telescope there is another weird one and up behind, but I won't have time tonight to describe that, though it's very cool. Here's some guy there. Is that a telescope? What is it? He's attracted the attention of the kids. It's painted a bright yellow. Let's look around a little bit from another angle. Look at the crowd he's got gathered. You know what he's got in his hand on a stick? He has a marshmallow. And of course, many of you recognize what that is a big Fresnel lens. This guy is teaching optics. You can't help but learn, no matter what your age, going to something like Stellafane. This guy, he's cooking marshmallows with solar power, man. He is roasting those marshmallows. That's what the solar focus there of that apparatus is, handing them out to the kids, and he's wearing a Stellafane hat, and it's just another facet of the scene that's going on. Homemade telescopes of all beautiful sorts. This one's, though, quite exotic. You know, these things get big, but they're challenging to transport. But this is made with a framework that can be twisted in a certain way. This bright engineer guy, he demonstrates how if you twist it just right, the telescope collapses down into something that's much more transportable. I mean, how cool is that? It's just the sort of thing you see. And some telescopes are designed of metal with traditional equatorial heads. Others have wooden mountings, just all kind of things. What's emphasized is it shows you can think in terms of doing stuff yourself and become hands-on. You can hang out after dark. You can look at these things, look through these things. Here's one that uses a green bowling ball as the pivoting mechanism in the mounting. As if that wasn't enough that this year that this was shown for this type of design. Here's another one with a bigger bowling ball, and it's not green. But an interesting way to facilitate motion of the telescope around the sky. Neat things. Sometimes people paint galaxies on them in a sort of traditional Dobsonian there. People have a lot of fun. Sometimes Stellafane is so beautifully clear like this. Sometimes it's rainy, but we still have fun. And besides all the reflectors, there are traditional homemade refractors, kind of along the lines of this one here, the fellow's proudly displaying. But if you just want to hang out and enjoy yourself, that's my daughter Anna sitting there in front of the pink clubhouse. I'm so glad that I've been able to turn my family on to Stellafane. I live in New Mexico now. I'm speaking to you from New Mexico, but whenever I can, I try to get back to New England. Of course, there are many other astronomy events like this all around the country, all around the year. I grew up with Stellafane. I was lucky in New England, and so I miss it. And this is just looking at the panorama from out around the clubhouse. A lot of people come down from Canada to attend Stellafane. I found that fascinating when I was a kid. And here's the big crowd in the amphitheater down on the 80 acres for the featured talk. David Levy has given these talks. Alan Stern has given the talk twice recently. Sam Hale, the grandson of George Ellery Hale, also was the keynote speaker just a few years back. But there's the event at its traditional location. Thank you very much for letting me share my enthusiasm for Stellafane. If you haven't been there, I hope someday you'll have a chance. They've got a fabulous website with tons of information on it. And thank you for your attention. Again, I apologize. I was a little bit out of sync, as I so often am on issues of schedule tonight. But that wraps it up for me. Thank you.
Well, thank you so much, John. I really enjoyed that. It was kind of like going back into the past during the times that I went to Stellafane and enjoyed it so much. I'd kind of like to go back there again some year. Yeah. I hope we'll be able to resume it at some point, and we'll all get together, John and Stella and Scotty and all of you, Dave, Clark, Terry, Wendy, all of us will be able to go and see each other in person, perhaps at Stellafane some future year.
Well, actually, if Stellafane runs is here, I'll be there.
Yeah, that's great. It's a lot easier for you. You're the closest big city to Stellafane.
Yeah.
You get in the car, turn left, and you're there. Okay.
Right. and straight. Well, sure. Yeah.
Yeah. Turn right. It depends which way. It depends on what your opinions are. You either turn right or you turn left.
Yeah, but I really miss the camaraderie. I mean, you walk around the middle of the night with your red flashlight and you're asking people what they're observing, and they're all about showing you through their, to look through their eyepiece and sharing their enthusiasm. And it's contagious. At some point, it's becoming a huge star party where it doesn't really matter who you are, where you come from, where your background is. All that matters is that you're sharing parts of the night sky and you just get to chat with each other. It's kind of it's liberating and it's fun. There's so many absolutely amazing people there. It's wonderful to learn from them because they know about telescopes. Oh my gosh, I've been wandering around Stella. I've been there like 3 years now in a row. I didn't go last year, but I was wandering around Stella just asking people, how they made the telescope, and just get a mini course on telescope making, which I absolutely love. They didn't know who I was. I didn't know who they were. And that's absolutely fantastic.
I remember one year I was there, Carolyn Hurlis was there, and she grabbed the microphone and announced to everyone that SS Cygni was an outburst.
Yay.
Right there during the convention. That was kind of fun. Yeah. Anyway, John, thank you so much for your wonderful presentation tonight. It is now time, I don't want to surprise her too much, to introduce Terry Mann from the Astronomical League. I believe that Terry has some door prizes to announce and some questions to ask us regarding future door prizes. Terry, are you ready to take over?
Yes. I am.
Okay, Terry, it's all yours.
Thank you. I'll go ahead and share my screen. And we're going to do what we usually do when we first start off, is just warn everybody when you are using optics that if you're going to look at the sun, please make sure that you have the proper filter on that telescope, binoculars, whatever you're using. And we're going to start a new way of doing door prizes tonight. And I will just ask 3 questions tonight. There will be no answers tonight because I gave all the answers on the previous star party. So tonight, please send your answers to secretary@astroleague.org. And here are the questions. What year was the Hubble Space Telescope launched? That's question 1. Question 2, what was the date of the last Mercury transit? And question 3, what is the name of the largest crater on the moon? And also, we will be back with Astronomical League 5. We'll be here on April 23rd. Our keynote speaker that night will be Howard Eskelson. He will be speaking. I'm not exactly sure what his title will be, but we'll have that out before long. So thank you so much. And please just send your answers to secretary@astroleague.org. And the answers will be next at the next star party. Thank you.
Thank you so much, Terry. Will the winner of this league's quiz please form a line over on the right? Thank you. Okay.
Thank you.
And now it is a great pleasure to introduce a close friend of mine, Joseph Wright from Kansas City. Kansas City is a holy place. It is a place to enjoy astronomy. It is a place to enjoy life. It is a place to learn. Why is Kansas City so great? For many reasons, like every other city in the world is great. But Kansas City has one point up for it, and that is that it is the home of the Linda Hall Library, which is probably the finest science library in the world. And I notice I have one thumbs up from John about that. I have been there, and it's like being in heaven. It's like being in a church or a temple or a synagogue. It is wonderful to be there. The wisdom of the ages, all in those books. Anyway, one of the other things that Kansas City has going for it is Joe and Rita Wright, who have been very enthusiastic astro disseminators over all of their lives. They are now in charge and running the National Sharing the Sky Foundation. Joe, I'm giving it to you now. Take it away.
Thank you, David, and it's a pleasure to be here, everybody. Just a moment, and I will share the screen. And if you've ever used Zoom before, it likes to hide things. Here we go. So as David has said, I had the pleasure, Rita and I actually, my wife, I'm very lucky to have her part of my astronomy interest, and she is with me nearly 99% of the time when we do things, especially when it comes to outreach and working at Stewart Observatory with Don McCarthy and Larry Lebowski. So we get out to see the folks in Tucson nearly every year, except for, like everybody is saying, except for 2020. So in these times that we have been going out there, and David has been coming to Kansas City to do research for some of his books at Linda Hall Library, we had a dinner for him at one of the steakhouses, and I was the president of the Astronomical Society of Kansas City then. And so I was invited to be part of that, my wife and I, and that's how we met. And ironically, that was about the time that David was having problems with one of the observatories at his house. And so he needed a repair mission, and our trip down to Tucson for one of the astronomy events with Don and Larry, we brought the pieces to the observatory down there and did some repairs for it. And that's what really kicked off our friendship, the four of us back then. And we ran out to their house and spent the evening observing because there was a storm coming in and we wasn't sure if we'd be able to observe while we were up in Mount Lemmon. But we also encountered something else while we were out there. I just have to share this. It's not often we have these in species of rattlesnakes in Kansas City area in the Midwest here. Scott's got them down where he's at. But that was on the path between the house and the observatory. So it's just interesting what we got to be introduced our first time. So moving along.
Smiling at the camera.
Yeah, it was doing more than smiling, all right. But luckily we were able to, they had some friends come over. I held a cooler while they put it in it, and we transported it over the fence and continued on. And there we are working on the dome. As you can see, the stops had come off, and I had fashioned some up out of aluminum, heavy gauge aluminum, and brought them with me in my carry-on luggage. And we installed them on the dome so he didn't have to run out there or have Wendy out there and catch the shutter as it was coming over the top. And then we found out why the dome wasn't rotating. And we even got to be on Let's Talk Stars with them, both of us. So it was quite an eventful time out there. And it really, as many of you said, in the community of astronomy, you're able to meet a lot of great people and you build up friendships. And let's face it, what better place than under a beautiful sky to start fostering friendships of any age? And so that's what I wanted to talk to everybody about, friendships and also sharing the sky with other people. Sometime following the Schumacher-Levy 9 event, David and Wendy formed Sharing the Sky, National Sharing the Sky Foundation. And the mission of this foundation primarily, and to give you the clip notes version, its mission is to inspire not just adults, but really youth, to get youth inspired and to get them involved in astronomy and the allied sciences. Because if we can get them interested at a young age, and they develop a interest in astronomy, physics, any science, we are doing something that's going to help the future of mankind and this planet. And so David and Wendy formed the National Sharing the Sky Foundation that did just that, with members from Tucson area like Tim Hunter and others out there and around the country, down in Florida and other parts. Even Scott's been part of it. And it's about outreach. And it's a hard thing to do outreach because it's an intangible thing. You don't know what kind of impact you're having. And so during this time, David had and Wendy formed alliances with different organizations, the University of Arizona, Mead, and many other entities, and Explore Scientific. And so it is really going forward. But, you know, sometimes in life people want to slow down when they get to a point, and they're looking to pass on the torch, but not put the torch out and keep it burning. And so in 2017, 2018, I was driving David down to the Heart of America Star Party, and he asked about what I thought if he transferred the president and leadership of the organization to me. My first thought was I was honored. I'll be honest, when I started in astronomy at Boy Scout camp getting arrested near Osceola, Missouri, where just like many other areas that you live in, the sky is really polluted. But down at the Eicher Bartle Scout Reservation, the nearest town only has maybe 1,000 people. And the sky is marvelous down there. And as a young Boy Scout, 13, 14, it really started my interest. I never had any idea that when I joined the ASKC and started meeting other amateurs and professionals, that I would be meeting the caliber of the people that are here tonight from around the world. And it's just been a blessing to Rita and I to be able to take part in meeting these people. And in this picture are, of course, David and Wendy, Rita in the middle, myself, and then a couple of the other people from the Kansas City area, Charles and Carol Kennedy, that are part of the board of directors of Sharing the Sky now in Missouri. And so we're carrying this torch forward, and we are doing events. Now that picture, let me back up and say this is taken at the Adirondack Astronomy Retreat where David attended camp as a youth, and really helped him also start his own personal observing projects or programs. And they started having a retreat up there, and they invited us, and Rita and I drove from Kansas City, Missouri to Westport, or just north of Westport, New York. It's not down the street, so we really had to want to go. And we went back in 2015, I believe it was. And then again, we invited Charles and Carol to go with us in 2018. And so they enjoyed it also. Near there, and I couldn't leave this out, Wendy and David, near there, we drove down to the Museum for Star Trek, where they actually have built the Star Trek sets by spec. And, you know, it was great. I think they had to pry David and I out of there. And we could have been running around the halls if we had a toy phaser or something like that, just having a blast. And sitting in the captain's chair and taking on the Kirk position of damn the torpedoes full warp ahead was a lot of fun. So if you get up that way, check it out. Anyway, so we started doing outreach back here in Kansas City. Typical places. One of them was the Mid-Continent Public Library System invited us out there. And so we take my old Boy Scout trailer. It is the astronomy trailer now. We have some tubing that we can put the banner at different heights. And we travel around the greater Kansas City area doing these outreaches. And if you're rather new to astronomy and you haven't done any outreaches, you don't know what you're missing. Yes, you get off work, or it's your Saturday, you're off, or the evening during the week, and they are looking for people to come to a school. When you get there and start interacting with the young people, it charges you up. I mean, you're dead tired, but you get going and you feed off the energy of the little ones. Here I have some nice Galileo replicas that were presented to me by a member of the ASKC. Many times it's during the day because they're young people. They're not going to be out late at night. And we set up displays for them where they can handle meteorites, a PST or Solar Max or some of the others, a C90 or 8-inch with a white light filter. But when you start seeing young kids, especially the young man on the right, it just changes your attitude. Or you get invited to a camp with young people with cancer. And you know, they tell you these kids will not make 18. And a little girl comes up and hugs you because you spent the night out there in the middle of the week in June after work, and you're showing this young girl that's 8 years old the rings of Saturn that she's never seen before. And then later, and she hugs you for that. And later on, you hear her, or before that, talking to another girl that she's on her 4th trial medicine to save her life. It changes you. I had to go off in the dark for a moment to compose myself and come back. That's the kind of touch you get from doing these outreach events. Many times they want hands-on activities. There's lots of them. NASA missions have hands-on activities. Your universities, you heard the AAVSO talking about information. It's out there. You can do it on a shoestring budget. We don't ask groups when we go out for these youth groups for donation. If a company asks us to come out and present or do something at their corporation, we will ask, would you mind giving a donation to support these types of events that we're doing? We're also looking at doing other places that don't get the attention. Homes for children with problems, special camps, kids that have delinquency problems. There's some in some of your, could be in your state parks. I didn't know one existed until I heard someone lost looking for it, that there's a youth home in the state park just across the street from me. Contact them, go to them. Nursing homes, yes, they are not youth, but they were at one time. And the stories you get from these people that lived through Sputnik, the Cold War, that were adults in their 30s or 40s or 20s back then, that want to talk about it and share. It's worth having a recorder and getting firsthand information like that. We also get invited to help at other events. I think the young man sitting at the table with the tie on, signing a book. As David mentioned, the Linda Hall Library, maybe the #1 place in the world for engineering and scientific journals and books. He could tell you about holding Galileo's book with notes in the margins, Copernicus original notes, Newton's. They have that there. They have a fabulous collection, and he was here speaking on his latest novel. If you haven't read it, it really opened up my eyes and helped me understand some of my life. And he's talking at UMKC. So, outreach, National Sharing the Sky, that's what we do. If you want more information, you can contact me. David has my information. All of you that are out there, I'm on the internet. National Sharing Sky is getting set up. We're switching over to the internet. We had some issues with that, but we're well going to be on our way. If you have taken gone to a event for outreach, share it with other people. It's like pulling teeth to get people to volunteer to do this. But once they get out and see the smiles and the questions, it's worth it. And talk to anybody that's here on the panel. They will tell you there's nothing better than doing outreach astronomy, getting somebody interested when they're young and keep them interested. National Sharing the Sky is going to be working with girls in the Kansas City area to form a girls astronomy club to get them going at the Vorkachevsky Observatory on the campus at the University of Missouri, Kansas City. Some of them are coming from the Girl Scouts that will be helping us, that have gone to training at Goddard, have studied under the Girls from Goddard Space Flight Center that went up there for training. So there are ways to do it. If you need more information, let me know. And David and Scott and the rest of us can point you in the right direction. And thank you for inviting me.
Thank you, Joe. That was really interesting. And really for me and Wendy, it was interesting to get a report on how our foundation is doing under your leadership. And I think it's doing just great.
Well,
I
was going to say, we're about like everybody else. We had to put things on hold, but we're making plans to get back in there. You got to run with the big dogs. You got to get off the porch.
You got to get off the porch. And I'm really glad. I was really glad to hear your presentation tonight. And while we're talking about that, I cannot praise Scotty highly enough for starting these global star parties. It was something that merits him the Nobel Prize without question. Scotty, congratulations. Those of you who can see a picture of me, well, you're seeing Scotty now, but those of you who can see my picture will see my telescope here. This is not a background. This is a real telescope that you're able to look at. I've had it since 1967. And now, Cesar, this is a global star party. And we have Cesar Brollo. I hope I pronounced your name right. All the way from Argentina.
Yes.
Thank you. Yeah. And I'm wondering if you would like to talk with us for a little bit.
Yes. Thank you to you, David. It's really an honor for me. I was really happy to accompany to the group of the Global Star Party in 40 editions, and it's a really honor for me share with you so a lot of special nights with the entire group, and really I enjoyed a lot this 40 nights, and this was for me a great was a great opportunity to talk about astronomy and share with amazing people the things that we love about the sky, the stars, telescopes, optics, and it's great for me share. Actually, I am working in an historic restoration of a very old solar observatory complex, and it's really great to work in a so important project here in Argentina, in San Miguel, that is a town in the Buenos Aires, outside Buenos Aires city, but in the Buenos Aires province, at only 30 kilometers from Buenos Aires city. And well, we are working really a lot for have anytime more near to start to work with this telescopes, the Celostrators, the White Light Telescope, the Lyot H Alpha Telescope, and well, I'm working with this group of Bella Vista El Cosmos is the name of the astronomy club. I have some pictures for to share with you if you like. Let me check where I have this. Only few pictures about this. In the last news is that next Friday we are going to remove. We need to move the main solar. It's not a solar. It's an all-size telescope refractor, and something that I have here is when we opening the first time last 1 year ago. We open one of this telescope, making a big effort to move the door of the observatory and a small observatory. And here I thought about this is the Obsidiana filter, a very old solar white light filter. Is not a filter with coating with layers. If not, it's a rock, a volcanic rock, grinding and polished, and have we think that maybe have a big knob, but big knob, but maybe naturally this well, I don't remember the name in English. This broken part is maybe appeared like something natural from the first time filter. Maybe it's not one piece, but work really properly. But this is the first time that we open the observatory, maybe before 30 years, and this is the Obsidiana filters. I remember the last time I say onyx because I remember the onyx broke instead of Obsidiana. No, it's Obsidiana.
Obsidian, I see.
Obsidian, yes. If we say Obsidiana, obsidian in yes, sorry.
But it's open, I guess, huh?
Yeah, this is the telescope. Actually, we are working with the telescope. Only we need to paint and clean a little more. This is our picture from the first time that we found it, and because it was like open a treasure. We don't knew in this time 1 year ago what we was founding in each dome that we are opening. And this is this Friday we are start to move in this. This is unfortunately is the vandalizing big size telescope, 8 inches refractor size. It's a great telescope. All of this, you can see that here the back focusing, the focusing, all in bronze was stolen. It's incredible, and we need to make the complete focusing for this telescope. This Friday we are going to remove the tube from the equatorial mount because the people from the government need to move from this area, the dome, and rebuild the entire observatory more near to the celostato. And well, it's something that we start to make this Friday, and it's really a great first step. This is the first time that we saw the celostato. Actually, we clean people from the majors, the major from this city of San Miguel. They send us a lot of people to start to clean, to start to get out the pigeons, because it was totally invaded by pigeons. We are starting to work in the recovering of the mirror that are okay, but we need to clean. Fortunately, in this case, in celostate mirrors, they don't use aluminum. If not, they use chrome, and it's very. The chrome is maybe not reflective in the percentage like aluminum, but it's strong and it's easy to clean. And we started to clean, and we have fortunately a very great quality and a great conditions the reflection of the mirrors of the celostate, the two mirrors. This is all that I have for tonight. But really, I say again that it's an honor share with the entire people in the Global Star Parties in this 40 special edition.
Thank you so much for joining us tonight. I think that was a lot of fun and very special. I think we should take a little break at this point because we have been going for some time. Let's break for 10 minutes. Is that okay, Scotty?
Okay.
We'll take break for 10 minutes. I'd like to give some of our speakers coming in after the break a chance to prepare a little bit. We have Rick Hill coming. We have Adrian Bradley from Michigan. Rick is from Tucson, Arizona. Then we'll have Peter Janicki all the way from London, Ontario, and Jason, who will be showing some astrophotographs. And so we've got exciting stuff coming up after these messages. Whoops, no messages. We're just going to take a break. See you in 10 minutes. Okay, Rick, we may all unmute now and have a general conversation.
So
Rick?
I'd like to test something that I'd like to play during my segment. I don't know if it's a good time to do that or just find out if it works.
Yeah, I'd like to. That would be great, but I think Rick is a little concerned about testing the system.
I'm good to go.
You're good to go?
Well, Rick, you go ahead and because you're going
okay, well,
first.
Rick is giving it over to you, Adrian. So if you'd like to test a little bit, that's fine.
Okay, there's a sharing going on already, so I can't share it. So I'll find out when it's my turn. What I have music that'll go with my slideshow, and I think the music will transfer. It'll transfer through. If it does, that'll be perfect. If not, I can explain the images that are there. So either way, I should be good. But hopefully the music does go through. It's a beautiful piano piece.
We hope you'll be good.
Yep.
And if not, we can all sing along. Okay. And
That'll work
hello,
for me.
Peter. It's good to see you. And I'm glad you're able to stay up so late and be with us tonight. And really glad.
Nice to be here, David and everyone.
Yeah, glad you're here.
Nice comments here. People thanking Cesar for his presentation. Norm Hughes says, a great show so far, Scott. Tell David he's doing an awesome job. Yeah.
In between
Can't get
all the
much better
stones
than having
coming
these
my
guys
way, I
on
can
the
see
show.
that.
Book Davey says, this is too cool. Great lineup tonight. One of the best from Chris Larson there. And Clearlight 58 says, David is a great host. So.
By the way, Dave, would you like me to read the resolution? We finally came up with one from the Warren Astronomical Society, making you a member. I can read it during my presentation, or we can read it now.
I would love it if you'd read it during the presentation, and especially if you could say what the vote was, especially if there were any negative votes for it. Anyway,
I will tell you what, I'll do that. I actually have it. I jotted down some notes for what I wanted to do. I should be able to get through my presentation fairly quickly, but we'll see.
Okay,
And,
we've got a little bit more time than I thought we did, because we had to do some last minute juggling at the beginning, but I think we were able to take this precious 10-minute break, and I think everything's going to be fine.
Oh, it's been running good. Yep, I'm going to take a quick break myself, and I have to remind my wife that I'm still alive down here.
Yeah.
And, then I have to run back down because I want to hear Rick's presentation.
Yeah, we don't want to miss that, and we don't want to miss yours. And we will see you all in 6 minutes and 2 seconds.
All right.
Rick, I thought last night was such a home run for you, and it was you and Dolores. It really was great.
It was a surprise. It was a surprise. They really were interested in the moon, which is my main focus. So
that's not what the surprise was. I mean,
yeah,
I thought the surprise that you and Dolores were really so.
We were completely cut off. We didn't hear any of that presentation. For some reason, we weren't getting any sound at that time. And it was really sad. I wish somebody had recorded it.
Well, I think someone did record it. I think the thing is recorded somewhere.
Oh.
Actually, no. I think when we started talking, it was after the main presentation was over. And the wonderful... Yeah, we stopped the YouTube video, and all of that wonderful talk about the moon and me moving in and out and those things, that was basically after meeting Bar Talk, and it basically got lost in the internet. It was a wonderful memory, but I don't think we recorded it. It would have been a great impromptu recording, but I think the Warren Club had stopped the.
All I saw was she was holding up a plaque, and I didn't know what the plaque was.
That was your lifetime membership.
I'll look forward to that.
Yeah, we're trying to figure out who's going to drive it down to you. It's going to be one of us, I think.
I thought it was. I can't remember his name now. Benton.
Yeah, I remember. Someone said that they would try and get it to you. I remember hearing that too.
He wanted to come
and
down.
And I said, I'm coming. Yeah, my plans I just registered today for Okie-Tech. So I'm actually set for the 8 days, of which if I get a perfectly clear day on any of those 8 days, I will be, I'll probably bolt out of there to head to Arizona. So I'm hoping to visit with you all.
Well, we're hoping to see you.
That'll definitely happen.
Rick, did you hear any of my talk
tonight?
No, I mean last night.
Yes.
Okay, you did hear that part.
Well, you talked about coming up to the Burl Schmidt and everything.
Yeah.
Yeah. I'll be showing the Burl Schmidt tonight.
Great. Great. That's going to be an exciting talk that's coming up in 2 minutes and 56
Isn't it?
seconds.
I see the countdown. Yes.
Hey, the Earth didn't explode after the first countdown.
That would be funny if you hit 0 and the Earth just blows up.
Yeah. Well.
And hi, Peter. I haven't seen you in a very long time. I think it's the 1980s was the last time we saw each other.
Yeah, I think you're right, Rick. But you're still down there in Tucson, and Diane and I have been down there to visit a few times in the last couple of years. This year, obviously not, but we would love to see you guys again.
We can do that.
Yeah, I sure like to.
Now that I'm retired, especially.
Oh, I love being retired. You do nothing all day.
Wake up when you want to, stay up till 2 or 3 in the morning.
Tell me, yes.
Yeah, love it. And Cesar, I loved your talk on the telescopes there. You're making me jealous. I'm an old telescope maker. I was an optician in the 1970s. I would love that project. That would be so much fun. Even the cracked lens. I can make a new lens. That's not a problem.
Yeah.
That particular lens is a piece of flat obsidian. Obsidian.
Yeah.
It's used as a solar.
Now, I thought obsidian was opaque and black.
It is. Well, I guess it's got optical properties.
Yes.
Well, yeah.
It's incredible that they make with a rock, not a glass.
Yeah.
They make an flat parallel 1 inches excellent quality filter, and they use it's incredible because they calculate how many thick they needed to use, because they only calculate in the darkness of the obsidian. They say, okay, we need maybe 1 inches to have a safe filtering to watch while we make a picture of the sun. And this instrument have 2 telescopes, one for observing, that is that actually we are turning the obsidian for observing, turning to use for a reflex camera or CCD. And
Cesar, I'm going to have to stop you at this point because we're about to start again. We're about to start our meeting, but thank you. Yeah. Good evening, everyone, and welcome back. Do I start right away, or does Scotty have to? Does Scotty want to do some introductions first? So you want me just to go on? Yep. Okay, thanks, Scotty. A few days ago, someone who will remain nameless came up to me and he said, I would like nothing more than to discover a comet with you. And the thing that went into my brain was, what do you know about searching for comets? Do you think that we just go outside, look through a telescope, and oh, there's a comet. That's great. And oh, there's another comet. That's great. What do you know about the stress, the patience, the years it takes for even one comet, and the passion that it takes? I know someone here who does know that, and that's Rick Hill, who has discovered no fewer than 27 comets. And Rick, to say that I am proud to be your friend and to know you for the accomplishments that you've made with everything you've done is a serious understatement. And now we're going to hear a little bit, not about comets from Rick Hill, but about the thing that he was involved in when he and his wife Dolores first relocated to Arizona, working with Schmidt cameras. And now take it away, Rick Hill.
Okay, let me bring my screen up here. Are we still there?
Oh, yes, we're there.
Okay, good.
Might want to take it into presentation mode. Slideshow mode.
I'm trying to, it's closed on me. Should be just F5. There we go.
There you go.
There we go. When I first came here from Michigan, I was an optician in Michigan, and I answered an ad at Warren Swayze Observatory they were looking for a resident observer, and I answered that ad. And after a lot of selection process, I was the number 2 person chosen for the job. The number 1 person was Dean Kettleson. And Dean got tired of waiting for the wheels of administration to turn. In case he went and got a job direct with Kit Peak, and I got the job with Case. And it was working with a Schmidt camera. Now, Schmidt was an optician in Germany around the turn of the last century. And he was a very unfortunate young man. He liked to do something I was always interested in as a kid, and that was building rockets. Except he did it by packing gunpowder into pipes. And it resulted in an explosion that took off the index finger and the thumb on his right hand. His mother's medical treatment for that led to infection, and he lost the whole hand. And so he was a one-armed man, understand, a one-armed man who invented one of the most popular telescope designs ever in world history. And that's the Schmidt. Most of you know what a Schmidt camera looks like, with a corrector up at the top. And then it goes down and hits a spherical mirror and focuses on what used to be a photographic plate, but today we use CCDs. And the corrector plate up here is as a plate that creates aberrations. And the aberrations are exactly the same aberrations, but the opposite sign of those created by a spherical mirror. And it gives you a wide field with sharp images right to the edge. This is a cutaway drawing by no less than Russell Porter, the same fellow who did all the great 200-inch drawings. And this is of the Burl Schmidt telescope that was at Case Western in Cleveland, Ohio. Why anybody would put a telescope in Cleveland, Ohio, I don't know. But then again, you've got another 40-inch telescope in downtown Toledo, Ohio, and it seems to be doing science all the time. You have the corrector plate up here, then the primary mirror down here, and that's where the photographic plate went. I lived to the end of its photographic era and the beginning of its CCD era. This is a picture of the telescope as it was in Cleveland, Ohio, and that's J.J. Nassau down there showing, I don't know who, but showing him the setting circles of the telescope. And it was moved to Tucson, Arizona, and I met a number of you then. Peter, I think I had you up at that telescope at one time. And I had John Briggs up there, I know, at one time. And this is what the telescope looked like. That's a GM blue color. The fellow who had the telescope repainted was Bill Shaning out at Kit Peak. And he built cars for a hobby, and he liked this color that GM used on their cars, and he had the whole telescope powder coated back in 1979 with that. And now, David, you used this telescope when you came out to Kit Peak. You may not remember. You used the finder scope here, a 9-inch refractor made by Carl Lundin, the understudy of Alvin Clark. And it was a very fine piece of optics. And you used it for, you did hundreds of observations of Orion Nebula variables. And you spent a whole night there.
The Orion variables at the time.
I can't hear that. But there I am at the eyepiece of the 4.5-inch finder scope.
I was just trying to say that I was doing a lot of Orion variables at the time.
Yeah. You did. You know, you forgot to mention one thing last night in your talk, of the night you and I observed all 9 planets from the backyard of this observatory.
How many planets?
Huh?
How many planets?
9. Pluto was a planet back then. And I remember we got to the very end and we said, we haven't observed one of them. We bent over and looked at the Earth.
That's for another night, but that's a good point you made.
Now this telescope used setting circles and everything, but when I left, it was all digital and it had a nice CCD and a 4K CCD, which was a big CCD back in those days. I left in 1993. From there, I went through a period where I was using Celestron 14s to travel all over the Earth and chase occultations with the occultation group at Lunar and Planetary Lab. And then I wound up on this telescope. This telescope was built originally for one of the astronomers at LPL who studied comets. And she had it rushed through production because Comet Kohoutek came up all of a sudden, was supposed to be the greatest comet in a century. And they had to have this telescope in a big hurry. We rebuilt this telescope for the Catalina Sky Survey. It was the first telescope used by Catalina Sky Survey. It has found literally thousands of asteroids. It has found more asteroids than were known to exist when I started working with this telescope. And it's a real workhorse of a telescope, but it's starting to get a little long in the tooth because its magnitude limit is around 19.5, 20 magnitude. And the game is now fainter than that for most asteroids. Then I went from there, after I retired after using that telescope and several others, I went to my own backyard observatory where I have the old classical Schmidt-Cassegrain telescope. Many of you have these and are familiar with them. I've had about a dozen of them. I've had a couple of C14s, as you see up in the corner there. In fact, that C14 was put on a long-term loan with me. That's the one we chased around the world with. We would set it up in all these different places around the world. The last place we set it up and observed occultations before we lost funding for that project was on Madeira Island off the coast of Morocco. And we watched an occultation of Triton, by Triton, of a distant star. And we measured the scale height of the atmosphere and everything. And on the way home, I took 5 days off to see London, England. My first day in London, England was 9/11/2001. And I wasn't sure I was going to get out of England in any time soon. I was thinking about getting their equivalent of a green card at the time. And then a C11, which I had over here in my backyard observatory. And a C5, which I'll never get rid of. This C5, the optics were made by a local optician by the name of Bob Goff.
Oh, yeah.
And he's gone now, but the optics in all of these telescopes you see here were superb. This telescope wound up at the Arizona Sonora Desert Museum. I don't know if they still have it. I bought them 3 more Celestron 8s as well. And it was an excellent instrument. These are the Schmidts I've worked with, and some of them professionally, some of them as an amateur. Still have a number of them, although I tend to like the Maksudov Cassegrain today, and I have 3 or 4 of those, culminating with the 8-inch f20 Maksudov Cassegrain that I use for lunar, planetary, and just lunar and planetary. I don't do solar observing with that one. My sight is not good enough for solar observing with that aperture. So if you want to see more about this stuff, you can go to my website right there, and I would be glad to answer any questions you might have about this.
I am posting your website up on the
You're going to it right now, I see.
Yeah, and I on my Mac keyboard here, I do not see that squiggly. Let me find it. Ah, here it is. There we go. And there we are.
Here, I could share that too. I think I can.
Yeah, it looks like a big gray square.
The little Schmidt that could.
Yes. I think you can all see this now.
Yes.
So you can go to my website. I was showing this website last night, but one of the things I did is
I remember going through it.
yeah, I for the last year and a half, I've been laid up and much of the time in a wheelchair. It turned out it was my hip and I had to have it replaced. And during that time, I got this, I was always curious about the quality of these Schmidt Cassegrains, the Dynamax. I'd heard bad stories about them, but this one was $285. How can you go wrong? It was inherited by a son and the father almost never used it. It's in pristine condition when I got it.
Wow.
That's my protection for it in the backyard.
Mm-hmm. And how is it?
It is an excellent telescope. There are the clouds on Venus with it.
Wow.
Some Venus images. This is on the website too. There's Mercury. You can see a little bit of modeling, but for a 6-inch aperture, what do you expect? Jupiter. I have pictures of a lot of things there with it. This is one thing I like to do each year. This is the Seeliger effect on Saturn, where the rings get brighter with respect to the ball of the planet right at opposition. I like to photograph that every year. It does an absolutely excellent job, even though we had a terrible last summer. This is smoke across the desert Southwest last summer. It was very difficult. I was having to shoot through a lot of smoke much of the time. But you can go there and you can spend some time looking at it. Beautiful double stars I got with it. This is the triple star Beta Monoceros and Zeta Cancri, another triple star. And this is Alpha Coma Berenices, which doesn't look impressive until you realize its separation is 0.5 arc seconds. And a 6-inch aperture is the Dawes limit is 0.76 arc seconds. So this telescope stood up very well to the tests I put it to. And I have no complaints. Oh, these are my expensive slow motion controls.
Oh, these are great.
They're made with popsicle sticks, take about 15 minutes, and it just takes one finger to move those. I can easily guide, and when I'm taking images or AVIs of the planets, I can easily move it in declination with one finger very smoothly and slowly.
And you reduce shake on the telescope when you
That's
do
exactly
that.
right.
That's a brilliant idea, Rick.
And I just don't have money to spend on all these expensive motors and everything. And so for the Questar, I got a little fancier because the Questar is a fancy telescope. And I used hemostats that I heated and then reformed so that they would grip the knobs without hurting them. I'm a cheap guy. I'm really cheap. I'm a cheap old ATM. So with that, I'll entertain any questions. You're welcome to go to my website and abuse yourself there. I've also got a paleo page because another one of my hobbies is paleontology. And there's some paleo area where I work at. I love micropaleontology.
Rick, I have a question for you.
Sure.
Do you know if the early history of Schmidt cameras in the USA, who built them? Before the big one at Palomar, which I think opened in 1948, were there a lot of Schmidts around before that?
No, there weren't. And I think the first one they built was the 16-inch Schmidt.
18-inch.
Is it 18?
18-inch.
It's in the museum now. It's not.
Do you know what year it started?
Oh yeah, that was back in the 30s. Remember, Bernard Schmidt didn't come up with the Schmidt design until the late 1920s.
Yeah,
that's when he made the first one, which was a 14.5-inch. Up until then, he'd been making ordinary telescopes and camera lenses since 1901, and he made the first one in Germany, and then I guess Hale probably saw it and had to have one. But it was an innovation because up until then, only sky surveys could only be done 1 degree or 2 degrees at a time, and the imaging at the corners of the field were never good. And so this was a real innovation, and it caught on pretty quick. But he built, I think, the 18-inch, if you will, at Palomar was probably the first one in the U.S. unless Unc Ingalls built one. I don't know. Unc Ingalls is the fellow who's responsible for the ATM book series. I have his name currently in process with the IAU to have an asteroid named after him.
How long that process can take some time now, but
yeah, it's
I'm
taken
really
over
glad
a
you're
year.
doing that.
It's
I'm
taken
really
over a
glad
year.
you're doing that. Rick, anyway, thank you so much.
You're welcome.
I had so much fun observing with you, just sort of not really using that telescope, but watching you use it and watching you do the science you did with it over those years.
And you and
it was so much fun.
You and I saw Pluto through the smallest telescope I've ever seen it through. We saw it through that 6-inch f5 that
That's
I had.
This telescope right here.
No, it was my 6-inch f5.
Yeah, might have been yours. Anyway, but I remember bringing this one up here. It was at a different tube at the time, but
I think so.
I brought it up quite often.
And you brought up
with you.
8-inch cave you had too.
Yeah, which I still have. And that is the finest optical system I own right now. Is the
They are excellent telescopes. Yes.
Yeah.
Hey, Rick,
you.
could you say a word about the Jim Loudon Observatory? I used to know Jim back in the day.
Yeah. Well, Jim Loudon was a personal friend. He was a mentor to Dolores and me back in the 1970s and actually got us into planetary astronomy. And when we came out here, he had been our teacher. We got out here, he was calling us up all the time to find out what's the latest and what's the cutting edge. And we were just shocked in 1988 when he died at the tender age of 44 years old. Right. And I immediately said, that's going to be my observatory name after that. There's if you go again to my website, let me share the screen real quickly and I'll get out of here. Go to the Jim Loudon Observatory. It says, who is Jim?
Oh, yeah.
Who is Jim Loudon? I not only have a description of Jim Loudon, and most of it's his own description of himself, but I've got a bunch of his lecture series that I've digitized and put on the website there, so you can enjoy those as well.
Terrific. Thanks.
There's
Thank you. Good question, Clark, and thank you, Rick. And this is the telescope that I think that I had up at Kitt Peak with me, although it may have been yours, Rick.
Yeah, I've never looked through the one with the carbon tube on it. But.
No, it has had its cube changed in recent years.
Me
but
too.
The optics are the same. The optics are the same. Anyway, we're going to move on. We're going to press on right now. And as I mentioned earlier tonight, talking about Adrian and the quality of the photographs that he has taken over the years, it has been so special to see those pictures. Looking up at the night sky is an incredible thing to do, but the way Adrian photographs it makes them doubly so. And now, handing it over to Adrian. Take it away.
All right. Well, thank you for handing it over. I wrote myself some notes that I could promptly forget, even though they're in front of me. But thank you for inviting me, David, and to all of you. It's an honor to be here. I'm here. Several astronomy clubs, the University Lowbrow Astronomers. I'm a member of the Warren Astronomical Society. I met David Levy as being a part of the Lowbrow Astronomy Club. He gave a talk for us, and I remember being inspired by his love of the night sky. Prior to that, he gave a talk at the University of Michigan and gave the famous words, "If you didn't write it down, it's not an observation." Mm-hmm. And as someone who had been learning visual astronomy at the time, I was notorious for not writing it down. So part of the reason that I got into photographs was, if I'm not going to write it down, I'll take a picture of it so that it reminds me of what I saw. So later on tonight, you're going to see some amazing astrophotography by Jason Gunzel, who's hanging in there with his beautiful image of the sun behind him. So look forward to that. But back to David, David, as he's called by all of you call him. We have made him a Warren Astronomical Society member, and I would like to read the resolution. I'm going to start sharing the screen. And what I'll do is share the resolution that we made for him. Here it is. This is being sent to you, David, and I'll read it. Dear David, at the regular monthly board meeting of the Warren Astronomical Society held on April 5th, 2021, the following resolution was presented for consideration and adoption. Whereas, in recognition of his contributions to the Warren Astronomical Society paper and his participation and contributions to the virtual monthly meetings of the Warren Astronomical Society and his contributions to the astronomical community at large, which all of you have been listening to throughout this star party. Therefore, let it be resolved that the board of the Warren Astronomical Society bestows on David H. Levy honorary membership to the Warren Astronomical Society. The motion came from Dale Timmy, supported by Dr. Dale Parton, and it says 6 yeas, but there's really 7 because I said we should make him a member before it even got to the board. And so here we are, the board of the Warren Astronomical Society. And this is your official honorary document of honorary membership to our Warren Astronomical Society. So thank you for all that you've done. And of course, all of you will be invited on this panel, and all of you watching out on the internet are invited to come to go to an astronomy meeting, find out the nearest astronomy society near you, and attend it. Most of us are doing it online. And until we can get out and see the stars, we invite you to go out and see the night sky. So now I'm going to do another share. This time I will share my screen. You all came here hearing that I take pictures. Well, some of these pictures will be featured in a video, well, a montage that I put together with some music.
Adrian, before we go much further, if the music is in any way professionally recorded, even if you are the one that re-recorded it, apparently that's going to be a problem. Sony,
okay,
and many others, they have these new
I worried about that
algorithms on Facebook and YouTube, and they pick it up like that, and they'll shut
and they
us
pick
down.
it up and they'll shut down the
Shut it down.
it's
5 countries. So
okay, yeah. So the name of the tune is I Remember Well, and it actually goes well. My chasing of the night sky, I'll just share my entire screen. Those were some of the pictures that I'll share. So what I'll do is just go through them then. I was prepared to call an audible. So my chasing of the night sky has taken me to a number of places, and I jotted all of these down. In Michigan, there are a number of places that you can go that are dark enough to image a beautiful night sky. From the countryside in Milan to the Lake Hudson Dark Sky Preserve in Clayton. These are all places in Michigan. So from wherever you are, go to your dark sky, look up a dark sky page and look up where the darker areas in your state, your country are, and try to get to them, because the night sky is beautiful when you can get out away from lights. Broward Nature Preserve, Peach Mountain, Clinton Township, Alcona Park, Port Austin, Highway 123 to Quamanon Falls. The Point Albarkes Lighthouse is one of the darker places that I've been. The UP, which I thought, Highway 123 is even darker. There's a roadside park at Port Hope where I stopped and imaged. Port Crescent Dark Sky Park. I listed 10 or 15 places The driving out to those places just to see the dark skies is something that I have enjoyed doing. So with that, let's share the screen, and I don't know if I can if I turn this down. Here's the slideshow. If music starts playing, just let me know. I'm going to turn this down so that it'll just play the slideshow. This is starting with this is my very first image of the Milky Way that I attempted. Very grainy. Yeah, done with a 30D and an old kit lens, 18-55. Those of you in photography know that it's pretty impressive to get a result like this. I've actually got a slight Milky Way over Ann Arbor, one of the more light polluted places that you would see the Milky Way from. But this was the start of my journey, just believing, you know what, I barely see it in this countryside field, and I'm going to try and image it. So let's see, it's not letting me step forward a frame. I came back later and turned to the north and imaged the field, and this is a northern star field. Good luck finding the Big Dipper in this. It's actually over here. Lake Hudson in the winter.
It's beautiful.
Sometimes your clouds help you make a beautiful star thing, and this is how I'll go through just these images. Yeah, this is this effect of larger stars. You can buy a filter, or you can wait for these high clouds to be present. I've seen this happen for me in the winter more so than other seasons, and it makes for a beautiful starscape. There's my truck. That's the same truck I travel with. I go here and there, and I go places to do imaging. These are some earlier images. And of course, when you see this part of the Milky Way, you're looking at a summer image. This is Lake Hudson State Park in the summer. A nice dark sky park in Michigan. It's actually about 30 minutes from Ohio. And it's a beautiful place to observe. The light dome has been getting higher at Lake Hudson. It's been a little disappointing that it's not as dark as it may have been 2 or 3 years ago. That's kind of the part of the fight with light pollution that we have to deal with. But you can still pull off beautiful images. Here, we're at another part of Lake Hudson, a boat launch. And look at all the stars in the sky. This is an image, if you live in Michigan, you'll see this hanging at a camera shop in Ann Arbor. It's called Camera Mall. I submitted it for a contest, and I came in second to a beautiful Milky Way shot over a river in another part of Michigan. This one won a prize because I got lucky. The quick story behind this is the image I took prior, I saw a meteor go underneath my frame. I turned it back around, started imaging the core again. Someone next to me says, "Hey, did you see that meteor?" "What meteor?" I look on my camera, which was a 20-second exposure on my camera, and at the time I wasn't using a tracker. And I look and see this bright streak. I sent it to my job. It ended up in the calendar for that year. Broward Nature Preserve in Ann Arbor, Michigan. A few people know of this place. This was a winter shot. You have this beautiful tree and you have all these stars. You can, with the right imaging tools, you can pull stars out in places, even if there's cities nearby. It's something that I enjoy doing, is uncovering the beauty of a place. So let's see, that goes that way. I'll click here. Turn to the south, I caught a meteor. Quick story with this one, this was a year, it was a year since we had lost one of our club members. John Coslin owned a huge telescope. He always held star parties at his house. We lost him to we lost him to what I think kind of turns out to be a heart condition after a race, and it was the anniversary of his passing. I went out the image and I said, "Okay, John, it'd be a good time to send me a meteor," just like that other image where I had a meteor. I look away as I'm taking this frame, and then I go back and look on the screen again, and there is this streak coming right through the center of the galaxy as astronomical twilight is ending. So I looked up and I said, "Thank you, John." And even though this may not be the best Milky Way picture I'll ever take, it's definitely an emotional one. There's Jupiter and there's Saturn. This was taken, of course, last year. And as the season went and the Milky Way started to recede, I captured it over heading towards this big tall tree here. Out at Peach Mountain, where the lowbrows observe, I was able to isolate the Milky Way here. As you can tell, I enjoy chasing the Milky Way. I consider myself a Milky Way chaser. And this is a couple years ago because Jupiter is right here. Jupiter moved in 2019 from here, 2020 it ended up here, and in 2021 it's a little further along. So this is a 2019 photo. And so is this. I can find out all of the settings and everything that I use. I just prefer talking about my feelings as I take these photos. And you can always email me if there's a certain picture you like in settings. Most of the time, 30 seconds, a high ISO, and depending on where I'm shooting. If I'm at a dark site, I go with a higher ISO. Here you have this oak tree right here, and just the night sky. I come from an astronomy background, so a lot of my pictures will be of the night sky, more so than the ground. But every once in a while, you get a good foreground object, and it's cloudy. I'll still go out and take an image. So here you have an image with some colors, which it looks very artsy, or there may be a reason that those colors are there. Either way, I love this picture. This is one of the outliers because it's one of the few that I like that don't have any stars in it. But it's still the night sky, and it's still a beautiful image to me. Alcona Park, Milky Way splitting the trees. Brian Adam, whom, if he's not watching, one of my mentors in doing night sky photography, took me out here, and that is one of the images that I got. I just headed back a year later, again, using clouds. I call this one Lonely Road because it's what it looks like. And later I would take this photo, light pillars. Those of you that have not seen light pillars, you are seeing them. It's not aurora. It's actually light from, there's ice crystals in the atmosphere, it's cold enough, and light from the nearby town is being refracted into columns. And if there's enough light and you're at a certain distance, you end up getting this effect where you see all of these light columns. This one had the opportunity of being an apod. I think it either fell short or it's in purgatory going through some social media sites to see how it responds. But I just like the image because I put Orion. You notice Orion in a lot of the later images that I've taken. Taurus and the Pleiades are being swallowed up by aliens here from the light pillar cloud. So unfortunate for the Pleiades in that shot. Mackinac Bridge. You can get stars over the Mackinac Bridge. It's fairly well lit, but this is a single shot. You've seen some shots where you may have composites, where it'll show you if the Milky Way is rising, it rises here. This is south, so the Milky Way could rise here. I haven't gone to see if I can take a picture of the Milky Way in one shot. I've seen a lot of composites. This is a single shot, and yes, that's Orion. It's a star field. It is possible to put stars over the Mackinac Bridge. I was once at the Golden Gate Bridge, but I didn't have the fast lens that I used for this. So I don't know if it's possible to get stars over the Golden Gate Bridge. Maybe one day I'll find out. This was one of David's favorite images. Even though the trees are a little blurry, it's more about the composition. And I took a long image of this. This was around 2 minutes on a tracker to expose the rosette, some of Barnard's Loop, all of the nebulosity that's here. I think even this is the witch's head, even though it's not showing up as typical blue. At Port Austin, we're talking about dark sites now. This is where I would love everybody to go if you get the opportunity. Get somewhere dark. Satellites go through your dark sky field. This is taken with a camera and a lens, I would say around 100 millimeters or so, maybe more, for about a minute and a half. And at a dark site, an unmodified camera will pull down this data. It can also show you how many satellites we have to contend with. I think there's more over here somewhere. So this is not only just a beautiful star field, it's a sign of things to come with the issues that we face concerning satellite constellations, which we know more of them are coming up in the near future. So that image
that's a single
shows
frame.
that. That is a single frame, which is
of a minute and a half. So those are geosync.
minute and a half single frame. Yeah, that is one single frame. So now the internet that the and I know I may be running over my time. I know, David, you wanted me to speak for 15 minutes, and I'm just going. The internet that the satellites are supposed to spread all over the world may be useful. However, we want to see the night sky. We're going to have to contend with this. So we don't know of any solutions, but I know that there's been attempts to talk to Elon Musk and figure out cloaking the satellites or doing something. Other companies want to put satellites up there too. This would probably be a great place to end, but I've got a few more places to show you. So I'll just run through them. Daybreak at Tequamanon Falls. You can still see some stars. Barely see the Milky Way's gone by now over here. And my favorite place, Point Albarque's Lighthouse. I took a lot of study shots here before I was able to get some good ones. So there's half stars, half clouds. Same thing. Walk right up to the lighthouse. Just try a few different compositions. And turn around from the lighthouse, and this is what you see. I think that same night. When it's dark, there's your winter Milky Way and some of your lights. This is a beautiful place to go. Full moon photography. We don't stop shooting just because the full moon is out. We use it to create beautiful landscapes. And sometimes we get lucky and we get a beautiful shot like this where you've got the moon having risen quite a ways and you get this effect. So this is one of those shots I was surprised that it turned out. All right, Milky Way over Lake Huron, that's the ISS. And I'll go ahead and move along. This is kind of the opposite side. I think I jumped back towards Lake Hudson with this one.
From a NASA image.
And there's a winter Milky Way right there. You can see how much easier it is to image the summer Milky Way. There's a summer Milky Way over Lake Huron at a roadside park. If you recognize this, there's the coat hanger. For those of you visual astronomers, there's a coat hanger in that shot. This is daybreak. Of course, I pulled in a lot of the blue from daybreak. This is the point at which the Milky Way is still visible, but it fades by the minute. So you take this shot, 5 minutes later, your next shot's not going to have any of this. Another 5 minutes, you lose the entire Milky Way when the sun rises. So here is a naked eye visible, and I think some of you from last night at the Warren Astronomy, I shared this. When you're in Bortle 2 skies, this is how the Milky Way appears. You see color and you see structure. It is that visible in Bortle 2 skies. For Milky Way Chaser, it was just awesome to sit there and look at it. You know, with all the stars are there. There is Antares from the Scorpion. Sagittarius rises. Now, of course, Milky Way shooters, we like to edit and make the Milky Way stand out. So when we do, this is what we get. All of that detail here. I didn't quite catch the coat hanger this time. There's a star cluster. I think this is from Aquila the Eagle. I used to know all my stars, and now this blanks. From the Summer Triangle. Well, the constellation is Aquila. Altair. Thank you. Over here, you've got M8 and M20, and you can tell I need to learn my night sky so I can know what these are. I know if you go up the chain, you see M16, M17, quite a few objects, which should be visible. This is my deepest Milky Way shot to date, and I have more planned. So back to point out Barkeys, and as we come closer to the end of this slideshow, I did my best to get some beautiful shots out at Point Out Barkeys, and there's the Milky Way again. It's not as dark, but it's close. And I like you incorporating the lake or large body of water with Milky Way shots. Study shots. I come to this place and I take this shot, and it just looks like a frozen lake. And I come back, it's frozen, but there's a bunch of stars in the sky. So these were my aurora hunting shots. I was basically taking study shots because this is north, and I figure at some point I'll get aurora here. I thought I had it, but no, I don't know. It's kind of hard to tell. But I got the winter Milky Way. Finally, at spring solstice, aurora. There are the pillars that were visible naked eye. The colors weren't as visible, but these pillars were visible. And I went and took more pictures from different spots. There's my picture of the aurora, a little Milky Way. These last few pictures you're seeing are among my favorite and pictures I've taken recently. Those of you that haven't seen the zodiacal light, I happened to catch it at Port Crescent. And there's Andromeda. The Andromeda Galaxy makes an appearance over here. The winter Milky Way, you can kind of see it here. It's making an appearance. And Port Crescent, this is Lake Huron, a little different angle. As nightfall fell, the zodiacal light, this is twilight, and twilight's done, zodiacal light remains. You have Orion here, you have more Milky Way. There's Andromeda hanging out, getting ready to set. And at times I'll fire directly into the night sky and pick out large clusters. Those of you on the panel probably know what this cluster is based on what you're seeing with the triangle of stars, the triangle here. For those that don't, this is known as M44, the beehive. And with your camera, your tracker, a large lens, you can take down some large clusters and image those. This is a single, I think this is a 1 minute shot. But alas, sometimes the day has to break, ruins our night sky. And when you see the sun, you pack up your things, you go home, and you plan to come out the next night that it's not cloudy. So that's the end of my presentation. If there's any questions about how I take the images, feel free to ask those. And otherwise, as you can tell by all those pictures, there's a passion that burns for getting night sky images and representing the night sky the way that I see it. It's not just a bunch of stars that frame some sort of foreground. It is the star of the show for me, and that is how I represent it. So with that, I'll turn it back over to you, Dave.
Thank you. As the hour is getting later, if we're going to have an after party afterwards, during which you may ask Adrian all the questions you like, except to say that I feel like I've just been on a tour through a museum of fine arts. The emotion, the feeling of these images of Adrian's just goes right through me like a rocket launch. It's so moving. And I really especially enjoyed the images that he showed us of the clusters coming up. And that brings us nicely to our next speaker. Now we're going to move all the way across the border into Canada. I understand the Canadian border is closed, but they've just opened it for us so that we can cross the border at Detroit, Michigan, saying farewell to Adrian, who's going to stay with us for a while. And we're going to London, Ontario, where we're going to see the Saturn V rocket and Peter Jedicke sitting right next to it. I love that Saturn V, Peter. I first met Peter in 1979. He was giving a lecture to the Kingston Center of the Royal Astronomical Society of Canada. And I was waiting for him. I had no idea what he looked like. This tall guy, lanky guy, got off the train and he came up to me and I'm about to say hello. And he says, "We got to wait to watch because I love watching the train go." And I said, "Yeah, I do too." So we just stood there, two strangers like doofuses, watching this train leave the station. I'll never forget that. Anyway, Peter over the years has developed many talents, including being national president of the Royal Astronomical Society of Canada, including learning all there is to know about Schmidt cameras. That I think he learned a lot of it from Rick and Dolores Hill. And what he didn't learn from Rick Hill, he learned from studying. He actually joined us at one of our 18-inch observing runs in 1994. And then he did an awful lot of things, but became recently excited about globular clusters. And that is what he is going to talk about tonight. So take it away, Peter Jedicke.
Well, thank you very much, David. And it's really a pleasure to be here, of course. I really enjoy the whole evening as I've seen it so far. It's been great fun. And so I'm going to share with you some thoughts about globular clusters. And that's going to start me off. Can everybody see my screen?
Yes.
Very good. Everybody seeing my screen okay?
Yes.
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 Great. Okay, so
Yes.
I use this as my splash screen. As David said, I'm a keen member of the Royal Astronomical Society of Canada. It's been mentioned here a couple times this evening. And in fact, Scott and some RASC leaders did a global star party type of event some months ago already, where we did it across Canada. And for those of you who are listening to this program right now across Canada, friends of mine, family, a big shout out to all of you. I'm going to talk about globular clusters and, why might someone take an interest in globular clusters? Do we hear enough about them, or is there more that we should know? And I'd like to maybe answer some of those questions and make you think of those things. Most folks, when they hear about globular clusters and learn what might be printed in a introductory astronomy textbook, usually there's only like one paragraph. So you usually see just, one big blob of stars. And so that kind of sticks in folks' minds. And I hope that there's more that I can share with you about that. I know that our MC tonight, David Levy, is a big fan of Shakespeare. So I thought I'd start with one of my favorite Shakespeare quotes from Macbeth, where Macbeth is starting to contemplate what he might have to do to make himself king, and he's not so sure he wants his deep desires to be revealed yet. So he says, "Stars, hide your fires." And this, of course, is a photo from the Hubble Space Telescope, from the Hubble Heritage Collection. You know, when folks think of globular clusters as just being this incredibly dense conglomeration of stars, that's very impressive, and this is a really beautiful photo, but you end up losing a lot. You end up overlooking a fair bit of interesting details that folks should think about a little bit. Let's stay with M13. It is the most famous of the globular clusters, at least in the Northern Hemisphere. And so if someone is observing this summer, let's say, in a couple of months, and they want to see something that inspires them, then one of the things they might look at is the constellation Hercules rising in the east. And, you know, when you look at the night sky, it doesn't come complete with these convenient little lines joining the stars. But that's the artist's license to bring that in. And if you look, I'm not sure if my mouse will show up, but if you look along the right edge here of what's called the keystone, the 4 stars that make up the main center of Hercules, if you look along the right edge about a third of the way along, you see a little fuzzy patch. And notwithstanding the fact that there are no lines in the sky, your unaided eye should be able to pick up a little tiny bit of fuzziness on a decent night there. And that is, of course, M13, the 13th item in Messier's famous catalog. That is what we're going to start with. And I think it's only fair to say that most folks think of M13 immediately when globular clusters are mentioned, especially in the Northern Hemisphere. If you looked at it through a smaller telescope, you might see it a little bit more detailed. The 2 stars that are sort of upper center and lower left here, I often nickname them the rabbit ears just because they kind of look like ears on the cluster. The cluster in this photo, which the credit goes to Ryan Betts, I pulled this off the internet today. This photograph kind of shows what it might look like through a small telescope. And, you know, again, it just gives you a hint that there's something really spectacular waiting for you if you follow these things a little more closely and try and learn a little bit more about them. M13, of course, being the brightest of these objects that's visible from the Northern Hemisphere, probably was the first one that was seen. And, you know, it probably was seen in ancient times, but the folks in ancient times tended to write down only what they expected and not what they actually saw with their eyes. The first mention of anything in the field of globular clusters was that Ptolemy did write about it, but he didn't comment about it or, you know, make any kind of a speculation on why it wasn't star-like. But it was Edmund Halley, of course, who's quite famous as being quite a good observer and having a good head on his shoulders. He wrote about M13 in the 18th century, and he usually gets credit for being the first person to really see it, which was a few decades even, before Messier made the famous list of false comets. And there are actually many clusters on the Messier list. It turns out that one of the important things about globular clusters for us to learn is that, in fact, there are only a smaller handful of globular clusters that are visible in the night sky. So even though we think of thousands of stars, and even with the open clusters, there's thousands of those that are accessible with telescopes, with globular clusters, you have a much more manageable list. And they are impressive because some of them are so bright, so huge. They're not that far away in cosmological terms. Anyway, going forward another few decades, William Herschel had what was at the time the biggest telescope in the world, and he basically found all of the globular clusters that are on the modern list, at least for the Northern Hemisphere. And his son, John Herschel, went to the Southern Hemisphere, basically picked up the rest of them that were in the Southern Hemisphere. He's also the first person to have used the term globular cluster, and he also used the symbol, which you'll see in atlases and so on, which is the circle with the cross through it. And I always found it a little confusing that that's the same symbol as we often see for the Earth itself when the planets are represented by symbols. I don't think there's any reason for that. I think it's just a coincidence that Herschel decided to use this symbol, and I don't even know, which came first. The only other name that's really important to mention in the early history of globular clusters is James Dunlop. He wasn't perhaps the best observer in history, but he was the first person just before John Herschel went to South Africa. James Dunlop was in Australia, and even with a fairly small telescope, he made a long list of discoveries. Many of them turned out to be spurious, but there were 21 of the impressive southern sky globular clusters which are on his list. So that kind of gives a summary of where we stand with the observational history of globular clusters. I'm not an astrophotographer, so I should have asked Adrian to lend me one of his Milky Way photos to do this, but instead I took this from a Sky Atlas program, asked it to show me the whole sky with the constellation lines drawn in just for a sense of perspective. The individual dots represent the globular clusters. And I purposely chose to have the sky map centered on Sagittarius because that's the direction of the center of the Milky Way galaxy. And it turns out, of course, that the globular clusters seem to be kind of organized around the center of the Milky Way galaxy. That's not a coincidence. There's a very good reason for that. It's because they are, in fact, physically located around the Milky Way galaxy in 3 dimensions. And we are off to one side. When we look towards the center of the Milky Way, we are also seeing the center of the geometric pattern of all the globular clusters. Again, let me emphasize that there's not that many of them. There's a manageable number on this list. And for an observer who had, let's say I had a background of laziness, I didn't want to take on any kind of projects where I had to do thousands and thousands of observations. So I really liked the idea of going after the globular clusters. This is me as a young astronomer with my home assembled 15 centimeter Newtonian in 1974. And it is the telescope that I tried to look at some of the globular clusters with when I was a youngster. But I have to admit, I really didn't have an awful lot of perseverance, and I didn't really pay a lot of attention to reading sky maps. I can't honestly say that I made any worthwhile observations when I was that age. It wasn't until a little bit later, and David Levy already shared the story of how he and I met. And I don't mind saying many of you will understand me if I say that David helped to motivate me and inspire me to take up observing in astronomy as a little more serious thing. I had done some astronomy in university and loved that. In fact, I was kind of interested in variable stars as they express themselves in globular clusters. So in fact, here's a animation of Messier 3. And in fact, I chose this to show you this evening because Stella Kafka mentioned it earlier when she was talking about the work done by the AAVSO. So you might remember this photo just from earlier this evening. You can see it in the animated GIF. It does cycle, of course. We're not looking at this live or anything, but you can see that a handful of these stars do brighten and then dim again while the animated GIF is going through its cycle. And that's important for my personal story, the interest that I had in the globular clusters. Because when I was an undergraduate at the Western University here in London, Canada, I was asked for a summer project to measure the brightnesses of the variable stars in NGC 5897 by Professor Amelia Mayall, who was a student, well, she was a researcher of these variable stars in globular clusters. And I wanted to actually dedicate my talk this evening to her memory because she passed away on March 22nd at the age of 90. So this is to you, Professor Mayall. You'll see here, it's a reverse and negative black stars on a white background. NGC 5897 is not known as one of the richer globular clusters. The variable stars are identified with letters, with the letter V and then a digit. And they're the ones that I studied on photographic plates in a dark room in the basement of the astronomy department at Western University in the summer of 1975. Turns out the plates were not particularly clear. And even though I did my best with the measurements, Professor Mayall was not able to get any data that led to analysis leading to variable star periods at that time. I kind of kept in touch a little bit, and over the years, I would check in on whether or not she had published any research on NGC 5897. It wasn't until 1990 that I finally found the paper. I think the paper was published in 88 or 89. And there I found my one contribution to the world of professional research astronomy, which is in the paragraph under the acknowledgements in this paper that she published with the final values of the variable star periods. And you'll notice in the red oval, it says, the help of many student assistants. And I was one of those assistants. So that was my big contribution to astronomy. That's how I'll go down in history, as having made some of these measurements. I love NGC 5897 because of that personal connection. It's in the constellation of Libra. It's one of the globular clusters that you might pass over if you're just looking at the brightest ones. And I hope that if you think of my presentation this evening, throughout this summer of 2021, maybe you'll take a moment and look at this globular cluster and have some fun with it. Now, I also want to relate one very inspirational moment that I had in the summer of 1991, actually spring of 1991. I was at the Texas Star Party, and I was watching Omega Centauri through one of David Levy's telescopes that he had brought to the TSP that year. And I was just watching it and following it because it was a Dobsonian, and I was holding it with my hand and dragging it down. And I didn't really notice that I was close to the horizon. And suddenly I got kind of startled because into the field of view came this dark shape. And it was literally Omega Centauri setting against a distant hill with a tree on that hill. This photograph reminds me of that experience. It was really cool. But I again want to kind of switch back and forth here between observing and astrophysics. Turns out that Omega Centauri is one of these transition type of objects. It's not actually a globular cluster. It's actually a dwarf spherical galaxy. And it just happens to be in the family of the Milky Way's satellite galaxy system. So, you know, we might be forgiven. It looks certainly like a globular cluster. It was thought of one. It being demoted from being a globular cluster, apparently, it doesn't have the emotional impact that Pluto's getting demoted from the list of planets had, because I haven't heard a lot of folks complain when I tell them that Omega Centauri is no longer considered a globular cluster. So I'd like to propose a few observing projects for folks. For instance, I call it Scopy-Locks in the Three Globulars. If you look at the constellation of Hercules, and there's M13 shown in the chart, which of course you'll spot no problem. But if you look to the north a little bit, where the underneath Hercules' knees, you'll see M92, also a Messier object, not as high up on the Messier list, not as impressive as M13, but a very interesting contrast and comparison. Look even further to the north, and there you see NGC 6229. Make this one of your projects for this summer. See all the three globulars basically within a couple minutes, and train yourself to look back and forth between the three and try and appreciate the differences in them. This is a really cool idea. Ken Hewitt-Wright wrote about this in 2009 in Sky News, and it's a really neat idea. In fact, there are other triplets. There are a whole bunch of places across the sky where I find three globulars that are worth looking at one after another. Another is what I call the Threepius and Scorpius, M80, M4. M4 is a big thing, and you can almost see it with the unaided eye, even through our long view through the southern atmosphere when we look to the south in the USA and Canada. If you're down in Chile or Australia, you have M4 right up high. It's just great. M80 is also in Scorpius. It's much more compact, but some folks might actually say it's brighter than M4, and you should make that check yourself. Look at the difference in the distances of the two of them. And then NGC 6144 is the more challenging of the three objects. It's actually quite close, just a little jump over from M4, and it's actually not as distant as M80, but it's more diffuse. It's actually a larger cluster than M4, and it's interesting to make that comparison. So there's a little bit of a challenge for you to take with you for this summer, whether you're a beginning observer or even if you're more experienced and just never thought of looking at the globular clusters. To really see some of the excellent ones, you have to head down to the southern hemisphere. So this is NGC 4372 in the constellation Musca, and south of the Southern Cross. The dark slash across the middle of the photo is the Dark Doodad Nebula. And I've heard lots of folks comment on the Dark Doodad and then not even mention NGC 4372. I hope you won't make that mistake. It's quite a beautiful sight if you ever are in the southern hemisphere. And it's worth a trip, of course, to go to the southern hemisphere if you're a northerner like most of us are, and you've never been down there. You should make that happen once in your life. One of the other really famous globular clusters, which is not a dwarf spherical galaxy, is 47 Tucanae, which is obviously in the constellation Tucanae. It's not actually a 47 as in Flamsteed numbers. These numbers were added by Bode at the beginning of the 19th century, so it was not observed along with the other stars that we think of as the two-digit numbers. A lot of folks identify it with the Small Magellanic Cloud because the SMC is right next to it by appearance, but it is in fact much, much closer. So 47 Tucanae is part of the Milky Way globular system. Now, that's not to say that there aren't worthwhile things. In the Small Magellanic Cloud, you get yourself a decent atlas, and there are at least half a dozen really nice globular clusters that are located attached to the Small Magellanic Cloud. They're also in this photo, but I'll leave that to you as a challenge to kind of find them on your own. You need to be in the Southern Hemisphere for that. My own project in the recent years has been to use a 40 centimeter mirror that was part of a telescope that David got involved with and was brought up here to Canada. And we took it out of the original cardboard tube. And my friend and fellow RASC member, Mike Haynes, built a 40 centimeter low profile Dobsonian.
Scotty was involved in that telescope as well.
Well, I was wondering whether you'd like to tell the story, David. Do you want to tell it now or later?
Later.
Okay. But while we are talking about big telescopes, some of the globular clusters are actually far enough away that you do need a bigger telescope, and they are considered more challenging objects. I would say there's probably about 40 that are really easy, that are in the Messier catalog. Then there's another 40 that, yeah, okay, you should be able to try. And then there's 40 that get a little bit harder, and then maybe another 40 that are really, really hard. And you might need a really, really big telescope. So what I did was I made my own observing list of the globular clusters in 4 groups, which in the tipping of my hat to the fact that astronomers always make nonsense categories for things, I decided to call them early, punctual, fashionable, and late. So the early globular clusters are the ones that are the brightest, easiest ones. And as you see down the list there, almost all of the Messier objects are there in that list. And then
Peter, that's brilliant.
Thank you, David. I think you've, I'm sure someone like you, David, in fact, many of the experienced observers who are on this evening tonight have seen all of the early, all of the punctual, most of the fashionable, but I'll bet you not very many folks have observed any of the ones on the late list. It turns out that the ones on the late list are so far behind the center of the Milky Way galaxy that seeing them is obscured by an awful lot of dust, and that makes them really tough. There may be more globular clusters back there. Every now and then I do read about a new one being discovered. I think I've included them all on this list, but I'm not 100% sure. Anyway, there is a sort of an ongoing challenge here for anyone. If you pick up your telescope and you're just a beginner, you can see a globular cluster on the very first night you open your telescope to the sky. And years later, if you've been doing observing all along, you'll still be trying to hunt down everybody on this list, and you'll enjoy every one of them. And so that's what I wanted to emphasize for you tonight. I'm also going to show my slide of the telescope that John Briggs pointed out earlier. This is Steve Dodson's 56 centimeter Dobsonian that was taken to Stellafane that one year. This is the telescope on the campus at Western University in 1982, if I remember correctly. If you have a nice big telescope like that, you can certainly see a few more into the late category of globular clusters. There's my summary, folks. If you have any questions that I can try and help you get over with globular clusters, I hope you will somehow realize that globular clusters are worth maybe more attention than the typical amateur astronomer gives them. And if you are interested in the astrophysics of them, there's plenty to learn there as well.
There is
well,
one
thank
question.
you, Peter. That was really quite something. We're going to put the questions off to the after party, I'm afraid,
Sure.
because time is not going backwards for us.
It never does.
Yeah, there was just a
And
question
I
they
want to
might
thank
want
you
to
for
the
coming,
website.
for your patience, for staying so late. And I'd like to see that list so that I can see how many of the late ones that I've been able to see, if any, probably not. Anyway, we have Jason Gwenzel, I hope I pronounced your name correctly, who has been waiting very, very patiently to show us some astrophotographs. And it is now a pleasure to introduce Jason. Take it away, Jason.
Hey, thanks for having me. Can you hear me all right?
Yep.
Yes.
All right. I am going to share from a different computer here, so hopefully this works out all right. Just let me know if it's coming through. I should be able to see it. Okay, yeah. All right, so I'm gonna, I was interested in going through and sharing some of my images. For those that don't know me, my name is Jason Genzel. I'm an astrophotographer. Basically, you know, whatever I can. I've shot, you know, like the wide field Milky Way stuff all the way to high focal length planetary photography and things like that. What I was thinking about going through today was some of the images I've shot with this 6-inch Acromat telescope from Explore Scientific. You know, I've gotten some pretty good response off this image, off this images from this telescope, and I think it's kind of an underdog telescope. It's got a lot of capability for a decent price point, and so, you know, I tend to steer some beginners towards this scope, or at least this series of scopes, these Acromats, whether they're looking to get into visual observation or some more targeted photography. So I'm just going to go through some images I put together, but I have up on the screen here, and hopefully you can see it. You know, this telescope here is the telescope I'm using for all these images I'm going to show. So it's 6-inch doublet Acromat, and I use it for anything from planetary photography to solar photography to deep sky photography. For my solar work, I do put a dedicated filter on the back for solar photography, as well as an energy rejection filter in front of it. And I just want to caution anybody who's considering pointing this thing at the sun that you need to make sure that it's properly filtered at all times. So I'm going to first go through some solar images here that I have. This is the setup that I use for solar photography. And you can see back here, I've got the quark, the Daystar quark solar filter and the ASI 174 mm camera behind. And here's just another view of it. So I use it for dual purpose for deep sky and solar photography. As you can see, I've got some like a guide scope up here for the deep sky work. But and this telescope just recently went through an upgrade. This is a moonlight focuser on the back of it now. So
looks nice.
Things to come. So here's an example of a photograph of the solar chromosphere. This was actually shot today, believe it or not. This is active region 12813, which is on the limb of the sun that's currently rotating out of view, and it's kind of a fading active region here, which you can see in the center of the screen. Just some disturbance in the chromosphere. And then this was also shot today. This is on the opposite limb of the sun. There is quite a large prominence hanging off there, so I got a shot of that. Really battling with conditions today during this, but I was able to get some images out of it. And again, you know, for those that don't know much about the solar photography, this is all shot with a monochrome camera. So that's colorized after the fact because we're only looking at one specific wavelength of light.
Mm-hmm. Wow.
This is so this was in 2019. This is actually a pretty old image, but I'm just going through some highlights of what I've been able to get with this scope. And yeah, every once in a while we get one of these major prominences that are pretty interesting to photograph. So here's one that is probably one of the larger ones that I've ever had the opportunity to image. And then also done, some close-up work here so you can get in, real close into the
Beautiful.
details of these prominences. But where the scope really shines is in the chromosphere details. So I'm going to play a video here for you. Hopefully it plays all right. This is going to loop and rock back and forth.
Wow.
And then it's going to slow down so you can kind of see some details. I hope the video is coming through all right. Is it playing smoothly at all?
Yeah.
Okay.
Yeah, it's coming through pretty good.
And there's points there where it's so sharp, it's unreal. I mean, it's crazy.
Yeah, this gives you a feel for what you're kind of up against with solar photography. The conditions come in and out so rapidly where the atmospheric turbulence will disturb the image and make it blurry, and then you get these moments of clarity. So it's really challenging to make a video like this that plays consistently. But I've got a few videos here to show, so I'll just kind of hop through those. This is an example of a very crisp day with good seeing conditions. You can see that even the difference from the last video, you can see how much more detail is available in the chromosphere. So this plays forward and just loops through. You can see a flare shooting up here out of the active region. And so this brightening here is considered, this is all considered the active region, and active regions don't necessarily even have sunspots, although this one has a few, one large one obviously, and then a few more peppered in here. But these active regions are just where the local magnetic field is twisted upon itself and creates some heating and some cooling of localized regions, and that's what ultimately gives rise to sunspots and flares and things like that. And here's another, obviously colorized, but this is a active region on the limb. It plays over 45 minutes of looping motion. One thing you might notice here, because this just plays forward and then snaps back to the beginning and loops, is you can actually see the rotation of the sun in these 45 minutes. The sunspot, rotates up away from the limb. Hopefully it's coming through all right. It looks a little jerky on my other machine here, but
no, it looks good.
No, we're definitely seeing the detail that you're talking about.
It's mesmerizing.
Yeah, you can kind of stare at it for a while, and then you look at this. This is a flare that erupts. These flares typically travel along the magnetic field lines, so you can see it kind of curling around. But it's definitely interesting to watch the chromosphere kind of. You can almost see these snakes, in motion.
Someone wants to know, has NASA contacted you yet?
No, not yet. They got observatories in space, which don't have to deal with the problems of the atmosphere. So I also have a calcium filter on that scope. Well, from time to time I have it on that scope, and that gives you some nice details in the active regions. Unless there's significant active region, there's not much to see in calcium. So this gives you an idea of what a large active region looks like in calcium. So you get these, the mottled bright features along with the sunspots. This is actually.
So I imagine there's a difference. There's a difference between regular white light and calcium, other than the color. So is there a little more detail that calcium gives you that white light gives you? And I may be answering my own question looking at the texture that you've got here that I know the white light doesn't always show.
Yeah, the white light typically will show sunspots, but you don't see these brightenings around the spots in the active region.
as well as you
Okay.
do in calcium. So that's kind of what calcium gives you is the.
Jason, do you know what the wavelengths are for the calcium filter?
This one shoots, it's calcium H, so I think it's just below 400 nanometers. It's like, you should know this. It's like 392 or 396, somewhere around there, nanometers.
Well, gee, Jason, I wish you were a member of the ALPO solar section. I'm the coordinator. I'm writing a report on AR 2781 right now.
I might have some shots of that.
Yeah, you just showed them. They were beautiful.
Which one?
2781.
Oh, here, yeah.
Yep. And you had another shot of it further in the middle of the disk.
Yeah, feel free to reach out if you ever want to talk about it.
Don't worry about that. You will get an email from me.
Yeah, all right. No, that's fine.
This
Actually,
is
this one, yeah, this is 2781 too. So this is when it already traversed almost all the way across the disk.
Right.
Actually, this shot, if you imprint this in your mind, is taken within minutes of this shot. That's the same active region. Two different wavelengths, and you get a feel then for how much different hydrogen looks from the calcium.
It was the second largest region of the last quarter on the sun.
Yeah, I believe it.
Did that spot have anything to do with some of the aurora activity that we caught over the solstice, or was that something different? Was that the?
Well, this was from November. This was November 9th. The shot was.
Okay, so that wouldn't have.
But
no,
yeah,
it was something else.
When these active regions are pointed toward the Earth, is is when they send out a stream of charged particles and then end up getting entrained in the Earth's magnetic fields and filtered towards the poles and end up looking or creating.
It didn't have any X-ray flares, but it had several high energy events.
Yeah, I remember one of those events turned out to be a bit of a dud because of the way it hit the Earth. It got absorbed as opposed to spectacular. I think I remember going out one night looking for aurora, and it happened to be one of those nights where it got swallowed up. So we had nothing. Of course, just wait a month later, the solstice came, and that time we had something.
Thing is, it spews out charged particles, and the solar wind comes out in a spiral because the sun's turning. Solar wind comes out in a spiral, and we have to be just in the right spot to catch that pulse of high energy particles. So it can be you can have a big coronal mass ejection, and it completely misses the Earth.
Yep, I believe that.
So this is another one from 2019, but this is one of the better looks I've had at a sunspot near the limb, and a large sunspot. I've got the Earth down here in the lower right-hand corner to give a sense of scale. So that's appropriately scaled against the sun. The sunspot is larger than the Earth.
And in white light, that whole follower spot, which is on the left, that whole follower spot area was a profusion of spots and detached penumbra.
Rick, if you don't mind, let's hold the questions until the after party so that Jason can get a chance to complete his presentation. We'll have plenty of time in the after party for more questions. Is that okay?
Yeah.
Yeah, that's fine.
Yeah.
This is active region 2804. So this was just a month and a half ago. It looks like February 27th. And this was as the sunspot. This is an inverted image, so the sunspot's bright, but this is as it's rotating out of view. And then this was, I don't have a date on this one, but this was probably in the last few weeks. And then this is another sunspot from the end of November. This is extreme close up, one of the closer sunspots.
Wow, that's
Able
beautiful.
to image, but yeah, a lot of detail all the way down in. All right, so that's a tasting of the solar work with the AR 152. I've got a set on planetary too, which you wouldn't typically think to use this scope for planetary photography, but it's an extraordinarily sharp telescope in green light. So I typically would take the detail or the luminance layer in green, and then shoot other colors separately with a monochrome camera. I'm able to get some pretty decent planetary shots, considering it's an achromatic telescope, so you have the violet fringing to contend with. But if you look at it in a pure mono sense with a green filter, significant detail on the lunar surface, including some hills and valleys out on the limb, which I always think is a cool thing to catch. And also with an eyepiece, just taking a cell phone shot, through the eyepiece. I think a lot of people start this way. It's a good telescope to use that way also. And then this is again with a green filter as Jupiter was rising, so the video kind of starts off a little bit soft, but you can see, I think this is about 2 hours looking at Jupiter.
Seeing just like pops in.
Kind of a cool look as you see the moons moving away and the planet rotating. And I don't know why that one looks so.
Christopher Gould would be proud.
Yeah, I'm sorry. This one is looking. Is it coming across all right?
Yeah.
And Scotty Roberts would be proud.
So this is Venus shot with ultraviolet and infrared and green filters to get the tricolor match. So it's a false color image, but it's shot in with the ultraviolet and near infrared filters to give it the coloration there. I think I had some more Venus, yeah. Just some different looks at Venus.
Amazing. Look at that.
Sort of an artistic look with a star background, but I've actually been able to image the dark side using an infrared filter, the dark side of the planet to give a full disk appearance. And then one other thing you can do, which is use a white light solar filter, and this is an ISS transit across the disk of the sun.
I know, incredible, huh?
You got that, Jason? That's wonderful.
Yeah, it's that transit happens in less than a second. I think this one was, so it's shot at 128 frames per second. Yeah, if you freeze it, the individual frames are pretty sharp on the ISS. But yep, they can do planetary, and more recently I've been trying to use it to do deep sky photography. This is it set up for deep sky next to a couple of celestron scopes I was using last year. This is the Dumbbell Nebula. I actually imaged this one live on one of the first star parties we had.
Mm-hmm. I remember.
Stars removed, obviously, but just to look at the nebula in detail. This is the Cave Nebula shot in hydrogen and oxygen narrowband.
So a lot of times, Jason, people ask me about these achromatic telescopes, and you know, and they wonder, if they can get away without having to spend so much money on a big apo, and you look at images like this, and it's really inspiring.
Yeah, I mean, you just have to know what you're working with, right? You gotta know you can't really shoot in broadband with it. At least not get, as good a results as if you shot in mono and selective bands or in narrow band like I'm doing here. But yeah, the scope can produce a ton of detail if you're looking at narrow band imaging.
And I think, Jason, you have to refocus, right? Every time in different filters. Is that right?
Yeah, that's absolutely required with that scope.
Yeah.
Yeah. So this is the Lobster Claw Nebula, and I think I got one. Well, this is the Wizard. This is just an HA, so monochrome. And then this is a Wolf-Rayet star WR 134.
Wow.
Nebula associated with that Wolf-Rayet star.
Looks 3D.
Might be all I have. Well, that's just it. Same target, just in a different color scheme. But yeah, that's all I had. I just wanted to show a kind of a demo of what I've been getting out of that scope. I mean, you can see from this collection, I've used that scope a ton for imaging, almost exclusively. Looked through it a few times, but.
Thank you so much, Jason. That was really exciting. I missed a little bit of your presentation because I went outside to try to get a look at Tombaugh's star, Clyde Tombaugh's star. And I did. I didn't see the star, but I did get the field. It's fainter than 13.4. Anyway, Molly does not seem to be here tonight, Scotty. So if you don't mind, we're going to sort of be fading in pretty soon to our after party, which I think all of you are looking forward to. But before we do that, I would like to know if Scotty, if you would be willing to answer just a few questions.
Sure.
Would that be okay?
Yeah.
Thanks. I guess about 6-7 months ago, you called me because at the time you were doing a lot of advanced, almost daily advanced Zoom sessions on certain types of telescopes. And I was trying to come to some of those, as many as I could.
Sure.
But you asked me if I'd be interested in participating in something new you were going to do more for our people called a global star party that you would hold every week on Tuesdays. And I, of course, said I thought that was wonderful. And you asked me if I'd like to do a little poetry at the beginning of each one. Yeah. I said yes, and I've managed to do that. What gave you, Scotty, the inspiration to do the star party and lead us up to this 40th global star party?
Oh, geez. Well, myself, like many of us, I felt, I'm someone that likes to go to astronomical events. I like to go to star parties. I love doing educational outreach. And during the pandemic, it was just an impossibility. I had, leading up to this, I always made a point of shooting like little videos with my iPhone and trying to capture some of the fun and excitement and some of the community aspects of what it is to be involved in amateur astronomy. I think that our community is built of some of the greatest people around, some of the most sharing people around, and I just I just don't quite see that kind of engagement in a lot of other community activities. I was a photographer, had a photography background. Photographers don't give up their secrets, okay? The guys that do terrestrial photography, but you talk to a guy like Adrian or Jason or something like that, you know, and they're doing amazing work, and they will tell you everything. They will tell you how to do it all, you
Definitely
know.
will.
And so that's kind of, I mean, that's just one indicator of what kind of community we have. But I felt it was important. You know, I kept hearing about people being depressed, feeling isolated, these kinds of things. And I go, there's no reason that amateur astronomers have to stop getting together, you know. Amateur astronomers are some of the very early adopters of the internet, the early adopters of e-commerce shopping. You know, if it was digital sharing, you know, they were involved in it. And so as I started learning to use some of the tools and stuff, I realized it was possible to have to get people together on Zoom and connect up broadcasting software and to make it enjoyable and for us not only to reach out across our own country or, you know, within North America, but good Lord, around the world, you know. And this was the only way to do it. But I really felt it needed elements that make people remember a star party. And part of that, and the reason why I asked you to do the poetry, David, is because, you know, the kind of the sacred parts of being out under the stars and the sacred parts of remembering why we do it is locked into a lot of the poetry that you read. And so that was the reason why.
Well, thank you, Scotty. We're going to be phasing in just a moment to our after party, which is kind of patterned, I think, after, would you say, Scotty, the Saturday Night Live after parties that they do? Is that where you got the idea? And this will give all of us a chance from Facebook and all the others to ask questions of all the remaining panelists and everyone who is still with us tonight on on our screen. But tonight's theme was night, very simple one-word theme, where I wanted to get a chance to have from different perspective, Clark to talk about Mercury, Adrian to show some of his absolutely heavenly photographs, John Briggs to bring us back to other earlier times with telescopes, Rick Hill to describe the wonderful work he did with a specific type of telescope, Peter to talk about his favorite types of objects in the universe, and all the others that we have heard tonight. Had such a good time. But I'm going to close with a poem that kind of addresses the theme of our global star party tonight, Acquainted with the Night, by Robert Frost. I have been one acquainted with the night. I have walked out in rain and back in rain. I have outwalked the furthest city light. I have looked down the saddest city lane. I have passed by the watchman on his beat and dropped my eyes, unwilling to explain. I have stood still and stopped the sound of feet when far away an interrupted cry came over houses from another street, but not to call me back or say goodbye. And further still, at an unearthly height, one luminary clock against the sky proclaimed the time was neither wrong nor right. I have been one acquainted with the night. And on that note, I'm giving it back to you, Scotty, to get us going with the after party.
Okay.
Thank you.
Thank you, David. That's awesome. That's beautiful. Okay, so I have been posting the link to join up with the after party, and I think Cameron Gillis is logged on with us, and I'm not sure if anyone else is up for it, but
Kent is just logged on.
yeah, and Kent's here with us too. So
hi, everybody.
That's great. But really wanted to invite you to participate if you'd like to. Being on the Global Star Party is your chance to reach out to amateur astronomers and other people, just interested people that are watching from around the world, and those that will re-watch this program, because we get thousands that watch it in after it runs. So, if you got something to contribute, an image, a live view through your telescope, a little presentation, by all means. And I will take it to what I call Hollywood Squares. Here we go.
All right. Hey, Scott, if you don't mind, I just wanted to, my contribution tonight is just an enthusiasm, enthusiastic recognition of this panel that you have here, that David has assembled. And, I just, if I can just address each person and what I kind of take away from each of these. Clark, I really was, I thought the sketching of the albedo on Mercury, that was really fascinating. Just that discovery, to be able to do that and be able to get that type of detail, it was really neat. And then Jason, obviously you're a mastermind in your ability to do all sorts of photography and astrophotography and pushing the limits of everything, and it's really awesome work. Love your solar work, love your nebulas. You make the galaxy and the universe just full of fabric and colors. It's just incredible. And Adrian, when you showed me the pictures of all the Milky Way, I just remember my time in about 20 years ago, I think, in Soyuz in British Columbia, and was in Peachland, and I had my 11x80 binoculars, and the Milky Way was rising over the mountains, and it was fantastic, very memorable. But I'm sad to say that I haven't had that experience. So when I saw your pictures, it just made me feel, I really want to go and see the Milky Way. And this is kind of getting to Kent Mart's, the whole light pollution thing, right? Some of those pictures just made me think it would be so nice if you could just walk out your front door and see something like that. So thanks, Adrian. That's really good. John, I love his historical, restoring all that. That's fantastic. The history and preserving it and bringing it kind of contemporary, right? Making it modern, updating it, taking care of our history and bringing it to today's Renaissance. I think that's awesome. And then Rick, love Schmidt Cassegrains, of all sizes. I think it's a fantastic optical design. I have an 8-inch Schmidt Cassegrain I've had, and it was really neat to see the different scales and your talk there. That was really good. Thanks. And then Peter, globular clusters, man. I mean, who doesn't like them? It's a great outreach. It's a great outreach thing, because I always love showing my family or whoever. If you look at that and you say, hey, there's millions of stars, or there's hundreds of thousands of stars, and it just looks really cool, right? Even in a small telescope. But of course, in a Dobsonian, oh man, it's the most beautiful thing when it just fills your whole eyepiece. You get one of those wide field eyepieces, and you look through a globular clusters are great. And then on 47 Tucanae, I haven't been to the Southern Hemisphere, but there was a recent talk where they showed 47 Tucanae, and then they had a smaller globular cluster that's actually in the small Magellanic Cloud in the distance. It's in the background, and so that's a little Easter egg in that, which is really neat. Anyhow, and of course, David, awesome. I love your singing, your poetry. It's wonderful. It's great. And of course, Scott and Kent. I think David is away, right? He's not logged in right now, but
He's logged in,
Right
but
there.
he's not. I don't.
oh,
see his
okay. Thank David, of course. I mean, I've said it before, and since the times in the 80s and 90s when you were writing for astronomy and doing the sketches of deep sky objects, I just love that. That was one of my favorite articles. Just looking at what you can see in an 8-inch, what you can see in a 17.5-inch, all that kind of stuff. Love it. Anyhow, so just wanted to thank everyone here. This is great what you're doing, Scott, and it's awesome.
It's
Well,
all.
thank you, Cameron. It's wonderful.
Yeah.
Sorry, Scotty, I'm interrupting you. Sorry.
No, I just said it's everyone that comes together that really makes it happen, and it's our audience too, because it's, we couldn't do this any other way. It would just be impossible to have people in the southern hemisphere and the northern hemisphere and other countries and all of us get together without us doing it online. So I don't ever see this kind of event going away. I do see us getting together in person when that's possible, though, as well. So, and I'm sorry I interrupted you, David.
September 2022. Do you want to tell us a little bit about that?
September 2022, we plan to have the next Arizona Dark Sky Star Party. We had one pre-COVID. It was fantastic. It was held at Kartchner Caverns State Park. It was a wonderful venue. David showed us all up by observing from, dusk to dawn, he brought so much energy to the Star Party. It was amazing. We had astrophotographers there. And it was, Kartchner Caverns is just an amazing state park. It's just really comfortable, beautiful facility. If there's a 5-star state park in the United States, that's it, for sure. And so we do plan to do it again in September. And things still have to be firmed up, but we will, I fully expect it to happen. And all you guys are invited. So...
Yeah, that's all the energy I had until I got my second COVID shot. But anyway, that's going to be fun. It would be a great opportunity to meet all of you or see all of you, some of you again, others to meet for the first time in person. Mm-hmm. Dolores, you've got a cat there.
We have 7.
7 cats?
Yeah, they're all rescues.
7 cats.
The Pleiades?
Well, you just saw Deimos and Phobos, her sisters, in the other room.
I thought it was against the law to have 7 cats. Do they speak Latin?
We're down to 7 cats.
Down to 7. Do they speak any Latin?
3. We lost 3 in the last 2 years.
Oh.
Do any of them speak Latin?
No, they speak catadioptric.
Oh, I see. Well, that's good.
Yeah.
I think a lot of us are cat people. I used to be a cat person. And before, in the pre-Wendy days, I used to be a cat person. And now in the Wendy days, I've become a dog person. And it's interesting, the difference, though, that cats, you take care of dogs, but cats have staff.
So little known fact, that time period is also in Michigan. We do astronomy at the beach, which we went virtual. And a few of you, Dolores, you were there. Dave, you volunteered to give a talk. Yeah, we managed to pull off a virtual event. And I'm hoping that our events don't cross, because I'd like to attend one and deal with and then we have to go back and do the other. We're not sure that our event is going to be, whether it's going to be virtual or some sort of a hybrid yet, because I live in the state with the highest rate of COVID cases going. So we're not sure what's going on in our state. We know that the University of Michigan had a deep run, and as a result, folks got together to watch it, and students tend to be spreaders, unfortunately, and it led to our numbers starting to go up. But the fall could be completely different, so we don't know. I just know that I plan to travel in October, so I'm hoping to come out and meet all of you after making a quick stop at the Oklahoma-Texas border and that star party I just registered for, to add to some of my deep sky wide photography. I'm looking forward to seeing the Milky Way the way it looks in my pictures with the naked eye, and to do some observation.
Okie-Tex is definitely going to be a real in-person star party, or is it going to be a virtual pants optional star party?
They're having folks register, so they're saying it's definite. A few of us from Camp Lowbrow, which I hope some of them from our club are watching, from all the clubs that I'm in. I hope they're all watching. There 4 or 5 of us have registered already to come down, so I'll have a Lowbrow T-shirt on or sweatshirt when I come to visit West, and I'll have a lot of maintenance to do on the truck to make it down there, and then make it even further west to visit you all. I used to play baseball in Arizona, but now looking at the stars is now more important. Then of course I have to make the trip back. So it promises to be a really fun road trip. We'll see how it turns out, but hoping to meet a lot of you out there when I can come out. And of course, fresh batteries to image some of these nice night sky vistas that you'll have, without getting myself into trouble. Rick, you warned me about south of Phoenix. I plan to stay away from that. I don't need my last image to be somebody coming up to me with a gun with the Milky Way in the background. That's not going to work. His last image, no, we don't want that.
The only thing you got to contend with north of Phoenix, the only thing you got to contend with are the rattlesnakes.
Well, we can handle that. At least I think. I say that now. When one comes after me, that could be a last shot too. It was a beautiful shot, and we don't know what happened after that because he collapsed.
We have a saying in Arizona: you grab the first rattlesnake and bite its head off, and the rest of them will leave you alone.
Oh my God.
Hey, Rick and Dolores, I have a question for the two of you. Thanks, Adrian. Speaking of rattlesnakes and being killed south of Phoenix, what do you think is the oldest book in your library collection?
Oh, goodness.
Our first anniversary, she gave me a copy on Uranus's Satellites by William Herschel, signed by John Herschel, to Smythe, to Admiral Smythe. That's one of the oldest. Oh, no. Ewan Whitaker, before he passed away, he was cleaning out his library. And he had boxes of books in the garage, and the U of A library didn't want them. And he says, you can have anything you want out of there. And I got a 3-volume set on Fragmente of the Moon by, oh my gosh, I'm having a senior moment on the name. It's from 1735. So that'd probably be the oldest one. And that's now in boxes with cotton gloves and all of that. Human fingers don't touch those books anymore.
Yeah, but you're not really human, Rick, so you can touch them.
Yeah. I need to get one of those things where they have them in the libraries, like the Library of Congress, where they turn the pages with these little paddles. But that's probably the oldest one, is 1735. Ewan had books in his library on the Moon that went back into the 17th century. So it was quite an amazing library. And I finally got the U of A convinced to take some of that into their special collections.
Oh, I'm glad you did that, Rick. I think that's a very noble thing to do.
Well, he had a lot of paper.
But you yourself have.
He had a lot of paper.
You yourself have.
Yeah.
Yeah. But you yourself have an awful lot of wonderful ancient books. You can take a dip down into what people were like. It's like you go into the living rooms of all these people and they tell you, come in, sit down. This is what life was like when I was alive. And that's the magic of having an antique book, an old book.
And why they have to be preserved. Ewan
They have to be
Whitaker,
preserved.
Ewan had a couple of sheds on the back of his property, and there were file cabinets in them. And he had worked on every moon program in the space program, from the first days of Ranger right up until they landed the Apollos on the moon. He even helped select some of the Apollo sites for landing. And these papers were correspondence between him, the other scientists, NASA, and even the astronauts. And when he had died, nobody knew those were there. They were fodder for the crickets. And I brought the university aware of that with the help of Tim Swindle over at LPL, and we got those in special collections too.
I'm really glad you did. Really, really glad you did. And
Yeah,
Dolores, what you've done. Oh, sorry, Clark.
Yeah, I was just going to say that I met with Ewan a year or two before he died to try to find the missing crater catalog that was done at LPL in the 1970s by, I guess his name was Leif Anderson, who died young. And Ewan went through his garage and hauled out all kinds of stuff. And basically that crater catalog just has disappeared. It's crazy because he brought out lots of stuff about the moon and from the 60s and so on, as you said, but there's this missing lunar crater catalog that a lot of people worked on in the 1970s, and it just disappeared.
How big is it? Do you remember what it looked like?
Well, it wasn't published. It was on decks of cards, I guess, or some ancient medium. And
punch cards?
Pardon?
Punch cards?
Yeah, punch cards. And, we searched the basement of Flandreau Planetarium and, all kinds of things, but it's gone. If anybody's ever comes across it, let me or Chuck Wood know.
Yeah, I think the punch cards are gone.
They've reorganized a lot of the imagery center, and I'll keep an eye out.
What's
So you
interesting?
yourself have been very, very notable in what you've done with Bennu over the years. You've done a wonderful job with Bennu. You've really made it come alive to the world. Nice work, Dolores. Thanks.
Well, I've mostly been the cheerleader up until now. Now we prepare for the sample.
She knows a fellow who lives literally across the street from the, a testing ground?
Utah Test and Training Range.
Yeah, Utah Test and Training Range. He lives across the street, and we're going to invade his front yard the day that comes back and lands at the testing range. He doesn't know it yet, but we'll bring the pizza. So,
Mark, when is that slated to happen? There's a date on there. Yeah.
September 24th, 2023.
What time?
I think it'll be in the morning.
Okay. Well, I figure by then we'll be back to the old 2019 normal or something close to it. I have a feeling masks is still going to be a flu season thing, but they wouldn't have to be year round. It would just, if you don't want to catch anything during flu season.
But in the labs, we'll have to be suited up so we don't contaminate the sample.
Yeah, that's been forever though, right? You always have to mask up and everything else up for that. Yeah, we prefer that to the alternative, spilling coffee on the sample. Yeah, that's something I'd probably do. Get fired the first day.
Yeah, Rick, one thing I wanted to check with you is that I know how careful the Library of Congress and most libraries are handling books. A notable exception to that is Linda Hall. they encourage users, especially children, to touch the books. They think that touching the old book, even though you might cause a little bit of wear, is an important part of the experience. And I subscribe to that. I think that's important.
It depends on the book. You know, if it's Galileo's books, no, you keep your finger oils off of the paper.
Not at Linda Hall, you don't.
Oh.
No, in fact.
Apparently, Dave, you've touched Galileo's books.
I have touched one of Galileo's books. I have touched one of John Herschel's books.
I got to touch those kind of things at the Vatican Library.
That's one place I'd like to go to. I know they're out there too, somewhere in Arizona.
Mm-hmm.
I have to give Brother Guy a call or an email. I have his email address. I gotta let him know if he's gonna be that way or if he's gonna be across the seas.
Who can tell?
You know he's from Birmingham, Michigan.
I think I heard that at one point when he also gave a talk at Glass.
We're from Birmingham, Michigan.
So it's a small, it's
houses apart.
It's a tightly knit community.
Mm-hmm. I didn't find out he was from Birmingham, Michigan until I went to work at the Vatican Observatory in Gandolfo. He met me at the airport. They said, Brother Consolmagno is going to meet you at the airport. And I instantly had an image in my head. Nobody told me he was from LPL. I had an image in my head of Guido Sarducci. And I get off the plane and this fellow's speaking perfect Midwest English to me, which is, of course, God's English. And I said, where are you from? And he said, Birmingham, Michigan. I said, I got to come to Rome, Italy to meet somebody from my own home. We never knew each other. Even though we're all about the same age, we never knew each other through astronomy. We all went to Cranbrook at one time. And it's just kind of a funny world.
It's a small world. It happened to me. Go ahead, whoever was going. I've talked enough.
This is Ken. I think that happens more often than we realize. I've had customers who have connected through the PMCA users group. Literally, he's like, "Are you the Mark Johnson that lives in Clearwater, Florida?" And he in the message back, "Yeah." He says, "Do you live on Johnson Street?" He went, "Yeah." It turns out they live 5 houses away from each other.
Oh my God.
And did not know they were both into astrophotography, and they were literally right there together.
Wow.
But we do it at night. It's invisible, and it's not like you go to a football game and do astrophotography, So
that's how we met. I sold a telescope, put the ad in the Detroit News. 2 million circulation back in 1960. What? No, it was 1971. 2 million circulation back then. And I got one answer to the ad, and it was this girl that lived 6 houses away from me.
That's crazy. It's crazy.
And who knew we'd wind up getting married? And that was 47 years ago. So.
Was it a good telescope?
Yeah.
RV6.
Yeah. We still have it.
Yep,
That's
we still
awesome.
got it.
That's awesome. Hey, I have a question. I have a question for Adrian, a technical question. Looking at all those pictures with lighthouses in them, how do you handle the exposures? Because you can't get much more extreme than a lighthouse and faint lights of stars. How do you handle that?
So the lighthouse itself, the light, if you're there watching the light go off, it's more diffuse than my images make it look. And of course, when I end up doing the long exposure, I'm shooting about 30 seconds. I may be tracking the stars, or I'll do a 20-second untracked image. And I'm shooting at a high ISO, 6400. So, and usually it's a fast lens. So it's like, it's a great question. The only answer I have for you is that light isn't as bright as my images are making it look. It's a fairly diffuse. It's a fainter light, and it flicks on and then it flicks off. and it flicks on again after a few seconds, and it's off. And during the exposure time, when that light is off, is when all the other light from the stars and everything else is getting imprinted in that exposure. So it's not a constant light, and it's not as bright as you may think. I mean, it's diffuse, but it does spread out over the two different parts. So I only have to contend with it for a couple seconds at a time. And if I image where it's not directly in view, it's a little easier to deal with. It basically light paints. It becomes something that light paints something. If I'm shooting out over to the north, it just helps me light paint that part of the shore. So yeah, it's the fact that it's not constant helps me get everything else that I'm getting in those shots. So that despite shooting wide open, high ISO, full frame camera, and even I've done some 2-minute images just tracking with a tracker there. It mitigates that light. So yeah, it's not as dominating as you would think it would be, considering it is a lighthouse.
Yeah, it's directional. It's directional though, and it's not pointed at you. So
right.
Yeah, but it's still lighting up.
Yeah. Yeah, if you were there, you'd be surprised. It's, because it's high up and it's aiming straight out. It doesn't create as much light as you might. It's basically like a very faint. It's even fainter than moonlight when the moonlight's out there. There's this other annoying red light that casts a little more light out there. Sky's dark, so I deal with it. And then there's places you can go where you can kind of shade yourself from all of it, from behind the lighthouse itself.
And where is that lighthouse at? I don't remember.
So, state of Michigan, way up here. Point out Barkey's Lighthouse. You can take Highway 25, and you'll run into Lighthouse Road. You'll take a right turn on Lighthouse Road and go right into the park. And then you'll see the lighthouse every 20 seconds or so, flashes a couple times, and then that's it for like the next 20 seconds.
I was just trying to look it up on a light pollution map.
Yeah, point out. Yeah, you'll see it's around Bortle 3.
Is that Traverse City, near Traverse City in that area?
No.
I don't think so. I think
further over.
Yeah, it's the best way I describe it is if you're going into the thumb, it's on the northeastern tip of the thumb, very northeastern tip. There's also a spot called Eagle Bay that I was going to check out.
Right. Oh, yeah. Wait, wrong hand.
Yeah, you got to do it so that it shows up.
Right
there. It's way over here.
Yeah.
See, unlike Port Crescent, which is over here, and then there's Port Austin, there's a lot of light. It goes dark when you get here. There's a spot called Eagle Bay. There's that lighthouse. You can come down. There's a little area. I think it's private owned land though, so you have to be careful. But you're about as far away from any of this light over here. This shines all the way up till you get to about the tip of the thumb. You finally lose the light domes from southeast Michigan. You see those light domes all the way up the thumb till you get to right about here. You're about 20 minutes away from driving straight into Lake Huron before the light domes go away.
Michigan's so flat. My sister lives in East Lansing, and Michigan is so flat that getting away from the light, I noticed on the light map, there's no place in Michigan that's below Bortle 3, I think. There might be one, not in the lower peninsula.
In here,
gotta go.
Yeah, you get up here, you start getting into Bortle 2.
Yeah, that's like
that was yeah, you can get up here, and you're by, I think Whitefish Bay is over there, and here's the
not until you get
so
up
there
into
you go.
Yeah, right here.
So this is I forget where this is, but it may all be farmland in that area. I know that one of the places where I shot the light pillars is nearby there, Alcona County. And the areas out here do get pretty dark. But if you go across the bridge and go a little bit further north,
yep,
you can get into some Bortle 2 land up there too.
That area,
I think if you
that area east of Grayling or Gaylord there is Indian River. Yeah, right there. That's Indian River. We used to go camping there all the time, take our telescopes up there.
I'm not sure everybody can see my screen other than the participants.
I can. That's a nice.
Yeah, we can see it. Yeah.
Yeah.
Good.
I don't know if it's being broadcast out though.
Yeah, I can see it on the YouTube stream.
Yeah, it's being broadcast.
Yeah, I can see it on the YouTube.
Yeah, the headlands is in that area that starts to get dark to the north, the northwest. The headlands is over there, but as you can see, that where I shoot in the thumb, that's where Point Albarky's lighthouse is. It's basically up there in that eastern part of the thumb. There's a few spots that they're Bortle 3, but they're surrounded. So if you look straight up in the sky, you see all the stars, you see some structure in the Milky Way. You won't see any color. You look toward the Canada side, you look behind you, there's some neighborhoods. You're kind of surrounded by light, and it lowers the Bortle rating. Well, I guess opposite. It raises the number on your Bortle rating to Bortle 4. You're in Bortle 4 skies. You're still pretty good for observing, and you're definitely a lot better than anything in Southeast Michigan. There's a little oasis down here, Lake Hudson, where I took some shots, but it's been getting worse and worse because the light domes have been growing from surrounding towns. It's a dark sky preserve, so I think Bortle 4, Bortle 5, on a great night at Lake Hudson, it gets to Bortle 4. And you can see a little bit of Milky Way there. You can, if you image it, you can pick something up, but there's a lot of light coming from some neighborhood towns. That northern view is not good at all. So you get a little bit better southern view at Lake Hudson. And,
I like how you use this as a map. I do Cape Cod up here, and this is Cape Cod. So, yeah. We say, okay, Hyannis is down here, and the Provincetown is up here, and Boston is in my ear. So
yeah, you have to use a lot more. We just use our hand. It's a lot easier. It's a little more portable. The whole body to show Cape Cod.
That's right. All of Massachusetts.
It's all year. That's interesting. Good to know.
Mark, you had some images that you wanted to show us.
Yeah, first of all, I want to say I'm honored to be on the same screen. I'm Mark, by the way, Mark Helton. I live in north of Boston. I was living in Boston before the pandemic, but I live.
You got to show us the.
Well, let's see. I'm up here. I'm here now because I'm up near New Hampshire. I'm in Ipswich, Massachusetts, which is up the coast past Gloucester, depending on how you pronounce it. I am actually from the Midwest originally. I'm an Ohioan, Cincinnati, and my sister is a professor at Michigan State. So there you go. Not Michigan. So
right.
For all of you,
Michigan. Yeah, there's lots of points that you're losing here because I also root for the Yankees, and
she's an opera.
She's going wrong.
She's the head of the opera departments there, so she every time she looks over at the stadium and they put a new luxury box, she goes, "Oh, there's my new opera theater that just went into the luxury box." So
yeah.
But anyway, it's an honor to be on the screen with all of you. John, I saw you talk the other day, and I am also a member of AtMob here in Boston. And I had heard that you were a member of AtMob, and that's a great group of people. They're just about to open our observatory again. There's about 10 telescopes, the biggest being a 25-inch, and then they just installed a new telescope. It was donated by a former member. I can't remember the size of it, but it's going to be used for variable star observation, and it will be available to pretty much anybody. It's going to be, it's remote based. It's not installed yet because the MIT is not letting us put it on the property yet, because we're near the Haystack Observatory is where our observatory is. And so you'll be able to literally, the top will open up and it'll rise up, and it has a flat, we just figured out how to put a place to do flats at the end of the night. And it's designed, even though you'll be able to use it for regular observing, it's also designed for variable star research. And I can't remember the size of it. It's pretty big. I think
I know. That's probably the telescope that belonged to the late David Middleman. Is that the name?
It is the Middleman. Yes, yeah. That's the name.
David Middleman was the manager for a while, one of the senior managers in charge of the Harvard endowment, of all things. And when I was teaching back in New England not so long ago, I met this fellow who came to an adult education class that the school I was teaching at had encouraged me to run.
Yep.
And it was just a 3-night thing, but David Middleman was in the audience, and he gave me his business card at the end, and he said to me, John, you have a lot of texture and color. I took that as a compliment. I didn't know this guy at all. That's what he said, and I thought it was funny. But it turned out he wanted to hire somebody to help him learn astronomy. He was a very wealthy financial guy, and he had become a hedge fund manager after his success with the Harvard endowment. It was all pretty spectacular. And I ended up going to work for him, and my family and I moved to Colorado, where I ran the nice observatory that he had built in Colorado. But then, unfortunately, he got cancer and died very suddenly. But in the same way, a person might hire somebody to train their horses or teach them to ride. I had the amazing experience of working for David Middleman to help him progress in his astronomy interest. And after his death, I think that was a 17-inch plane wave.
I think it is. Yes, that's what it is. It's
a Paramount, and that whole observatory was on the roof of his house in Dover, Massachusetts, that his family decided to sell after his death. But he was an absolutely amazing man, and he was involved in many other astronomy things. But I was very lucky in my association with him for altogether about four more years.
Well, you should know that the telescope is going to good use. It's actually in kind of a container now, and that container is going to be, they've just built it and designed it to be totally remotely used. I don't know how the access to it is going to work. It's through the club, but I also think that there was part of the agreement. I'm just a member of the club. I don't know a lot of inside stuff, but I think that it's going to be available to other people to do research with variable star research.
I believe it. It was a nice robotic system. The observatory, the container it's in was really a little roll-off roof observatory. He had the whole thing on top of his house. Yeah. And Alan Slisky was the man back there in Massachusetts who designed the system for him. So, but a lot of fun. He was a great guy, and his family foundation is continuing to do a lot of things to benefit astronomy in various quiet ways. But talking about Boston ATMs and their observatory there in Westford, Massachusetts, when I was relatively recently back in Massachusetts area, New England area, it was really, really fun going to the clubhouse that the ATMs of Boston maintain, because that club was one of the all too few, I think, in the country nowadays that still is running a very, very vital mirror making program. And my daughter and I were grinding and polishing mirrors together in the clubhouse out at Westford. And you could go out there almost any night of the week, and there would be people there and a level of vitality there and friendliness, a happy social scene. And again, like at Stellafane, a spirit of community. And for the sake of telescope making, people talk about telescope making becoming passe because telescopes like the ones that Scott offers for us are so wonderful, and it's just true, but yet it's so compelling in its own right to learn how to make optics. There are some places where you can still go to do it in a group effort. That's one of them.
It's interesting, yeah, because I've been into astronomy my entire life, and I tried to build my own 6-inch telescope when I was probably 15 years old, and I didn't have any mentors back then, and I gave up. I had designed a nice kind of Dobsonian style telescope that I found in books. This was in the early 60s, but again, I couldn't figure out how to grind the mirror properly, and I didn't know how to, so I kind of gave up. Peter, I wanted to just show you a quick photo I took. If I can, let me see if I can share my screen. Make sure I share the right one. All right, can you see this?
Yes.
That's M3, I think. Yeah, M3. I took this the other night. I thought, because I kind of was feeling like, well, globular clusters and clusters aren't getting any love. Everybody likes to look at galaxies, and I have the galaxy photos and everything, but this is with a 6-inch Newtonian. I have a ZWO ASI 533 that I just got. I'm kind of a beginner at this. I'm a professional television cameraman. If you've watched TV in the last 40 years, you've seen something I've done. I've worked on Antiques Roadshow and Evening at Pops and Ballroom Dancing and Zoom and tons of TV shows. But astrophotography is a brand new world for me, and I'm learning. I've started to do my own processing finally. I've had a friend that was been helping me, but I've actually been doing my own. So, but I thought you would appreciate this, having, I don't do too much planetary yet because the 6-inch scope doesn't really do well for planetary yet, not without a Barlow.
Mark, if you don't mind sharing that file with me, you can dump it in the chat, click file and send me that file. And I keep a big folder full of, excellent amateur photos of globular clusters.
Does this one pass?
Oh yeah, sure. And to be honest, of course, I also keep photos that aren't excellent just to show them for comparison. But
well, I share on Instagram now. I'm not a big social media person, but because I've been, in fact, Jason left, unfortunately. I don't know, or maybe he's still here, but the vast reaches, I just am blown away by his work, and the guy his work with the sun, and even some of his nebula work is just blows me away. And so I've been learning so much by just sharing with other amateur astrophotographers, and then with all of these star parties that Scott has been doing, I've just learned a lot. This was Comet Neowise. This was taken just down the way from me. I live very close to the ocean here. This is actually called Plum Island Sound, which is up near Newburyport. And I guess the gentleman from Michigan left, but this is, I'm in Bortle 4 skies here, but this is the sky glow from Newburyport, which is, and then actually I'm looking kind of up the coast of Maine. So when you look out over the ocean, you think, oh, I'm looking into nothing, and the next thing is Portugal. But actually you're looking up towards Nova Scotia and all of the coast of Maine. So we get the sky glow to the north, and then to the south, I have my view out my window here, I have 180 degrees from west to south to east. but I've got nothing but the glow of Boston. So when I'm going into galaxy season, which is now, everything's low in the sky, all of the good galaxies. So that gets a little tough, but yeah, this was with the Sony. And then this is the Rosette Nebula, which I took. And then that's the Crab Nebula, which I got the other day. And then now you said, I love that. This is my favorite galaxy. Bodhi is definitely my favorite. I took this one the other night. And then M82 here. And then this is not the best because I can't get rid of the noise. I'm getting better at getting rid of the noise in the photography, but M51A. And I don't know what there's a little galaxy right there. But as you can see, I do I do the sun as well, and these aren't as good, but this is just with just a regular white light filter. So anyway, I just wanted to share some of these and say that it's just really fun watching all of you guys. It's just been amazing to I echo what Cameron was saying. It's just an honor to meet all of you guys and be able to talk to you and watch you and learn from you. So thanks for letting me share.
Have you on as well? Pekka's there in mission control.
All right.
Hey, Pekka.
Pekka.
I finally get to see you.
Hello.
Nice backdrop. Good stuff.
Can you hear me also?
Yes.
Oh, yeah, loud and clear.
Good. So I made it. I just say hello to my doctor and gave him a tissue with a blood sample from my nose. So you will have to find.
So it's noon. It's noon, right, for you?
No, it's morning. It's 8 a.m.
Oh, 8 a.m. I got it wrong. You're 9 hours. Yes, right.
Yes. Nice to be here again.
Yeah.
I tried to get some sleep, but no. I have this will take a couple of minutes from me, but I will stick on the same topic that has been up today already, light pollution. And I have just now realized that because I have done astronomy for a long time, but in my childhood it was on Portal 9 in Finland, in the deepest forest you can imagine. That time the winter was really winter. We got minus 30 degrees was the normal winter. 1.5 meter snow was very normal. And I don't know how many of you have seen your own shadow on a full moon.
I have, sure.
Yeah, because today I can't see it.
Oh, no.
On this light pollution, it's no chance. Barely can see the full moon today.
That's a good test of light pollution I hadn't thought about.
Yeah.
If you can't see your shadow from a full moon, that means that the light is brighter than the full moon. And that's actually a very interesting test. How deep of a shadow can you see? It might be interesting to come up with sort of a Bortle shadow scale.
Yeah, moon scale. Yeah, what I will share today is some DIU project I have done because we have a lot of cloudy nights. So there is no possibility to make some astronomy. So I'm sitting inside and do some DIYs, do it for yourself projects. And Kent, you saw my video, the sound behind. Is it properly to show the video, or should I show only the pictures without the sound?
Show the video with the sound. It shows your creativity. Go ahead.
Okay, because the sound has a message. Very deep.
Then just show the pictures then, if that's what you got to do.
Yeah, but the sound is what they say on Apollo 8 mission.
Yeah, about light.
Yeah.
I thought that was an interesting juxtaposition between light pollution and and the
because
Christmas
we are
message.
already now messing with the night sky. We are messing with our rainforest. We are messing with our seas. We are messing with our with everything. And now we are destroying our nights. So I will show the video and if there is some questions and so on. So let's see if I can find the video there. And
to set the stage, Pekka has a light outside of his apartment, and he's created a unique way to extinguish.
And this is a version 2.0.
That does not involve a BB gun.
No, yeah, this is a version. Rod. Yeah, and this is a version 2, upgraded version of it. Oh, let's see if I can. Wait, I have to share first.
You have to share first, yes.
Yeah. Post that, and then I have to move this. Let's see. I will close that and move that. Let's see. Share screen. And which one is it? That one. So, and now I don't get back anymore to share. Oh, is there? I will share this and then I will start the movie. Okay? Do you see it?
Yes.
Moon video. So we see your icons, your thumbnails.
Oh, it's thumbnails.
Yeah.
Okay. So let's see how I looked at this, and then I open this, but I have to move it from here somewhere. No, I can't. Let's see. I move this screen. Oh.
Yeah, I think you probably have to go into a window, make it instead of full, and then drag it over to the other screen.
I saw it. There. I will start it from the beginning.
There we go.
There we go. Okay. How's the sound?
Yes. We hear you.
But not the sound from the movie.
No.
Okay, how do I do that? Because that's how do I share sound from shared video?
When you go to share your screen, unshare for just a minute.
Okay.
Go back and hit share, and then there's a little checkbox that says share system sound.
Share sound. Yes. Thanks, Scott. Thanks, Scott. We start from the beginning. Now then. And play. Sorry.
Now approaching lunar sunrise, and for all the people back on Earth, the crew of Apollo 8 has a message that we would like to send to you. In the beginning, God created the heaven and the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light." And there was light. And God saw the light, that it was good. And God divided the light from the darkness. And God called the light day, and the darkness he called night. And the evening and the morning were the first day. And God said, "Let there be a firmament in the midst of the waters, let it divide the waters from the waters. And God made the firmament, and divided the waters which were under the firmament, the waters which were above the firmament. And it was so. And God called the firmament heaven, and the evening and the morning were the second day. God said, let the waters under the heaven be gathered together into one place, and let the dry land appear, and it was so. And God called the dry land earth, and the gathering together of the waters called he seas. And God saw that it was good. And from the crew of Apollo 8, we close with good.
Okay. That was it. And
we think it's your setup is so has so much ingenuity in it. You know, he's out there with a fishing pole.
Yeah.
You know, lowering these things down onto the lights down below.
Yes.
You know,
and this one is a little bit heavier, so I haven't tried yet.
Okay.
But if it's too light, so the wind will catch it, I will buy some 50 centimeters of chain and tape it inside. So I have, so it's going down. Or I will mount an small camera, pointing camera, so I can see downwards, like cranes have, so they can pinpoint the lamp. But I have 2 more small
so you lower those from your apartment down over the lights to block
from balcony, yes.
Oh, that's clever. I like that.
Got good aim too.
Yeah.
And the lights are about 3 meters from the balcony rail, so I have to come out from the balcony 3 meters.
That's clever. I like that.
It's the only way, because I want to run down, put it on, and then run up and see that, okay, there's close. And
how do your neighbors react to this when they see these buckets?
They know it. They know. I have gone round to everybody and told that, because I told the woman who lives downstairs that don't be afraid if there is a guy meeting around in the middle of the night and turning off the lights. I think this is the better idea.
Awesome.
I mean, I've seen some clever things on these star parties. I tell you,
he gets an award for this.
Yeah, that's definitely
there is other. Let's see where I have them. There is 2 more. Let's see how I can share. I share whole.
I mean, there's a book idea for somebody is doing all of the odd things that people have come up with to deal with all of the things that we all have to deal with. You know, It's like in my business, in the TV business, it's 1,001 uses for gaffer's tape or duct tape, you know, and how to figure out how to get rid of light pollution. That's it.
I have also problem with the sun. We all have, and that's heating up our gear and mount. They are black usually. Cholesterol is black, and if you have it in the sunlight, it's getting hot, and the grease inside will melt and drop down, and you have to, you know. But I will show you some this fabrics I have used is that fabric you put on your window shield in your car for summertime. So I have put it on my computer room in my balcony. So there is a mini PC for steering. Can you see it?
Yes.
Yes. So this is first tarpaulin, and then over it's this silver folia. So it's reacting. It is so good reacting signals that I don't have a signal to the temperature sensor inside. So I have made a small window so I get the signal. This is my new mount cover made of tarpaulin, and there is a small window because I have a small fan on the ground level here, so putting up the heat from the window. And when it closes, it's rain cover. This is my logo for my observatory.
I don't know, Scott, that looks marketable.
This is also from window.
I'm serious. That looks like, you know, you put a little Explore Scientific brand on there, and
yeah,
you know,
it's 3 of them, and the cost for this is 1/15 of the cost if you buy from. I want to make some competition with the manufacturers and dealers, but now I can spare some money to buy a better mount from Explorer Scientific and my 128 ED.
And we would take far away from Pekka, so I don't want to do that.
Hey, Pekka.
One thing I would, if I could have a second, one thing I would like to say about the recording that you played just now, is that some of us in this group are old enough that we were there when it actually happened. I was sitting with my family, my parents, and I think my sister. We were all watching the thing, and it says live from the moon.
Yeah.
And we heard what was going on, and Walter Cronkite was saying a word here and a word there, but most of the time he was just quiet and watching the events unfold. But when they said, then they did that reading from Genesis. And at the end, when they said, Merry Christmas to all of you on the good earth.
Yeah.
I mean, we were all crying. That was just.
Yeah, I can understand that because it has moved me too. And I have studying quite a lot Apollo 11. And because Apollo 8 and this statement, when he was reading this, there was a pastor or how do you say, priest that was make it suit the whole country, United States of the USA, because there was he was Mandolin Murray O'Hare, founder of American Atheist, responded by suing the United States government, aligning violation of the First Amendment about this.
That's really true. And you have to do that. And the founding fathers wanted to keep several miles between church and state, but sometimes you just got to say, what the hell? And this is one of those times.
Yeah.
And
but
I think that our country has a lot of good things going for it, but it also has many, many problems that we're dealing with right now.
Buzz Aldrin was ready to read something from Bible. Meanwhile, Armstrong was climbing down the stairs from moon surface, and he contacted Houston, and they told that keep it a little bit
short and to the point.
Yeah. So he had his ship and chips and wine with him, but he couldn't read it from the Bible because they didn't want of this suiting and law stuff. Again,
I was what, 10? I think I was 10. I remember watching it on our black and white television where the tube was slightly tilted, so everybody tilted their heads to watch it.
Yeah.
The tube was never mounted right, and
yeah,
I'll never forget that.
Yeah,
Pekka, how much difference does that reflective material make on the interior temperature? Have you measured?
Not without my tarpaulin under, so I have to check because if you can see, I have both. So this is just for testing and knowing how I will, how do you say, turn out, and because you have to turn over and out and tape inside and so on, so it will fit on one shot down. So I haven't, we don't have had any clear days so I can test, but I probably 5-6 Celsius degrees, because it's from east, south, and west, and this is open because it's for north, and we never get. I could just cutting up the whole thing to get in some fresh air, but I want to decrease the humidity too, because summertime here is the 98% humidity, and wintertime is only 30.
What part of the world are you in again?
Sweden.
You're in Sweden, okay. Are you near the water? Are you near the ocean, or are you interior?
No. I'm in suburban, and it's about 10 kilometers to the water.
Stockholm, right?
Yeah, Stockholm. Yeah.
Oh, okay.
So I'm living a little bit in inwards land, about 18 kilometers from coast.
But you're still close enough to get some of the humidity.
Yeah. And this building area I'm living, it's built over an old sea bottom. So it's mud. So when they poled, they have to pole first, because before they build, I think they got 30 meters underground.
I live very close to a large marsh here, and I've had beautiful clear skies, and I've been looking up, and all of a sudden I noticed that my images are getting dimmer and dimmer and dimmer, and I look up and the stars look great, but the fog has lifted.
Yeah.
And it just sits right at the level of I'm about 30 feet above sea level. So it just sits right at about 30 feet, and I can't see a thing. It's like I've got 10 feet up and I could have perfectly clear skies.
We have problem with smog and so on only 2 times a year, but the downwards Sweden, in the coast to south, they got problem with that one. So Kent.
I've got to go to bed. Scott has permission to come in late, but Kent does not. So
Thanks, Kent.
Hey, good to see everybody.
Thank you.
Always a
great
pleasure.
start party.
It was great to
Stay in
see you
touch.
tonight. You take care.
Thank you, David. Bye, everybody.
Bye. I have a question to David, because I have heard that you have a dog and a beagle.
We used to have a beagle.
Okay.
Actually, when Wendy and I got together, she had 2 beagles and an Australian shepherd.
Okay. Can you recommend it for an amateur astronomer? Is it like a friend that is laying down and looking for me when I'm studying and doing astronomy?
Oh yeah. In fact, one of the beagles actually looked through telescopes with us.
Okay.
And that was kind of fun. I have a picture of him looking through one of my telescopes. But the latest beagle we had, which we named the Beagle, didn't do that. He didn't really go in for that.
Okay. Because
John,
I want
take care. Thanks for coming.
I just want. Bye, John.
Bye, folks. See you later.
Take care.
Thanks for coming, John.
I hope to be at Stella this year, so I'm hoping that I guess it's happening, but it's going to be a lot. They still haven't figured out how it's happening yet. I guess that the word is that it's some form of Stellafane is happening, but I'm not sure exactly.
They might be more careful with registration this year and possibly limiting the size of the turnout. But I think it's going to run, and at least there's going to be some kind of program. But since you're still hearing me, I'd like to leave by just injecting something optimistic regarding light pollution, if I may. I live here in New Mexico, and we have basically very dark skies in rural New Mexico. But so therefore we're especially vulnerable. But we had a gentleman visit our village and actually make a presentation to our local astronomers, including the mayor of the village. And he was from a light fixture company in Oklahoma. Called. Now I'm afraid I'm overtired. I've got a mental block. But it's a relatively young company, I believe, that make lighting fixtures, and Clearway or something, LED or something like that. I believe that I've seen our skies get much worse in the years that I've been here in New Mexico because of the changeover to LEDs, where the LEDs that are being chosen by some municipalities like Albuquerque, the big city in our state, they're choosing LEDs, but with a strong blue component.
Yeah, that's 3,000, I think.
Yeah, things of that nature. This fellow and his company have a new product, and he believes that the nature of LEDs that will be the appropriate color, and furthermore, with essentially no blue output, these sorts of products are coming out. And there is going to be an improvement in these things in the same way that we have something like Moore's law describing the improvement in computing power. He thinks something like that is going to apply with LED technology. And his company has invested $1 million recently in a dark sky LED that is truly revolutionary according to what he's described. And I want to believe it's true. He believes that here in the Southwest United States, we have a particular market for care with light pollution, where his company has invested to produce a technology to meet a market demand. And he is having some success with his product in Flagstaff and recently in Santa Fe. And I won't go on and on about it, but I have been discouraged by light pollution, like so many of us are. But after this fellow's very recent visit here and our interaction with him, and it's a long story and there's more to it, but I have some hope that maybe all is not necessarily lost in the long term, because there are many forces arguing for improved lighting, and there are arguably some surprisingly revolutionary technologies that will address the color temperature issue appropriately, but also to truly minimize the blue component, which he argues is so important to eliminate. So anyway, I just wanted to end on that for myself, on that optimistic note. And as I learn more about it, I'll share it with you all in this forum. Thank you all.
Okay, take care, John. Thanks for joining us tonight.
Thank you very much. And Scott, thank you for doing this.
Yeah. Yes.
Yeah. This is so much fun.
Yeah, it's great.
It's like daily food or drink. It's like water.
Well, it's funny now that I'm going back to work after being out of work for a year. It's been, I was like, oh, I'm going to miss these things now because I can't always make them, you know. It's like tonight I lucked out because my job finished early. I actually went and visited a friend who also got vaccinated for the first time in over a year. It's just amazing how liberating this is, having the vaccinations and I find it amazing that, we live in a time when science can come up with these things as quickly. One of my biggest clients is a very big biopharmaceutical company that they make all the stuff that you need to make vaccinations. So, and I've been working with them for many, many years, and it's kind of cool to see everything that I've been videotaping for all these years being used in a truly worldwide manner. So, but And I still want to see a comet from far away, David. That's something I see things floating through now I know that it's something, the comet's not going to go floating past my screen like a satellite or a meteor, but I think that's got to be the coolest thing in the world. And it amazes me that you actually saw the comet that ran into Jupiter. I mean, I remember when that happened. I remember that, when the first dot showed up on Jupiter, and it was like, oh, that's what a comet does to a planet. And then to see how far that went around the planet, and you kept seeing the trail of damage that it had done. We still don't know what is down below all of the gas in Jupiter, if there's anything solid or if it's just literally mostly gas most of the way down. But just to see that and say, thank you, Jupiter, for grabbing all those comets and keeping them from coming towards us. Jupiter's our big friend. He's our buddy. I think if it wasn't for Jupiter, we would probably not be sitting here talking to each other.
Probably not. And Jupiter is also my very favorite planet, partly for that reason, and partly because it's so damn beautiful to look at.
And I'll tell you, those latest Hubble images, the more and more and both of Jupiter and Saturn, the more of those come out, the more fascinating it gets. It's like, even in the movie 2001 and 2010, they couldn't even come close to getting I don't think art can match what Jupiter is producing for us when it comes to 1960s psychedelic art.
Actually, Mark, with all due respect, and I agree with you, but I think that the artwork in those movies almost matched what we're seeing now with the Hubble. That was, especially in the original movie, it was superb artwork that they did. In the
no, trust me. I 2001, and it was, I saw that when it first came out on Cinerama with my dad. And I think that was I think it was 1968 that came out. So I would have been 10 or 11, 11.
Well, I can kind of see what you're talking about. I mean, look at this is from the Juno spacecraft. Oh, that's
no, not that. That looks like that's
this work of art. Okay, there we go. Well, look at this.
I know, it's just phenomenal.
It's like marble.
Yeah, look at that. Art can't even. No, it's just phenomenal to look at. It's just phenomenal. And I will say, I followed the conjunction of Saturn and Jupiter. I took pictures of it all the way. And it luckily, the day of conjunction, it cleared just in time for me to get. It was literally, it cleared for an hour, and I ran out and set my telescope up, and I aligned it as close as I could get so that it could track. Yeah, just phenomenal. Speaking of psychedelic, Scott, before we all leave, can I show one last picture?
Sure.
This was something I took the other night, and I think you'll enjoy it. It's kind of funny. It's gotten more likes on Instagram than any of my good photos. All right, so let's see. Okay, so that's M51A again, and this kept showing up in my photo, and I'm like, I thought, well, maybe I'm looking at my house, because sometimes when I get the house in my frame, it'll show up as like a blob in the foreground. And I went outside, and the scope was pointed straight up, because M51 was like 2 a.m, and it was pretty. And I'm like, no, what am I shooting? Well, I have 3 USB-C cables that are powered running out to my scope.
Okay.
I'm not doing Wi-Fi, so I run USB, 65-foot USB cables out, and the light from the USB cable was lighting up it's a red LED, and I haven't taped them over, and it was lighting the bottom of the mirror.
Jeez.
And as the scope was kind of slewing around this, I love this picture, to be honest with you. I think it's, just from a wacky artistic, I thought it was kind of funny, but it just goes to show what, the things that we run into as amateur astronomers and astrophotographers.
Right.
That's a great picture. It's
Yeah, it
just
was
wonderful. It has so much character to it.
just fun. Yeah, it's,
So David,
Yes.
when I was giving my presentation and I showed my telescope, our telescope, you mentioned about it being connected with Scott. Does Scott actually know the story of how it came to be where it is today? You didn't want to tell it because we were running late. Do you want to tell it now?
I think you might want to tell it. I think that I'd be happy to, but why don't you tell it, Peter?
Well, I don't know what part Scott played in it. All I know about is when it got to my house.
Well, I guess the only before that is that Scotty and I were talking quite a bit in those years. Scotty was working with Meade with John Diebel, and I remember telling him that I had a friend in Ontario who would like to get him a decent telescope, and right away you suggested a 16-inch Dob. And with the cardboard and everything, it kind of made its way up to Canada, and Peter got it. And it was kind of okay until Mike Haynes was able to, with working with you, really turn it into what it is now.
Yeah.
But I've told you a part of the story that really is leaving out all the good stuff. So why don't you tell us the good stuff?
Well, there's a lot of good memories with every telescope, of course. But I think what ended up happening, the Meade Starfinder, the 16-inch version, had those black pucks on either side that, for the altitude bearing. And
remember that, Scotty? Yeah.
Yeah.
I see you nodding. So there was one screw in the middle of the puck to hold the puck to the side of the telescope. And, within a year, it got to the point where you'd move the telescope and the pucks wouldn't move. That screw had gotten, so weak that, the pucks were grinding into the cardboard. And so one of the first things we had to do was put a little bar on the inside of the telescope tube with 2 extra screws on the outside on each side, right? And that held it down perfectly, made a huge difference. So anyway, that was 1995. And, I used the scope for something like 12 or 13 years before Mike Haynes had built a couple other scopes. And I was really liking those low profile, Dobsonians with the truss tubes. And one of our club members who likes doing optical testing and stuff, he took the mirror into his basement and put it on the Foucault tester, and it was really, really, really good. He said it was one of the best mirrors he'd ever tested, and he wanted to know where I got it. Well, of course, I told him the story, and then he said, yeah, because on the back in black magic marker it says Levy. We all thought that would be that was probably had something to do with why it left the factory in such good condition and such a great figure as all that. Anyway, that was when we decided to upgrade it to the low profile thing.
Yeah, very cool, very cool.
It is a wonderful telescope.
Still used today? You still use it?
Yeah, it's right here. It's disassembled when it's in the office here, but I can take it out on the deck and set it up. I haven't done it lately. I just feel more lazy these days, I guess, but it's still just as good as it ever was.
Yeah, the guy.
Peter on the
20s mirror, his name was Phil, and he was just that guy just had a knack for making great optics. He's one of the unsung opticians of our day, and sadly he took his own life at one point. But he did those optics.
Oh, I'm so sorry to hear that, Scotty. That's a part of the story I have not heard yet.
Yeah. That was a shame.
Maybe you could tell me a bit about him sometime.
Yeah.
But Peter, will you be taking it out on the 26th of May?
Okay, I'll say yes.
Okay, because there is a total eclipse of the moon that night. And you might be not getting the whole thing where you are in London, but we do here in Arizona.
Yeah.
But I think it's going to be worth setting the 16-inch for it.
What time is that one happening? Do you know
Let me just check the handbook.
Because I had heard something about that. It's total eclipse. Oh yeah, I
Oh,
should have my book, but I didn't get that this
Well,
year.
Peter's got it, so he's going to look it up and give us the times.
Well, I don't know how to read the times. There's 6 million times in here. I'm never sure which one is the one you might be interested in, but you might be able to read that chart right there.
No.
What is the what time in universal time does totality begin?
It says moon at greatest eclipse contacts, 11:11 UT.
Oh, 11:11 UT.
Yeah.
Oh, so it's the end of the night. Sorry, Peter. That means we have to stay up all night.
Yeah.
And then that's really going to kill a lot of the interest, I'm afraid.
So U1 is at 9:44 UT.
So
That's when the partial phase starts.
That's 6 hours for me here in Boston. So what is that? That's
So 3:44.
Yeah.
For you and me.
That's you're in Ontario?
Yeah.
Which part?
Southwest.
Okay.
Halfway between Detroit and Toronto.
Oh. I love
Canada. Yeah, you can see in the chart here, it's got the regions.
Yep.
And it says for the Western United States, it says eclipse at moonset.
Okay, so it'll be right down on the western.
Right.
That'll be, well, that could be a nice shot. I might have to just stay up for that.
You have to go, yeah,
or get up. Either get up or stay up.
Yeah. On the east side, on the east side of North America, I guess we just get the tail end of the eclipse, or I guess it's just starting when the moon sets. Right. That's the way to read that, right, David?
I think so. Yeah. I got it backwards, but I'm a backwards kind of guy. So
the Hawaiians get to see the whole thing.
Peter, one of my favorite pictures I took, this was, I think, 4 or 5 years ago, was the blood moon. It was one of the, what do they call the eclipse where it's not a total, is it a blood eclipse or something like that? But
it's
I could,
partial.
Yes. In fact, actually, one of the other favorite pictures I took was the night that the Red Sox won the first World Series that they had won in 60-something years. I was living just west of Boston, and I took a picture of the blood red moon, and it was literally, it went eclipsed right when they won the World Series. Most people don't know that happened, but it was literally, they won. I walked outside, I looked at the moon, and it was blood red, and it was like,
yeah, that's cool.
It is. I mean, it was like, wow, that couldn't have happened. I mean, I'm from Cincinnati, but I'm a Red Sox fan now. So, but the other picture I took that I love is Peter, is I got one with the beehive cluster and the not total eclipse, but it was, another one of the blood eclipses with the beehive cluster right next to it. That was kind of cool.
Yeah. So that eclipse you're talking about, Mark, was 28th October 2004. It was the first time that a lunar eclipse ever took place during a World Series game.
Yes, and it literally went total right when they won. I kid you not. I watched it. I watched the last. They were running up the. I walk outside the door. I look up and I'm like, oh, I can't believe this. This is like,
It doesn't feel like that long ago. I'm surprised I don't remember that, because I do remember them winning it. It was 86 years, Mark, not just.
Oh, no, that's right. 86. Cause I can't remember. The Cubs was something a little longer. But anyway, that was kind of a cool astronomical event that not a lot of people know, that the two kind of timed out with this wonderful sports event.
Yep.
Another one for a book.
Actually, our women's basketball team came within 1 point of winning the championship this year.
That was really close. They were outmatched. Stanford had a better team.
Yeah.
They played really great. It was.
Yeah.
Oh,
we had a pretty good team though.
Where are you, David? You're out
I'm in
west.
Vail, Arizona.
Okay, which is close to what?
Close to Tucson.
Oh, okay. My cousin used to live in Tucson. I've been to Tucson a couple times. Hot as it was like, we did an Antiques Roadshow there many years ago, and I remember walking out of the convention center to go to lunch, and it was like opening a stove. It was like, oh my God. Because it's dry heat though, you're not gonna,
Walk
I like,
slowly.
yeah, I like dry heat.
Well, you'd love Tucson then.
Yep.
No, Tucson was a very nice town.
Mark, have you been in Finnish bastu sometime?
In where?
In Finnish bastu. It's like a room. There is you throw water to those heat stones.
Oh yes.
Have you been in the real Finnish in Finland?
Oh no, I've never been to Finland. I'd love to go over there.
Okay, because the temperature it's so dry air, so it's different in here in Sweden. In Finland it's real.
It's dry in Finland. That's interesting.
Yes. Yeah, because the heat is so dry, it can be up to 110 degrees.
In Finland?
Celsius.
Yes.
No, we're talking about in the sauna.
In the sauna.
I'm like 110 degrees in Finland?
Yes.
I'm like, wait a second, I knew we had climate change, but
it's so dry, the air.
Yes.
But in Sweden we have 50 degrees, but it's so humidity, it's so wet the air, so it's enough.
no, that's what I want to go up to your area because I want to go I want to see the Northern Lights that way. I've seen them down here and I've seen them up in Maine, but I want to see them.
Yeah. And then you have to try the real Finnish smoke sauna.
Oh boy.
Yeah, it's totally smoke in there.
That sounds like some of the Michigan bars I've been in.
Yeah, and afterwards you have to jump into the snow, and swimming in the snow, and then back to sauna. It's like torture yourself, but it's clear your mind.
No, I've done that skiing. I've done that up in Maine where you run out of the sauna and you go out into the snow and roll around in the snow and then run back.
Yeah. It's so clear afterwards in your head.
Peter, you're up in Ontario. You're it's, although you're not super north there.
No, our weather's not too awful bad. And we had thank goodness we had a less harsh winter than normal this year. Because I promised myself when I retired 4 years ago that I would never spend another February in Ontario.
That sounds like most Bostonians. Like, we're not going to be here. And then everybody goes, oh, but the summers are so nice.
Well, I don't mind being here through most of the year, but the winters, as I get older, I just don't like it. So being here this year because of the pandemic really cheesed me off. And I hope I get to go to Hawaii or Tucson next winter.
But you send all your snow to Buffalo.
Yes, we do.
It's like all that water that comes across the lake and the cold air blows over the lake and Buffalo gets dumped on every year.
Yeah, we love watching Buffalo local news.
Yeah, right. 7 feet of snow. It's like, oh, it's a dusting.
I grew up in Niagara Falls, which is even closer to Buffalo than where I'm living now. And, that growing up, that Buffalo was always fun to talk about.
The Canadian side of Niagara Falls is absolutely beautiful. Yeah. Driving up the Niagara River on the Canadian side is such a different experience. And every time I go if you talk about light pollution, every time I go to Niagara Falls and I see the statue of Tesla, and I think if you were to have taken a picture of Earth from space back when he was alive, he and Edison, and if you watched the electric path go out, it all started basically, probably not everything, but the majority of it started in Buffalo.
Right.
Or that area. And you think about that one,
Have you been here lately, Mark? I mean, one of the original power plants from 1902 or something like that, which was closed about 15, 20 years ago, is now being reopened as a museum.
I think they were doing, I shot a story up there a while ago for CNN, and so that was maybe 5 years ago. So
yeah, as far as I know, this is a fairly recent development. It'll be open to the public in the summertime this year, provided the pandemic doesn't interfere with that as well. But you know, I mean, the plant is beautiful, and most of the artifacts are original, going all the way back 100 years.
I just
going to make an absolutely fabulous museum.
It would just be phenomenal to have, like a Star Trek thing where you're looking at Earth and you watch, you know, that web of electricity just go around the Earth. Just fascinating.
Of course, if we'd had satellites back then, we probably wouldn't have needed the electricity.
You're right.
The clear sky should be a tourist attraction. So only buses to the Bottle Tree area from Stockholm could sell a lot of, because I myself, I have not seen Bottle Tree sky on 10, 15 years. And then my son built a cottage in the middle of the Sweden somewhere. And I visited his cottage in November. And when I saw that sky in the middle of the night, I couldn't orientate because I saw so many stars. So I didn't know what star was what, because there was...
That's a dark sky.
Yeah. And I was totally blown out. I was like in shock a couple of minutes.
I will say that I'm more positive as well with when John was talking about that company. And you know, we have people here in our club that are highly active in the International Dark Star Association, and there's a lot of people who are doing a lot of lobbying, and they're starting at the local level and at the local towns to get them to switch. You know, the problem is when these towns get sold LEDs at a very low price, they're not necessarily looking at the color temperature of the LED and saying, you know, oh, this is not good for humans. It's not good for animals because it really messes up your clock. They're looking at price, and somebody comes to them and says, hey, you can switch to total LED for this price. And they're going to go, oh, great. I can sell that to my mayor. I can sell that to my town council.
And the operating cost is at least as important as the capital cost, because the LEDs are so much less expensive to light.
But then the health part of it did come out, you know, within the last few years, where they, you know, literally doctors are looking at this and saying, this is not having a good health effect on people. And so now the towns are actually, you know, people are coming back in and saying, well, we can sell you, I think it's 4,000 degrees Kelvin. Because blue is on the blue is on the higher, like 5,600. I have to deal with this as a lighting guy. So
but don't they use reverse? The spectrum is reversed for lighting. In other words, cooler means bluer.
Right, but yes, but 5,600 degrees Kelvin is considered blue light.
It is? Okay.
Yeah, because 22 is warm. So if I'm lighting, like the lights that are in my room right here are around 2,200 degrees Kelvin.
Yeah.
Daylight is 5,600 degrees average.
And we call that cool.
That's considered cool. So daylight is considered cool light, which is why when you look at a house from outside, it looks warm. It looks brown or dark, you know, tan. So, yeah, I have to filter, trust me, to balance stuff.
Yeah, that's right. There's a scale right here. 1,000 is like almost orange.
Yeah.
Color, yeah. And 10,000 is like deep blue.
It's based on the black box, you know, heating up a black box, and it gets, you know, that's the same with stars.
Yeah, except that the terminology is reversed. We would call it warmer and hotter, whereas they call it cooler and warmer.
Yes. Yeah. So, yeah, it's fascinating stuff. I mean, You know, and I think anytime you have new technologies that start to come out and people get all excited, you know, LED was big in my business, and there's a lot of things. I still keep tungsten lights because lighting an interview with people, sometimes the LED lights don't have the quality of light yet. It's getting there because LEDs currently don't come in bulbs, and a bulb reflects light slightly differently than a small pinpointed LED light. So it's the way you filter them. And, you know, the place I was working at today had some old LED technology. And the thing is, it's red, green, blue, and you see the red, green, blue shadows projecting on the wall. So you don't want that. You want a clean shadow. So, but the newer technology, they've worked on getting that better.
That light under my balcony, it's pure LED.
Yes.
It has 100 of those square small LED.
Yeah, the micro LEDs.
Yes, and
yes.
That's killing me. And those are on day and night because they have some fault in the system, so they are on 24/7.
Oh, that's okay. They're running less energy. No, I just
So I can say turn off in the nighttime.
And that's another misconception with LED lights is that they are physically cold, and that's not the case with the bigger LED. They do put out heat because it's still, you know, electricity going through a circuit.
Yeah.
They don't put out as much heat as, say, a tungsten bulb. By far, they don't put out that much heat. So they're much easier to use in a studio because you don't heat up a studio the way you would with the old tungsten lights.
Somebody knows about electrical magnets with function with 9 volt. You know, when you get power, so they get like magnetic, and you turn off. It's like those big car destroyer machines that they have you electricity, and when they put on, it gets magnetic, and when you turn off the electricity, they got no magnets.
I love magnets. I think that's
because I'm building. I have very high street lights, and if I will use my my rod, I will have battery and then drop down the cover because I can't use a hook.
I love this. It's like that fishing. It's like the fishing game where you used to pick up the fish in the
with the magnet. But I need electricity that I can drop it down and then pick it up.
Necessity is the mother of invention, right?
Yes. You have to have a problem to come to a resolution.
That's right. That's right.
Well, gentlemen, it is getting
it's
2 o'clock in the morning here.
Yeah.
It's almost 3 o'clock. It's 3 o'clock here.
3
Yeah.
o'clock out there. Yeah. So,
9 a.m.
And our audience is going to sleep too. So.
So, Scott, are we still on Facebook? Are there people paying more attention? Really?
We're still streaming.
Yeah. Well, hello to everybody out there in the world.
Oh, wait. Nope. That's Michigan here. Michigan is there. Yeah.
Oh, there. Okay. Right.
Yeah.
It was great to have all you guys.
That's right. Toronto's
David, thank you so much for hosting this. It was awesome.
Thanks for inviting me, David.
Yeah. You're
David doesn't realize he's muted. After all these hours, he's.
And David, it's an honor to talk to you, and I hope to maybe someday be able to meet you at Stella or somewhere like that.
We're in Arizona. I'd certainly like to meet you in person too, Mark.
Yeah, thank you.
Okay.
All right.
Well, good night, everybody.
Good night,
Scott. Thank you very much, Scott.
Yeah, thanks very much.
Good luck to all.
Good night, everyone.
Good night. Bye-bye.
Bye.
Bye-bye.
Hi, I'm Nikki Cox, a spacecraft operations engineer. I've been lucky enough to work for U.S. Space Command in the commercial space industry as well, and now I'm at NASA's Jet Propulsion Laboratory working on the Mars 2020 Perseverance rover. Don't forget to visit NEAF, the virtual experience, April 10th, 2021. It's the world's largest space and astronomy expo. Go to neafexpo.com. I hope you have a great time.
Folks, it's time to say goodnight. We sincerely appreciate your patronage and hope we've succeeded in bringing you an enjoyable evening of entertainment. Please drive home carefully and come back again soon. Good night.